Hello and welcome to StudyIQ IAS English. I am your host Rahul Saigaonker. On public demand, we are in for a long haul again. Why? Because today it's going to be a marathon session again. After our discussions of NCERT Science Class 8 and Class 9 in a marathon session, today we are beginning our discussion for Class 10th Science NCERT. In this lecture or in this marathon lecture, I will be discussing all chapters of class 10 science. Let me give you a gist of what chapters I'll be discussing. There are totally 16 chapters and I'll be discussing them one after another. Of course, you are all thinking that, sir, I have the NCERT class 10 and it does not have 16 chapters because this is the NCERT before the rationalization of syllabus, and it's better to deal with that in a more comprehensive way through the old book itself, the one which was there before 2020, because you all know that after COVID-19 or in 2020-2021, NCERT rationalized the syllabus and it reduced number of chapters, but we still go with the old thing itself. So I'll be dealing with one by one with all the chapters. Chapter 1 deals with chemical reactions and then we'll move forward. So enjoy the marathon session, and if you have any queries in this marathon session, or if you have any other demands regarding sir, I need another marathon or another video, any kind of request, you can always reach out to me. You can connect with me on this particular ID at the rate Rahul Sai 222. This is my Instagram ID. You can directly message me here. This is my number also. Do not call directly. You can WhatsApp me or Telegram. There is WhatsApp also, Telegram also on this particular number. You can reach out to me there. And this is the Telegram channel which I host for UPSC Civil Services students. You can check it out, and if you like, maybe you can join as well. All right, so enjoy the marathon of class 10 science NCERT. Let's begin. As I told you, today's discussion is about chemistry, chemical reactions, and in our previous interaction in 6, 7, 8, 9 discussion, the textbooks of 6, 7, 8, 9, we have gained some insights with respect to chemical reactions, and we have established that throughout our day-to-day activities we see so many chemical reactions. For instance, right now I'm breathing, I am inhaling air, and oxygen from that air is used for breaking down the nutrients. That is also a chemical reaction. It's a kind of exothermic reaction. Or there is combustion reaction, right? Every day you go to your kitchen and you simply switch on the gas. What is happening? The gas is burning. Combustion reaction is happening. You open a bottle of Coke or Pepsi, fizz is coming out. What is happening? Some sort of chemical change is happening and a gas is released. So many reactions. You simply add lemon to your water, add lemon somewhere else, there is some sort of chemical reaction which is occurring. We have also established the nuances between physical changes and chemical changes. We have established that chemical changes are irreversible. Physical changes, for example, water changes its physical properties. It is available in liquid format, in vapor format, in the solid format as ice. It is simply changing its physical characteristic, but chemically it's not changing. So we have understood the nuances between them as well. So in our day-to-day activities, the chapter starts with this itself. Consider some following situations. Say you leave milk during summers at room temperature. What will happen? There is a high probability that it will get spoiled. And if it gets spoiled, that means there is chemical change occurring in it. If there is an iron tawa or a pan or a nail, you leave it in humid atmosphere, what happens? There is a possibility of corrosion. Rusting happens. And what is this rusting? This rusting is a chemical change, chemical process. As I gave you example, simple breathing exercise or breathing is also example of chemical reaction, chemical change. The food that we cook, what happens when we cook food? We are giving it some heat and chemical changes are occurring. Grapes, they ferment. Grapes ultimately turn into wine, right? How is wine prepared? From grapes, from fermented or grapes, when they are fermented, you get wine. So that is again a chemical change that is occurring. One chemical compound changing into another chemical compound, that is alcohol. So day-to-day life, we see so many chemical reactions: combustion, rusting, digestion, photosynthesis. So many examples are there, right? Now, what is this chemical reaction? How do we represent them? See, chemical reaction is a process in which there is an irreversible change. The reactants, they react with each other and a final product is produced. And that final product will have different properties. All right. So a chemical reaction where the reactants, and we always represented the left hand side, we represent through reactants. So reactants, they react with each other and a final product is produced where the reactants act chemically. As I told you, a simple example has been put here where you prepare a cake. Now to make a cake, what do I need? I need flour, very fine wheat flour. We call it maida, corn flour, wheat flour. We need eggs, milk, sugar. We add all these things. We put it in the oven. That means some sort of agent is also given and it transforms into cake. So food that is cooked, it is an example of chemical change, chemical reaction itself. So you see, in a reaction, the reactants are seldom recovered. So one of the ways of telling that there has been a chemical change or a chemical reaction is to look at what has happened to the original reactants. Can they be recovered or not? And many times they cannot be recovered. For example, here we are preparing a cake. The reactants are oil, egg, milk, sugar, flour. We have mixed them and these reactants have ultimately led to a product of cake. Now, can I recover the reactants back from this cake? The answer would be no. So one of the ways is to understand what has happened to those reactants. They have undergone chemical change, which is irreversible. And that is what we established in our previous discussions as well, when we understood the nuances between physical change and chemical change. I gave you an example of water. Water transforming from liquid state to ice, say solid, or liquid to gas. It is simply a change in the physical state. There is no chemical change in it. But whenever there is a chemical change, it is irreversible. Apart from this, whenever there is chemical reaction, there are certain other characteristic features which we can see. Whenever there is chemical change, there might be a possibility of change in state, meaning solid turning to liquid, liquid turning to solid, or some sort of precipitation might occur. There might be change in color. There might be evolution of gas. I gave you an example of Pepsi, Coca-Cola. Simply open the bottle, carbon dioxide is released. Some reaction has occurred and carbon dioxide is released. Many a times in many reactions, we see hydrogen gas also being released. There can be change in temperature depending on the type of reaction, whether it is endothermic or exothermic. So as I told you, chemical reaction, they lead to either change in state of substance, say precipitation might occur. There are many examples of precipitation in your chemistry labs. You must have seen. Add two chemicals. One of them, it forms a compound and precipitates after undergoing reaction. For example, copper sulfate, when mixed with sodium hydroxide, it leads to precipitation of copper hydroxide. It settles at the bottom. There are many examples of precipitation. Either change of state, or you can also see change in color, or any of these mix and match also. Now we have seen this example in our previous NCERTs also. Simply take an iron nail, add it to copper sulfate, aqueous solution. Now this is how we describe a reaction when we write a chemical equation. Then we write S for solid, AQ for aqueous, or L is also written as liquid. So iron solid is added to copper sulfate, aqueous solution. It is blue in color and displacement occurs. Copper is displaced by iron, and now this ferrous sulfate is formed in aqueous solution. It is pale green in color. Or there can be some sort of evolution of gas. Zinc, when mixed with sulfuric acid, it leads to release of hydrogen gas. There can be change in temperature depending on whether the reaction is endothermic or exothermic. If the reaction is endothermic, then there is reduction in temperature. If it is exothermic, then the temperature will increase. Or there can be some sort of odor or smell because of, say, gas itself. Now in our day-to-day life, we can see the example of egg. Now have you observed a characteristic smell or odor of egg? When you prepare, say, omelette, you break the egg, you prepare the omelette, and you simply keep the eggshells on the kitchen counter itself. You forget it, say, for a day or two, and then you will observe a characteristic smell coming from it, spoiled egg smell. And that smell is of a gas which is released because of chemical change, that is hydrogen sulfide gas. So any of these things can occur. Now this chemical reaction, how do we represent it? It is represented in form of a chemical equation. It is represented in form of chemical equation. Now this is a classic example of chemical equation. The simplest reaction is this: hydrogen gas reacting with oxygen gas leading to formation of water. So a chemical equation is a written representation of a chemical reaction. And a chemical reaction can be balanced. Now, this is an example of balanced chemical reaction. But if I have to write it in unbalanced form, in the simplest form, I can simply write hydrogen. You know, hydrogen is in form of H2 gas, and oxygen, you do not find it in atomic form. Simple atomic oxygen would be this, but you do know oxygen can only be seen in air as a molecule, O2. Now, this leads to formation of H2O. This is an unbalanced equation. Now, to balance it, I simply have to ensure that the law of conservation of masses is followed, meaning the amount or the number of atoms towards the LHS or towards the reacted side should be equal to the number of atoms or mass towards the product side as well. Now, how do I balance it? I simply write 2 here and 2 here. Now, this equation I already know, but a balanced chemical reaction is one reaction where it follows law of conservation of masses, because mass can neither be created nor be destroyed on the reactant side, on the product side, both the sides it has to be exactly same. One of the examples is again written here. Zinc, when added to sulfuric acid, it leads to formation of zinc sulfate and hydrogen gas is released. This is the simplest balanced reaction that we can see. But many a times we see that the reactions are unbalanced. How do we balance it? Again, I would say this is not very important from UPSC Civil Services perspective, but we do need to have some sort of a common knowledge about how do we balance an equation. One example is from this NCERT itself, where this iron and water reaction, it leads to formation of iron oxide 3 and hydrogen gas is released. Now, this reaction is unbalanced. Why? Because clearly you can see that on the LHS there is one iron atom, but on the RHS there are 3 iron atoms. Hydrogen probably looks balanced, but on the LHS there is only one oxygen atom, but on the right hand side there are 4 oxygen atoms. Now, how do you balance this? Step by step procedure is given. Let me just tell you in brief, and let me also give you some pointers with respect to balancing this. All right. See, first thing that you need to do is count the number of atoms on the LHS and RHS of different entities. There is iron, hydrogen, oxygen. So on LHS there is 1 iron, 2 hydrogen, 1 oxygen. But on the RHS, on the product side, the number of iron atoms are 3, number of hydrogen atoms are 2. So probably this is balanced. But to balance these two, we need to change something with respect to hydrogen also. 1 oxygen atom on the LHS side and 4 on the right hand side. So to balance, what you have to do is take the compound which has maximum number of atoms. It is the best way to proceed. So take Fe3O4, and when you take this Fe3O4, you will see, to balance this, on one side I have 4 atoms of oxygen. So add 4 wherever you find oxygen, you will see now the oxygen is balanced. Now to balance the hydrogen, I add 4 here also. Please remember, I do not change this subscript. Never change the subscript. Always change the coefficient. So the simplest way to do this is to ensure or find out odd and even on LHS and RHS. For instance, in this particular equation, if I look at iron, see, it has 1. If nothing is written, then the coefficient is 1. There is 1 iron atom. There are 3 here. Both are odd. All right. With respect to hydrogen, there was H2 here. Let me go to unbalanced equation. There is H2 here. There is H2 on this side. Both sides even and balanced also. But when you look at oxygen, here it's only 1 oxygen. Here it's 4. So you will see that on one side there is odd number and one side there is even. So simply even out. Multiply one side with 2, you will get the other 2 or 4 with the even number, whatever is required. So what do? We multiply it by 4 to get a balance of oxygen. So similarly, we also balance hydrogen, and on this side it's the odd number itself. Use the same 3 here. All right. So these are the steps of balancing that have been given. Again, from exam perspective, as I told you, not very relevant from UPSC, but simply try to follow these steps. UPSC is unpredictable. So what you have to do, always remember, you have to adjust the coefficient, not the subscript. Right now sometimes you might think that, okay, I'll simply change this 4 and I'll change something here. That cannot be done. Okay, against the rules of chemistry. So adjust the coefficients and ensure that look for even and odd and multiply by 2 to make even on either side. Wherever it is deficient, make even on both the sides. And if there is a polyatomic ion, especially like this nitrate ion, see this is lead nitrate. If it is a polyatomic ion, then ensure that you balance it as a whole on either side, on LHS and RHS as well. And finally, look for the balance of the equation, because it has to follow the law of conservation of mass. Clear? Right. After understanding the balancing of chemical equations, let's talk about different kinds of chemical reactions. Now, we have discussed some of these reactions before as well. Generally, there are 4 different kinds of reactions that we find from the NCERT book also. The first reaction is the synthesis reaction, or it is also called as combination reaction, where 2 atoms, 2 molecules, they combine to form a compound. Another reaction is decomposition, meaning one particular compound breaks down into its constituents or different other molecules. Then there is a reaction of single displacement or single replacement and double displacement or double replacement. Let's try to understand these reactions one by one. First one, simplest, is the combination or the synthesis reaction. Now we see so many combination synthesis reaction in our everyday life also. Combination means there are 2 reactants which combine to form a product. Simple one, sodium and chlorine, they combine to form salt, sodium chloride. There are so many examples of combination reactions. The hydrogen combining with oxygen to form water, again combination reaction. Carbon with oxygen to find carbon monoxide with oxygen to form carbon dioxide. Sodium plus chlorine, sodium chloride. So we find so many combination reactions in our general life. But more than combination, I would say we look at many decomposition reactions. Decomposition means a single or a compound breaking down into different products, right? See, for example, carbon monoxide into carbon and oxygen. A compound, right? Calcium hydroxide into calcium oxide and water. There can be many examples. For instance, the simple digestion process is a decomposition reaction itself, where the constituents are breaking down. Carbohydrates, polysaccharides breaking into monosaccharides, monosaccharide breaking into ultimately the elements. So there can be many decomposition reactions. The examples are here. Water molecule breaking into hydrogen and oxygen. Again, there are certain rules that you need to remember. Generally, I have written generally here. Generally, decomposition reactions are endothermic. There has to be some sort of activity which occurs, or the reactants undergo some sort of change because of an agent. I have written generally here. There is a possibility that some decomposition reactions can be exothermic as well. And the corollary of that would be generally combination reactions are exothermic. Whenever 2 things combine, then energy is released. Again, in general, there can be some endothermic combination reactions as well. Now, as I told you, decomposition is very common. Decomposition can be thermal decomposition. You simply heat a compound, it might break into constituents. There can be example of photo decomposition. You keep something in sunlight. And because of the light, there can be decomposition. For example, silver chloride. If you keep silver chloride in your window, then the chlorine gas is released slowly and steadily. There can be a possibility of electrolytic decomposition also. You apply the EMF, or you apply some electromotive force, and then decomposition can occur. The compound might break into its constituents. Apart from combination or synthesis and decomposition, there are 2 other reactions, displacement and double displacement. We call it replacement and double replacement also. It's a reaction where one atom, it replaces another. Now, general reaction is this: A plus BC. Ultimately, the product leads to AC plus B. There can be many examples. For instance, in sodium chloride, when potassium replaces sodium, it leads to potassium chloride, and then sodium is released. This is single replacement. And double replacement is when the cations, they exchange each other. That means the general reaction would be AB plus CD. It leads to AD and CB. A and C being cations and B and D anions, that is negative ions. One of the examples is here, AgNO3 plus NaCl. It undergoes a double displacement or double replacement. Na is replaced by silver and the other anions are also replaced. All right, so reaction can be combination reaction, decomposition reaction, double displacement, or single displacement. Now apart from that, it can be oxidation or reduction reaction. Now the general understanding or general form of oxidation is something combining with oxygen is oxidation reaction. For example, one of the ideas is given here that if copper oxide, it reacts with hydrogen, it leads to formation of copper and water is released. This is a reaction which is given here, copper mixing with oxygen leading to copper oxide reacting with hydrogen leading to copper and hydrogen. So the understanding here is whenever a substance gains oxygen, it is called oxidation reaction, and whenever a substance loses oxygen, it is called as reduction reaction. So when I say gaining oxygen or losing oxygen, it can also be explained through a corollary of hydrogen also. That is what is explained here. Please remember, oxidation reaction means whenever a substance gains oxygen or loses hydrogen, it is called as oxidation. So let me just write here, oxidation is a process which leads to gain of oxygen or it leads to loss of hydrogen. And the reverse can be explained, right? If it gains hydrogen, if it loses oxygen, that becomes your reduction, the corollary of that. Apart from this, there is also an example of redox reactions. Now redox reaction, they are not peculiarly connected with oxygen hydrogen, but we can explain using that logic also. In general, in a redox reaction, whenever there is a loss of electrons or whenever there is increase in the oxidation number, that process is called oxidation. Please remember, oxidation is equal to loss of electrons and reduction is equal to gain of electrons. There can be many examples of this redox reaction. For instance, here if you see sulfur dioxide and oxygen leading to sulfur trioxide, example of redox reaction. So remember this, oxidation means loss of electrons or increase of oxidation number, and reduction means gain of electrons. Now apart from these reactions that we discussed, there can be many other reactions which can be explained. Now we already discussed about decomposition, meaning one compound breaking into its constituents or other molecules. We have also discussed about addition or synthesis reaction. There can be displacement, single displacement or double displacement, oxidation reaction, reduction reaction, redox reaction also we have discussed. Apart from that, reactions can be explained as combustion. Now combustion, again, simple kind of a reaction where something reacts with oxygen to give you energy, heat and light. There can be precipitation reaction, change of state. We saw some examples. Condensation, where again change of state, something is condensed, or it can also be hydrolysis, water breaking into hydrogen and oxygen. This is just for your information. Apart from that, a very important information from NCERT is this. When a solution of slaked lime is produced by a reaction and it is used for whitewashing, that is, you use calcium hydroxide, it reacts very slowly with carbon dioxide in air to form a very thin layer of calcium carbonate, and that calcium carbonate itself, it gives you a finish. When you do a whitewash, right, when you do a lime wash or a whitewash on the wall, the ultimate product would be calcium carbonate. Slowly and steadily, the calcium hydroxide is basically used as paint, and it is painted on the walls, and it reacts slowly with carbon dioxide, giving a very shiny finish to the walls. And please remember that it's very interesting to note that even the formula for marble is also CaCO3, calcium carbonate itself. Clear? Now apart from this, chemical reactions, as I told you, they are a part of our everyday life. You must have observed these things. Whenever there is oxidation reaction which occurs in our everyday life, one of the examples is corrosion or rusting, where iron, it slowly and steadily accepts oxygen, leading to formation of iron oxides, which is rust, reddish in color. Apart from that, another example is rancidity. Now, rancidity is generally observed with oil and fat. You must have seen, especially when you open an old packet of, say, chips, an expired packet of chips, you will feel the rancid smell, where the fats or the fatty acids or oil, they are oxidized, and because of that the taste changes. Their taste changes, they become rancid. Its smell also changes, and it is not good for your health. That is why whenever something is fried, oily stuff, it is kept in airtight box. It will remain for a longer time. For instance, your chips packet, it is completely sealed. As you open it slowly and steadily, the fatty acids, they react with oxygen and they turn rancid. The taste also changes, the smell also changes. You should not eat it. All right. So that's why I told you chemical reactions are seen in your day-to-day life as well. Right. So that's basically the first chapter of our class 10. Let me end our discussion with a sample question for you. If I remember it rightly, I think this is the question from Civil Services Prelims 2014. I wouldn't say this is a direct question which is connected to chemical reactions, but these are the kinds of questions that appear in UPSC Civil Services examination, where you need to understand the differences between physical change and chemical change, meaning of chemical reaction. There is no concept of balancing the equation, but the question simply asks you which of the following is an example of chemical change or some sort of chemical reaction. Crystallization of sodium chloride, melting of ice, and souring of milk. Now, if you try to analyze what is happening here, it is asking you the example of chemical change. When sodium chloride crystallizes, is there any chemical change which is occurring? No. Sodium chloride or salt, when mixed with water, it will dissolve. You simply boil that water. Water will become vapor and it will go off, and the salt will remain as it is. So there is no chemical change. Similarly, melting of ice, it is not a chemical change, it is simply a physical change. But when the milk is soured, milk becomes curd, buttermilk, then some sort of chemical change has occurred. So the answer for this would be 3 only. Such questions do appear in UPSC Civil Services examination. So do note that you may not get a direct question, say, about a chemical reaction or something, but connected to these concepts, questions can be created. Acid, bases, and salts. As I told you, the NCERT starts with you have learned in your previous classes. It means in the 7th class, we discussed about acids and bases. So let me give you a small or a quick recap of what we discussed, because it's the continuing knowledge itself. So during our class 7 interaction, we understood regarding the tastes of acids and bases. Right? We asked the question, can we taste every substance to identify its nature? We said, of course not. We need some sort of method or mechanism using which we can identify the characteristics or the natures of those chemical compounds, and we came up with those also. But in general, we understood that bases are a little soapy when you touch. Bases are bitter in taste. Acids are more thick, and acids are sour in taste. So we established these things. In nature also, we find acidic material. For instance, in our day-to-day products which we use in our kitchen also, like vinegar, like the citrus fruits, like curd, spinach, they contain many acids. Vinegar contains acetic acid, and when it stings you, it releases formic acid into you. Citrus fruits, they contain citric acid. Spinach contains oxalic acid in it. Curd has lactic acid in it. Very similarly, there are many bases that we find. For instance, in lime water, we have calcium hydroxide. In different soaps, we have sodium hydroxide or potassium hydroxide. Milk of magnesia, it was predominantly used, or I can say it is predominantly used as a solution for acidity. And we also established some of the characteristics of acids and bases. We established that acid they taste sour. When acid is touched with a blue litmus paper, it turns that litmus paper into red or pink. Acids also react with metals to give a salt and also release hydrogen gas. Acids are corrosive. Acids tend to corrode. That is why I told you during that interaction also, be very safe when you're touching acid. And acids produce hydronium ion. Acids basically produce H plus, or the hydronium ion. In aqueous solution in water, it produces the hydronium ion. We had established these things. Apart from that, bases, they taste bitter. Bases, they turn the red litmus or the pink litmus paper into blue. Bases, they feel soapy. That means at your home, you have your bathing soap or you have a detergent soap, they are soapy, they are basic in nature, and they neutralize acid, of course. And in an aqueous solution in water, they produce OH minus 1 ions. And through this interaction, through this basic understanding, we'll move forward. We'll talk about different kinds of acids and bases. Now, this has been discussed in the 10th in very short, but let me just give you some overview of how do we classify different acids and bases. Acids and bases both are classified first on the basis of their occurrence. They're classified as organic and inorganic. Organic means one that occur naturally. Organic acids are the ones which occur naturally. Inorganic ones are the ones which we produce in our laboratory. For example, say HCl, hydrochloric acid, H2SO4, sulfuric acid, nitric acid, all these are inorganic acids that we use in our chemical laboratories for testing. Natural acids, on the other hand, they occur naturally. In nature itself, there are different neutralization mechanisms. There is an example given here of nettle plant, nettle herbaceous plant, which has that acid producing mechanism. A nettle's sting, it has methanoic acid in it. Similarly, ant sting, it has formic acid and methanoic acid in it. Lemon has citric acid. Curd has lactic acid. I told you these are all organic acids which are found very naturally. In tomato, you have oxalic acid. In tamarind, you have tartaric acid. Orange has citric acid. Citrus fruits have citric acid. Vinegar has acetic acid. I told you this. So similarly, on the basis side, on the basis of occurrences, we have organic bases and inorganic bases. Inorganic bases, again, that we use in our lab, that is sodium hydroxide, potassium hydroxide, calcium hydroxide. There are many organic bases as well which occur in, say, our human body itself. There are many other organic chemical compounds which have basic nature. Apart from this, we also categorize acids and bases depending on their strength. Now, what is the meaning of this strength? Strength means when I put acid or a base in an aqueous solution, what kind of characteristics do they show? If an acid is strong and I put it in aqueous solution, say if I add acid into a water, it will completely hydrolyze. That means it is going to give you H plus ions and the corresponding conjugate base or conjugate compound. Similarly, for the bases as well, when I put it in water, it has to hydrolyze completely and give you OH minus ions. If they are not able to hydrolyze, then it becomes a weak acid or a weak base. For instance, many of the organic or the natural occurring acids, they are actually weak acids. For instance, these that I discussed with you, the acids that we discussed just now, I gave you example of the naturally occurring, right? Vinegar, acetic acid, all these are weak acids. Strong acids are the ones which inorganically produce HCl, H2SO4, they completely hydrolyze. In your aqueous solution, they give you H plus ions. Apart from that, both strong acids as well as strong bases, they form or they become very good electrolytes. This is a very important point. They become very good electrolytes. For electrolysis, we can use them. The third way of categorizing acids and bases is based on the concentration, that is the amount of hydrogen ions, here amount of H plus ions and amount of your OH minus ions present. That way we categorize them in concentrated and dilute acids, concentrated and dilute bases. Again, if something is concentrated, it will be corrosive. For instance, if there is a concentrated acid, you do not even touch it. Many times on these concentrated acids, there is always a warning sign that it is concentrated and you are not supposed to touch it with your bare hands. If you touch it, that is going to harm you. It is going to corrode. It leads to corrosion and erosive action. Same case with the bases as well. But acids are more severe. All right. So this is the categorization. Apart from that, in our 7th standard discussion, we established the concept of indicators. Right? That is what we saw. We said that it's not possible for us to taste each and every equipment or each and every chemical, I would say, not equipment, each and every chemical, and tell the taste. If it is bitter, if it is base, if it is sour, it is acid. We cannot do it. That is why we come up with indicators. So we discussed some of the indicators, right? We discussed some of the natural indicators like the litmus. Litmus is a natural dye which is obtained from lichens. And litmus paper, if it is blue, when I put it in acid, it becomes red. If it is red, when I put it in base, it becomes blue. Apart from that, we also saw turmeric. Turmeric is also a very good indicator of especially basicity. Turmeric itself is acidic in nature. So if we add acid to it, it remains yellow. But it is a very good indicator of bases. When a base is added to turmeric, it becomes red. It becomes vermilion color. That's why we also established, if it is a white shirt and you are in a function, you are eating somewhere, and some of the food, it falls on your white shirt, it is likely that the stain that is left out, it is yellow in color. But as soon as you wash it, it becomes red in color. Why? The turmeric in that food, it has reacted with the base and it has turned red. Apart from that, we also spoke about China rose or the gudal, right? So we also discussed some of the synthetic indicators. We'll talk, but in this NCERT, we categorize indicators into 3 different dimensions. First is natural indicators. We discussed this. Litmus is a natural indicator which is obtained from lichens. Turmeric is a natural indicator. China rose is a natural indicator. There is another natural indicator which is red cabbage juice. You take red cabbage juice, it is originally purple in color. You know it is purple in color. But this red cabbage juice, it turns reddish when it is touched or when it reacts with acid, and it turns greenish when it reacts with a base. So it becomes a very good natural indicator. Apart from this, synthetic indicators, we had discussed about this. We have created many synthetic indicators like phenolphthalein, methyl orange. Phenolphthalein is generally colorless. That means in acidic medium, it remains colorless. In very extreme acidic, it becomes orange color. In normal acidic, it becomes colorless. And in basic, it gives you pink color. And if it is a very, very strong base, then it becomes colorless again. Methyl orange, in acidic pH, it gives you red orange color, but normally it has yellow color. In base and in neutral pH, it is yellow in color. So we have created some synthetic indicators as well. Apart from that, we also have another category, that is olfactory indicator. Olfactory indicators, they become very important, especially for disabled, to identify. Olfactory indicators are generally natural. We have natural olfactory indicators like onion. You have a characteristic smell of onion, right? And that characteristic smell, when it is added with acid, it does not change. But as soon as you add a base to it, onion loses its smell. It loses its characteristic smell. Same thing happens with vanilla. You know vanilla smell, vanilla ice cream, the vanilla essence. The smell of vanilla, it completely vanishes when you add with a base. But it smells. It smells like vanilla itself if it is added with acid. As I told you, olfactory indicators are very important, especially for the disabled people. They can just smell it and sense it. Olfactory means where you can identify using smell, your senses, olfactory sense. All right. So we discussed about acids, we discussed about bases, and we discussed about indicators as well. So this is a gist of indicators that we discussed. Red litmus paper, blue litmus paper, they turn opposite whenever added with acids and bases. Turmeric is generally yellow, but when we add base to it, it becomes a reddish color. That's why color changes. Red cabbage juice, generally it is purple, but when we add acid to it, it becomes reddish. when we add base to it, it turns greenish yellow. Phenolphthalein, it is colorless in acids. It is colorless in acids, but it turns pink in bases. Methyl orange, honey and vanilla. When you add a base to it, its smell completely vanishes. Now, since we established idea of acids and bases and indicators, let's now talk about chemical properties of acids. Right. Acids, how do they react with metal? How do they react with other oxides? How do they react with carbonates? Common compounds that we find in our everyday life. First thing, reaction of an acid with metals. Now, when acid reacts with a metal, it leads to formation of salt. A salt, and remember, hydrogen gas is released. I can give you so many examples. Magnesium reacting with hydrochloric acid leading to magnesium chloride salt, and hydrogen gas is released. Calcium with hydrochloric acid, calcium chloride, hydrogen gas is released. Calcium with nitric acid, calcium with sulfuric acid, its corresponding salt, calcium nitrate, calcium sulfate is formed, and hydrogen gas is released. So when you add acid and a metal, a salt is formed and hydrogen gas is released. How do I identify this hydrogen gas? Hydrogen gas can be identified by simply burning it. You simply hold a candle at the outlet here. Hydrogen gas burns with a pop sound. So you identify hydrogen is released. So first thing we have established, acid plus a metal, it will lead to a salt plus hydrogen gas is released. Next reaction. How do acids react with carbonates and bicarbonates? See, whenever there is a metal carbonate, that means metal carbonate, when you add with acid, you form a salt. What is a salt? We'll understand that. We'll understand the definition of a salt also in the latter part of our discussion. There is formation of water and there is release of carbon dioxide. There is release of carbon dioxide. So when acid react with carbonates, it produces a salt, it releases water, and it releases carbon dioxide gas. How do we establish it, or what are the examples? Now you can see here, I can get sodium carbonate, I can get calcium carbonate, I can add it with hydrochloric acid. A salt is formed, sodium chloride or calcium chloride, water molecule is formed, and carbon dioxide is released. Now, how do I identify that carbon dioxide is released? One of the simplest methods is to check the outlet for carbon dioxide gas, is to take a candle and light the candle and hold the candle there. If the carbon dioxide gas comes, then the candle will get off, because combustion runs because of oxygen, and if oxygen is not available, carbon dioxide is continuously coming, then the candle will be off. But another method, chemical method, is mentioned here. Through this test tube, we can see carbon dioxide will be released, and in this test tube we have calcium hydroxide solution. Now when carbon dioxide reacts with this calcium hydroxide solution, it is also lime, basically lime, it forms a precipitate. It forms a precipitate of calcium carbonate. And if I continuously pass carbon dioxide through it again and again, then calcium carbonate also transforms into calcium bicarbonate. So first it becomes a precipitate, then again it turns into a colorless liquid forming calcium bicarbonate, calcium hydrogen carbonate or calcium bicarbonate basically. All right. So similar reactions, when acid reacts with carbonates or bicarbonates, it basically forms salt, water with the evolution of carbon dioxide. This is the example. Sodium carbonate mixed with hydrochloric acid, sodium chloride is formed, carbon dioxide gas is released, water liquid is formed. Similarly, if I take a bicarbonate, that means metal hydrogen carbonate, here sodium bicarbonate, sodium hydrogen carbonate, when I add with hydrochloric acid, you will get salt, carbon dioxide gas is released, and water liquid is formed. Right? So this is the reaction of acid with carbonates and bicarbonates. The next kind of interaction, acid reacting with a metal oxide. Now, only metal oxide is being discussed. Try to understand, acid does not react with a non-metal oxide. The reaction is fairly simple. Acid, when it reacts with a metallic oxide, it forms salt and water. Now I'm thinking, I've seen this kind of reaction somewhere. Say when I add acid, when I add a base, what would it lead to? What would it lead to? It leads to formation of a salt, and it also leads to formation of water molecule. Oh, that means it's basically some kind of a neutralization reaction. What do I understand from this? Why does this happen? Because metal oxides are basic in nature, and non-metal oxides would be acidic in nature. So do you recall this? We had discussed this when we spoke about metals and non-metals. In fact, all these ideas have been discussed once when we spoke about metals, non-metals, and their reaction with acids. It's more like a revision for us. Do you recall this? That metal oxides are chemical compounds that contain metal and oxygen atom, and they are basic compounds. So when I add this basic compound and acid, what will happen? Simple, salt and water will be formed. That means acid and base would be neutralized. That is why metal oxides, they react with the acids to form this, and these metal oxides are generally ionic compounds. They react with acids forming salt. And of course, when they react with water, they form basic solutions, basic aqueous solutions. Yes. Similarly, non-metal oxides, they are acidic compounds, and when I add this with a base, they both will neutralize each other. That's why this kind of reaction. I hope it's clear. One of the examples is here copper oxide, which is a black metal oxide, added with hydrochloric acid. It leads to formation of copper chloride and then water molecule. One of the examples. Right? All right. Now, this was the reaction of acids. Let's now move to chemical properties of bases. Now, how does a base react with a metal first? How does a base react with metal? First of all, you need to remember bases seldom react with metals. But there are some metals like zinc. They are amphoteric, meaning zinc can react with acids as well. Zinc can react with bases as well. But in general, metals, they do not react much with the bases. One of the exceptions is zinc. So zinc, when added with sodium hydroxide, it forms a salt. And it leads to release of hydrogen. And this, through this reaction also, I can check how hydrogen comes. I simply hold a candle, I light it, you will hear a pop sound of hydrogen burning. Apart from this, how do bases react with non-metal oxides? We discussed how acid reacts with metallic oxides. Exactly that. Base, when added with a non-metal oxide, it leads to salt and water. Why? Because non-metal oxides are acidic in nature. Can I find one of the classic examples of non-metal oxide? Non-metal. I take carbon, add oxide to it, carbon dioxide. Now, what is carbon dioxide? Carbon dioxide in general is acidic. You do know that if I add carbon dioxide with water, it leads to formation of a weak acid, carbonic acid. So carbon dioxide is acidic in nature. When I add acid and a base, it leads to salt and water. Simple example, sodium hydroxide, it creates or it gives sodium carbonate along with water when you react that with carbon dioxide. Apart from this, we have discussed neutralization reaction. How do acid and base react? Acid and base, they react to form salt and water. This is the basic neutralization reaction. Now, what do we have common between these acids and bases, or how can we define them? How do I understand what strength an acid has or what strength a base has? What is the concentration of acid and base? We need to understand commonality among them. See, what is the commonality? Every acid, when I create an aqueous solution of it, meaning when I add it to water, it will give me H plus ion. Take any acid, H plus ion as a cation, and anion such as Cl minus, NO3 minus, or SO4 2 minus. You take any example, hydrochloric acid, sulfuric acid, nitric acid, you will find H plus ion. Similarly, when a base is added into aqueous solution, we get OH minus, and strength depends on this itself. How is it electrolyzing? If it happens completely, then it's a strong acid. If it happens partially, it is a weak acid. Correspondingly same for the bases. So what do we see? We see that hydrochloric acid, or any acid for that matter, it always gives you H plus ion. Now, when it is in aqueous solution, we call it hydronium. Why? Because H plus, it reacts with water to give you hydronium ion. So when I write H plus or hydronium ion, both would be one and the same. Please note this. Similarly, when I have a base in an aqueous solution, it will always give me OH minus. So these ideas of acid and base, they have been further explained by different theories. But before entering those theories, we need to understand two more terms, especially connected to bases. Because with bases, we have a term called as alkali. Alkali. So what is this alkali? When you say something is an alkaline solution, means a base is soluble in water. Alkali is a base which is soluble in the water. That's why we say alkaline. The term alkaline is used. So difference between a base and alkali is just that if a base does not dissolve in water, it becomes base, and if a base it dissolves in water, it is called alkali, and that becomes alkaline solution. So what is the understanding? All alkalis are bases, but all the bases are not alkalis, because all bases do not dissolve in water. Right? That's the basic difference between these two. And I spoke about some theories, age-old theories have been there, modern theories have been there, which explain the idea of acids and bases. As I told you, one of the earliest ideas is the Arrhenius theory of acid and base. Way back, if I'm not wrong, I think 1887 it came up. And Arrhenius' theory basically says if there is an acid in an aqueous solution, acid leads to formation of H plus and its conjugate. Same thing for a base, it leads to creation of OH minus in aqueous solution and its conjugate. The modern theories have been a little different. Modern theory is Bronsted-Lowry theory of acid and base. It states that if something is acid in an aqueous solution, it leads to creation of a proton and its conjugate base. Similarly, in aqueous solution, you have a base. When you have a base, you add a proton to it, you create a conjugate acid. That's the basic idea of the theories that are given. These theories are not mentioned in NCERT, but I'm just telling you so that you have an idea, especially about Arrhenius theory. If I simply have a statement, Arrhenius theory is connected to what, or Bronsted-Lowry theory is connected to acids and bases. And why are we talking about these? Because we need to understand how to gauge the strength or concentration of acid. For measuring the strength of acids, we have created scales. And that scale, we have created a scale, that scale is pH scale. pH scale, it's a logarithmic scale of calculating what is the concentration of H plus ions in a solution. H plus, or for that matter, if it is aqueous solution, it would be hydronium ion. So the formula for a pH scale is basically pH is equal to minus logarithmic H plus. Since it's a logarithmic scale, lower the value, higher the acidity. Higher the value, lower the acidity. So on this pH scale, on the logarithmic scale, we have created a pH scale which goes from 0 to 14. The value goes from 0 to 14. If the value is near to 0, that means it is extremely acidic. And if the value goes near to 14, it is extremely basic. Here, it's devoid of those H plus and OH minus ions are higher. Clear? There are some representative numbers which are given here. Gastric juice, that means in our stomach, the acidity is somewhere in the range of 1 to 2. Lemon juice has acidity of about 2.2. Pure water, it is generally 7. Pure water is neutral. Blood is also around neutral, 7 to 7.5 range. Milk of magnesia has 10 pH, right? When I talk about concentration, concentration means how much of hydrogen ions are concentrated, and concentrated acids are very corrosive, very dangerous. All right, right. Let's move on. Since we created pH scale, pH has a lot of significance in everyday life. All of us, we are very sensitive to pH. For instance, if I do not have food, say for 6 to 8 hours, then the amount of acid in my body would increase. It leads to acidity. Similarly, plants, animals, different organisms, they are very sensitive to pH. They are very sensitive to acidity. And if there is a lot of pollution in our environment, it leads to acid rain. Acid rain means precipitation whose pH is very low. Precipitation whose pH is lower than 5.6, it is called as acid rain. And whenever there is acid rain, it leads to lot of problems to plants, animals, humans, everybody. It erodes or corrodes the monuments. We have seen the Taj Mahal case. It leads to reduction of pH of the water bodies. What happens then? The aquatic animals, they would be troubled. It leads to reduced productivity of plants, because with the precipitation there is a lot of deposition on the leaves, which leads to reduced productivity of plants. Similar case with the animals as well. Apart from that, pH in the soil is very important. NCERT asks the question, what is the pH of a soil in your backyard? If you do a testing of that, for ideal scenario, for ideal productivity, its pH should be somewhere within the range of 5.5 to 7. I would say 5 to 7. pH of 5 to 7 is actually better for plant productivity. But if it goes below that, soil degradation, the soil fertility is lost. Plants cannot produce enough food in acid soil. That's why it becomes imperative for us, it becomes imperative for farmers, for the government, for everybody involved to ensure that soil fertility or soil acidity is eliminated. Soil should not turn acidic. Soil should not turn completely basic as well. Optimum level should be somewhere between 5 to 7 pH. Apart from that, in our day-to-day life, in our digestive system, we have different pH setup. See, our digestive system, it starts with mouth. From mouth through the esophagus, it moves to stomach. From stomach, we have small intestine and we have large intestine. Now, when you look at pH of our digestive tract itself, mouth has basic pH. Stomach has highly acidic pH, and this slowly and steadily changes through the small intestine. We have duodenum, jejunum, ileum. The pH level, it goes on increasing here. Since acidic, that means pH goes down. It reverses here. In small intestine, it is again basic, but in large intestine, it is again acidic. So if there is any change in this pH level in our digestive system, we face problems. As I gave you example, that if you do not have food continuously, say if you're fasting and suddenly you eat a lot of food, you might end up having acidity, and for that acidity again you have to consume ENO, or you have to consume some other antacid to neutralize it. So in our day-to-day activities as well, pH is very, very important, because again without proper pH, we find that the GI tract, it gets upset, and to neutralize it, we take antacid, we take magnesium hydroxide, etc. Similarly, pH in our mouth, I said pH is generally around basic. Saliva itself is basic, but pH change in the mouth, it leads to tooth decay. If in my mouth the pH reduces too much, if the pH goes down somewhere around 5, right, somewhere below 5.5, then the tooth decay takes place. And why does that happen? That happens because of activity of bacteria and other microorganisms. Microorganisms, they break down the sugar and food particles in mouth after eating, and then it produces, or it lowers the pH of your mouth. That leads to tooth decay. That's why it is said that after every meal to brush your teeth. Why? Because you would not want your tooth to decay. Apart from that, many plants and many animals have self-defense mechanisms through acids and bases based on the pH itself. Mainly acids. I gave you example of nettle, a herbaceous plant, which releases methanoic acid. Similarly, bee, we have a bee, right? We have honeybees. Honeybee, if it stings you, what does it release? It releases different chemicals which has different acids. There is phosphatase acid if a bee stings you. So there are self-defense mechanisms as well. All right, so pH is very important for all of us in our everyday life, in our day-to-day life. So do observe these things to your preparation. All right. Now, apart from that, the last topic of our discussion today is salts. Now we established that whenever there is neutralization reaction, meaning whenever acid it mixes with base, they neutralize each other, it leading to creation of salts and water molecules. So salts are basically ionic compounds which are formed after neutralization of acids and bases. And generally, salts tend to be electrically neutral. They are electrically neutral. They form electrolytes. They are electrically neutral. Apart from that, the commonest salts that we have is sodium chloride. And from sodium chloride, or through reaction of sodium chloride or sodium chloride solution, we can get many other type of different solids, different salts and compounds that we use in our everyday life. But let's talk about some of the characteristics of salt first. Majority of salts that we find, they are crystalline in nature. You take example of copper sulfate, sodium chloride, any other salts, they are mostly crystalline. It's not necessary that every salt has characteristics like the common salt or NaCl. Many can be transparent or many can be opaque as well. But majority of salts, they are soluble in water. Why? Common sense tells me acid plus base, salt is formed and water is formed. So soluble in water. Solution of salt, it conducts electricity. That means it is a very good electrolyte. Please remember that solution of salt is a very good electrolyte. As I told you, salt can be transparent, opaque, it can be colorless, or it can be white as well. It's not necessary that salts always taste salty. By the name, it's a misnomer. You think that salt should always taste salty. It's not necessary. Salts may have different tastes. Some may be salty, some may be sour, some may be sweet, some may be bitter. And generally, salts are odorless. Especially neutral salts are odorless. Now the question is, how do we categorize or classify salts? Salts are classified on the basis of their families. And how do we define those families? Similar acidic or basic radicals, they are classified or they're put into same family. For example, we have chloride salts. Salts where you have chloride. For example, sodium chloride, calcium chloride, potassium chloride, they are under chloride family. They can be calcium family as well, meaning calcium salts with different conjugates. Calcium chloride, calcium sulfate, calcium nitrate, they come under calcium family. Zinc family, similarly, zinc chloride, zinc sulfate, they come under zinc family. What are the different classifications of salt? We have three major salts that are formed through chemical reactions. A neutral salt, by name itself, it's understandable. Neutral salt is created when a strong acid reacts with strong base, leading to creation of a neutral salt. So remember, strong acid plus strong base, where the pH is around 7, it is a neutral salt. Classic example being the one that we consume, sodium chloride, sodium sulfate, potassium chloride. These are examples of neutral salts. But salts can also be acidic. That's why I told you neutral salts are odorless, and other salts, they may have some kind of odor or different taste. Acidic salts. Now, how would acidic salt taste? They would taste sour. When would acidic salts be formed? Acidic salts be formed when a reaction happens between a strong acid and a weak base, leading to creation of a salt whose pH is less than 7. Example, ammonium sulfate, ammonium chloride. Basic salt. Now, basic salt would taste bitter. When would it be formed? It is formed when a reaction happens between a weak acid and a strong base, leading to its pH higher than 7. Sodium acetate, sodium carbonate, etc. are the examples. Apart from these three, we have two other classifications, although these are not mentioned in NCERT, but you need to know this. There can be double salts. Double salts are those salts that have more than one cation or more than one anion. Classic example being potassium sodium tartrate. Commonly we call it Rochelle salt. I'm quite sure you have Rochelle salt at your home. Rochelle salt box. It has potassium, it has sodium and other non-metallic elements. Then you have mixed salt. Mixed salt is a salt which is composed of a predetermined mixture of two salts. We'll talk about one of the mixed salt, that is calcium oxychloride. We also call it as bleaching powder. We'll talk about that. Now, from these salts, we talk about some of the most important compounds that we use in our day-to-day lives. The most important one is sodium chloride, salt. We use it every day in our cooking. It gives taste to our food. It gives that salty taste to our food. And without that salt, food would rather be incomplete. Sodium chloride, it is also known as common salt or table salt. How is it formed? It is formed through the reaction of sodium hydroxide and acid, hydrochloric acid, meaning one base, strong base plus strong acid, it leads to formation of sodium chloride. Its pH is somewhere around 7. Sodium chloride, you do know that we use it extensively. But many a times from this sodium chloride or sodium chloride solution, concentrated sodium chloride solutions, we obtain many other kinds of salts and compounds. Let's talk about them. One of the compounds is sodium hydroxide. Sodium hydroxide is a strong base. How do we get sodium hydroxide? It is also called caustic soda. Sodium hydroxide, how do we get it? We get it through electrolytic decomposition of brine solution. Now, what is this brine solution? It is concentrated NaCl solution, meaning I have salt. I create a concentrated salt solution and go for electrolytic decomposition. When I apply EMF here, what will happen? Salt plus water, and I'm providing electrolytic force here. Then what will happen? Hydrogen gas is released towards the anode, chlorine gas is released at the cathode, hydrogen gas is released, chlorine gas is released, and the solution that is left out, that would be sodium hydroxide. This entire process is called as chlor-alkali process. Why do you call it chlor-alkali process? Because chlorine is produced, chlor-alkali. You do know what is alkali? Alkali is a base which dissolves in water. Sodium hydroxide dissolves in water. Sodium hydroxide, also called caustic soda, it is used in many processes. It is used to produce soaps. It is used to make rayon. It is used in production of paper, other products like dyes, etc. It is also used in processing of cotton fabric, metal cleaning, etc. As I told you, it forms a very good electrolyte. It is also used in electroplating and electrolytic extraction. Sodium hydroxide. Apart from sodium hydroxide, another product, a mixed salt that we use regularly, is the bleaching powder. Bleaching powder is also known as chloride of lime, and commonly we use bleaching powder to bleach, to clean something. Its chemical name is calcium hypochlorite. Calcium hypochlorite, CaOCl2. In an aqueous solution, the bleaching powder will react with water and it releases chlorine, Cl2 gas. Whenever bleaching powder is added to water, it gives a very strong smell, that is the chlorine smell. But how do we get, or how do we produce this bleaching powder? Bleaching powder can be produced from slaked lime, that is calcium hydroxide, aqueous calcium hydroxide. When it reacts with chlorine gas, it leads to formation of bleaching powder or calcium hypochlorite. We use bleaching powder extensively in our day-to-day lives. Bleaching powder is used for cleaning our dirty clothes. Bleach, you must have seen that ad, right? You must have seen that ad. Vanish the white bleach. It says it has a lot of oxygen molecules. It has chlorine as well. We use it as a bleaching agent for cotton, for clothes. Bleaching powder is also used as oxidizer in many chemical industries. It is also used to bleach the wood pulp in creation of paper. You have white paper, exactly. So wood pulp is bleached with bleaching powder itself. It is also used as disinfectant. It is also used as disinfectant to clean water. Your drinking water, you can simply add bleaching powder to it, let the bleaching powder react, and chlorine is released. Oxygen is also released there, and you will find that germs die. Many a times when you go to swimming pool, you have a characteristic smell. There also bleaching powder is used because chlorine gas is the characteristic smell that you find in your swimming pools. Bleaching powder. Next, baking soda. Baking soda. Sodium hydrogen carbonate or sodium bicarbonate. Baking soda is a very important compound that we again get from another chlor-alkali process. How do we get it? We get it when brine solution, that is NaCl solution, when it is reacted with ammonia and carbon dioxide plus water is there, it leads to sodium bicarbonate. This is another chloralkali process where chlorine gas is formed. You have some other compounds also which are formed. The chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. Commonly we call it soda, we call it baking soda, we call it bread soda, cooking soda, bicarbonate of soda. The common names, and it has been used extensively. It is used as an antacid. It is used to clean. It is used to clean utensils. It is used to clean your body. It is used to clean odor. It is also used as face and body scrub. It softens your skin. There are so many do it yourself, right, DIYs that you find with baking soda. Baking soda and paste, baking soda and Coca-Cola, baking soda and lime juice used for cleaning. It relieves skin from itch, from insect bites. It helps to relieve baby diaper rashes. It can be used as oven cleaner. It can be used to clean bathroom tiles, silver polish, right? It can be used as a drain cleaner also. Simply add baking soda and vinegar, your drain would be clear. You must have seen so many DIYs or so many examples of baking soda. Apart from baking soda, we also have washing soda. Washing soda is sodium carbonate. Washing soda, it has two sodium ions and a carbonate ion, that is Na2CO3. It is white, it is crystalline, and it dissolves in water. It is manufactured by thermal decomposition of sodium hydrogen carbonate itself. That means it is basically produced from baking soda NaCO3. When you thermally decompose it, you get sodium carbonate or washing soda. And you do know washing soda has many uses. It has many applications. It is used in your washing powders. It is used for washing your clothes. It is used for softening of water. It is used as one of the ingredient, one of the reactants for production of glass. In glass production, washing soda is used. In production of sodium silicate, washing soda is used. For making paper, for making borax, for making soap powder, washing powder or sodium carbonate is used. It is also used to remove hardness of water. It also has a lot of applications in textile and other processing industries. Apart from this, there is one more concept called water of crystallization. Since we are talking about salts, many a times when we see the formula, the chemical formula for salt, in that we have the salt plus some water molecule. Such salts are called hydrated salts, although they look crystalline. One of the examples is this copper sulfate, right? We have this copper sulfate crystal which is blue in color. But when you see copper sulfate crystals, they are represented as CuSO4. This is the salt, plus it also has 5 water molecules. Yes, it is in crystalline form. Yes, you cannot see that water, but you can get a feel of it. When you simply heat this copper sulfate, these crystals, they become colorless. But again, when you simply add some water, when you hydrate them, they again become blue in color. That means in some salts, especially hydrated salts, there is already water present in them, and that water is called water of crystallization. That's it. Some salts combine with water and form hydrated crystals. The water molecules required to form these crystals, they are called as water for crystallization. In fact, many a times you do see during the rainy season, you have salt, but that salt, it has become moist. Table salt during rainy season, you must have seen table salt during humid days, or gypsum. Gypsum is another example where you have water molecules in it. So water of crystallization. One example of this hydrated salt is plaster of Paris. Plaster of Paris is produced from gypsum itself. Gypsum is this particular compound, that is calcium sulfate or hydrated calcium sulfate. It is called as gypsum. Gypsum can be naturally found. Now, when you heat gypsum, the gypsum get calcinated. That means some water molecule is lost. This solid gypsum, it turns into this powder called as plaster of Paris. And when you again add water to this plaster of Paris, it becomes extremely hard. That's why plaster of Paris has many applications. It is used in various areas. It is used for sculpting materials. It is used in your house, in your construction work, right? Plaster of Paris, POP is used for your walls, right? POP is used even for your ceilings, right? POP is used for making equipments like these. POP is used even for dental filling. Plaster of Paris is used for dental filling. It is used in soils, especially gypsum itself. Gypsum can be used in soil to reduce its acidity. When your bone is broken, or when there is some sort of fracture, you have a plaster. And what is that plaster? That plaster is plaster of Paris itself. So there are so many applications of plaster of Paris. You can use it for bandages, for plasters, for building material, for furnishing house, for finishing houses, for sculpting materials. So many applications of plaster of Paris. What is this? It is a hydrated salt, or it is prepared from hydrated salt. It is prepared through calcination of gypsum, simply heating or decomposing gypsum, where it loses some amount of water to form plaster of Paris. All right. So please remember these salts. Sometimes questions can be formed. For instance, if I have to create a simple kind of a question, I can give you the name of the salt, and say probably its application this side, application, and I can create a question where you have different pairs. For example, I say washing soda, I say baking soda, I say bleaching powder, and I simply give you the application of that, and I interchange them, and I give you a question where how many of these pairs are correctly matched and how many are not. So different kinds of questions can be created from this particular topic. Again, it gives you some basic knowledge about chemistry, basic knowledge about acids, bases, and salt. How do they react? And mostly regarding the salts and their day-to-day usage. Metals and non-metals. We have some idea about these from class 9 discussion itself. What did we discuss in class 9? We said that when we look at the periodic table, we can see that there are metals, there are non-metals, and there is another class of metalloids, although this is not mentioned in the NCERT, but I had given you this input in our previous discussion as well. So metals are these which are represented in the red in periodic table. Non-metals are the ones which are represented in blue. Hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine. These are non-metals. And there is another class which is called as metalloids, which fall somewhere in between these two. And we have discussed that metals are those elements in the periodic table which are characterized by similar traits. Metals are typically hard. Majority of metals are solids. They are lustrous, and they represent or they give certain similar characteristics. Approximately about 90 types of metals are found in the periodic table. Apart from that, non-metals are the ones which are characterized because of their lack of metallic properties. They are generally non-solids. Even if they are solids, they are brittle in nature, and their properties with respect to electricity are poor. They are poor conductors of heat as well as electricity. We also discussed that non-metals, generally we categorize them into three categories. Non-metals like elements like sulfur, phosphorus, carbon, halogen, chlorine, bromine, fluorine, etc., and noble gases. Noble gases, that is helium, neon, argon, etc. There are about 20 non-metals that we find in our periodic table. Apart from these two, metals and non-metals, just for your information, we also have few elements that are characterized as metalloids. Why? Because their characteristics are somewhere in between metals and non-metals. The classic example being semiconductors that we use in our electronic industry. Some of the examples are silicon, germanium, etc. So metalloids are the ones which have characteristics between metals and non-metals. This we have already established, and we also discussed some of the characteristics. Metals versus non-metals. When we see metals are lustrous, they generally form cations, that means positive ions. Non-metals, they generally form negative ions. And metals are more lustrous, they are good conductors. The opposite side you'll find non-metals. We also discussed some of the characteristics in details. So how do we put metals in a category? Because they show similar kind of traits. For instance, metals show heat resistance. That means they have high boiling point and high melting point. Metals show good properties towards electricity and heat. That means they are better conductors of heat as well as electricity. They conduct heat and electricity through them. That is why most of the metals are solid and most of the metals are dense. Some of the exceptions can be like mercury, but majority of the metals, they are dense solid materials. Non-metals are generally gaseous. Even if they are solids, they are brittle. Apart from that, metals exhibit two important properties, very important: malleability and ductility. Now, malleability is a property of metal by virtue of which we can simply transform them into sheets. That means you can hammer them continuously and you can bring them in a shape like a sheet. Ductility is the property of metals in which you can you can heat them and pull them and create thin wires out of it. Now, what wires do we use in our electrical equipment? It's copper. What is copper? Copper is a metal. For example, gold. You must have seen gold ornaments, right? Very costly. It is said that a single gram of gold, it can be pulled into a wire which can elongate up to 2 kilometers. Unbelievable, right? It's actually true. A single gram of gold can be elongated or created into a wire which would be about 2 kilometers long. So they have ductility. They show malleability, they show ductility. Majority of metals are also lustrous. That means they have shiny and metallic appearance. And since they have ductility, malleability, and they are lustrous, they are also sonorous, meaning they create sound. Have you heard that sound? When a metal, say simply, if you let a ring slip out of your hand and it falls on the ground, it makes a sound, and that sound is stinging. That sound is sonorous. So that's why metals are sonorous. They ring sound. Apart from this, as I told you, they're already dense. Their physical form is mostly solid at room temperature. Exception is mercury for sure. Apart from that, metals form alloys. Metals can be mixed together to get alloys. And when they ionize into cations, that is positive ion. Classic example, Na plus, right? Sodium plus. They ionize into cations. Now, on the opposite end is the non-metals. Non-metals will have poor conductivity with respect to heat and electricity. They will not have that heat resistance. That means they will have low melting point and low boiling point. They do not conduct electricity and heat. They are not dense. They are not hard. Even if they are solids, they would be brittle. They would not be lustrous. They lack that metallic shiny appearance. And of course, they would not be sonorous as well. Apart from that, as I told you, density would be lower. And when they ionize into negative ions. Again, classic example being Cl minus. Why I give this example? Because we use NaCl every day. That is common salt, sodium chloride. Na plus, Cl is minus. So metals, they form cations, and non-metals, they form anions. So these are some basic characteristics of metals and non-metals. Again, this has been repeated in the chapter. We have discussed that before also in our class 9 interaction. But let's move ahead and talk about some technical stuff specially connected with metals from this chapter. In this discussion, we'll be focusing more and more on metals itself. And now let's talk about chemical properties. What are the chemical properties of metals, and some discussion about non-metals as well. First thing, what happens when a metal is burnt in air? Now we have already understood what is the composition of air. The composition of air is, there is nitrogen in it, 78%. Then there is oxygen in it, 21%. Nitrogen is rather unreactive. So what will happen when we burn metal in air? There is oxygen which is reactive. So metals, except for noble metals like gold, silver, platinum, with respect to other metals, what they do is they react with oxygen in the air. When we provide heat, when we burn these metals, they react with oxygen to form metal oxides. And we know from our previous interaction itself, metal oxides are basic in nature, right? Metal oxides are basic in nature. And these reactions are exothermic. That means when we burn them, more and more amount of heat is also released. Some of the examples can be given here. As I told you, metal plus oxygen, it leads to creation of metal oxides. Classic example, copper. Copper, when you burn in air, it reacts with oxygen to give you copper oxide. Similarly, aluminium, when you burn in air, it reacts with oxygen to give you aluminum oxide. And I told you that generally metal oxides are basic in nature. And now by now I already understand, if metal oxides are basic, when they react with your acid, they neutralize. This we have discussed before also. But there are some metal oxides, predominantly like aluminum oxide, they have peculiar behavior. Sometimes they act as basic and sometimes they also act as acidic. Some exceptions like aluminum oxide. But generally metals, when they react, they form metal oxide, which are basic in nature. Again, depending on the reactivity of the metal, some metals react fastly, some metals react slowly. Next, what happens when metals react with water? Metals, when they react with water. Now, we understood metals when they react with air, that means with oxygen, they form metal oxide. In water also, water's chemical formula is H2O. Means when metals react with water, they are going to react with oxygen as well. So a metal oxide would be formed. But since there is water present, that means water amount is high, then that metal oxide is going to further react to form metal hydroxide. So remember, some metals do not react with water. Again, classic example being gold, silver, etc. But many metals, they react with water to form metal hydroxide. Again, depending on the reactivity of that particular metal, some react very vigorously. Some react vigorously, releasing heat, giving some sort of precipitation. For instance, sodium, potassium, they readily react with water. Whereas magnesium, it does not readily react with cold water. But if you provide hot water, it reacts. Metals like iron, they react with water very slowly. They corrode slowly. So what happens when metal reacts with water? A metal reacts with water. It first forms metal oxide, because water also has oxygen, and it releases hydrogen gas. How do we get this, or how do we sense this hydrogen gas? We simply burn it. A pop sound comes out. Then this metal oxide, it further reacts with water to give you metal hydroxide. So we already know that when a metal oxide is formed, this metal oxide is basic in nature. And if we have this metal oxide in water, it will give you metal hydroxide, meaning it will give you a basic solution, a basic aqueous solution. And if it completely dissolves in the water, it becomes an alkaline solution, because we discussed what is the difference between alkali and a base also. Classic example being here. Now take potassium, take sodium, add water into it. They react with water very vigorously to form these hydroxides. Next, how do metals react with acids? How do metals react with acid? Now we have already discussed this when we spoke about acids and bases. When metal reacts with acid, they produce a metal salt and they also release hydrogen gas. Right? Now, for example, let's take say sodium. Right? Sodium plus you take sulfuric acid. Now what is going to happen? The product would be, we have sodium sulfate, you have a sodium sulfate, right? And then you have hydrogen gas. Of course, this is not a balanced reaction, but just for your understanding, I'm telling you that sodium sulfate is formed, Na2SO4, and then hydrogen gas is released, right? So this is a classic idea of metal reacting with acids. Now we have also seen that with some acids, hydrogen gas may not be released. Please remember this. So general reaction is when metal reacts with acid, they produce metal salt, one particular salt, plus hydrogen gas is released. How to sense that hydrogen gas? Simply burn this hydrogen gas, a pop sound will come when you burn it. But there are some acids with which hydrogen gas may not be released with some particular metals. Hydrogen gas is not evolved, especially when metals, they react with nitric acid. Now when this happens, the products would be, of course, a salt, then you get water, and then you get nitrogen oxide gases are also released. Nitrogen oxide gases are released. There is one exception, magnesium. When it reacts with nitric acid, it also releases hydrogen gas. But please remember, when metals react with HNO3, nitric acid, the nitrate oxides or nitrogen oxides are released. All right. Next, how do metals react with the bases? Now please remember, when a base reacts with a metal, it leads to formation of a salt along with liberation of hydrogen gas. This we have already established. So metals, they react with bases to produce hydrogen gas and a salt, very similar to how we have seen with acid. But when it comes to non-metals, non-metals do not generally have such a simple kind of reaction. It is much more complex. For example, say when bases react with non-metals like carbon dioxide, it leads to formation of sodium carbonate and water, one of the examples, but the interaction can be a little complex as well. So metal reaction with the base, again similar to acid, it gives a salt and hydrogen gases released. Next, how do metals react with solution of other metal salts? Now we know that metal salts, if they are able to electrolyze, then electrolyte is formed. Now in such a reaction, in such a aqueous solution of metal salt, do other metals react with it? Now this depends on the reactivity of metal. Here comes the concept of reactivity. Now in our previous interactions, we have discussed two kinds of reaction. One was the neutralization reaction. This was very simple. Acid and a base mixing leads to salt and water. This we have discussed. We have discussed another reaction called as displacement or replacement reaction. Replacement meaning one metal replacing another. And we have also discussed two kinds of displacement or replacement reaction: single displacement, double displacement. But this displacement, it depends on the reactivity of metal. So when a metal reacts with a salt solution of another metal, when metal A reacts with salt solution of metal B, depending on the reactivity of that metal, the metal A can replace metal B in the salt solution. And this is called as displacement reaction. But again, this depends on the reactivity of the metal. I'm putting a condition here. It depends on the reactivity of metal. For instance, if you just look at this particular picture, you'll understand that there are two test tubes. In one test tube, there is copper sulfate solution and an iron nail. And you see there is no displacement here. That means iron is not displacing copper. But in another test tube, you have iron sulfate solution and a copper wire. And you see slowly and steadily something happening to copper. Now, when you look at this, what happens? Why there is no displacement? Because it depends on the reactivity, and this is the reactivity series for the metals. If you look at reactivity series, potassium is highly reactive. Now in this sequence from the NCERT itself, in this sequence, the top ones are the most reactive, meaning if I take potassium and I put potassium in sodium salt solution, then potassium is going to replace sodium. But if I take sodium and put it in potassium based salt solution, sodium cannot replace, right? Meaning the upper one would replace the lower one. This is the reactivity series. The most reactive is potassium, and in this sequence there is also mention of hydrogen here. You must be surprised, sir, in this series of metal, why we have put hydrogen here? Hydrogen, it becomes a reference point. Hydrogen also has some sort of reactivity, because you do know hydrogen, it consists of one proton, one neutron, one electron, and since there is one electron, it tends to lose that electron and react quickly to form H plus. We have seen this. That's why it is also included in this particular series. And you can see at the bottom you will find noble metals like gold, silver. So gold, silver, they do not react. Platinum does not react. Mercury has very low reactivity. Copper has less reactivity. Copper can react. In fact, for your reference, I have created a chart here which you can refer. I'll be sharing this PDF. You do know that I do share these PDF at my Telegram channel itself, which goes with this particular ID, Rahul SAI222. You can always take the reference from here and look at this particular sheet. For your reference, I've put this, that most reactive metals like potassium, sodium, lithium, barium, strontium, calcium, these are most reactive metals. They react even with cold water. But below that, magnesium, beryllium, aluminum, titanium, magnesium, they need heat. That means they may react with hot water, they react with acids. You just go below and you'll find you need stronger acids for reactions. And for silver, gold, they do not react. They are highly unreactive with even strong oxidizing acids as well. All right. So this is the reactivity series. Now, Apart from this, there is one more idea. How do metals and non-metals react? Let's talk about reaction between a metal and non-metal. I'm not talking about metal oxide, non-metal oxide. Directly, reaction between metal and a non-metal. Now, we have already established that metals, when they are ionized, in their ionized state, they tend to become cations. And non-metals, they tend to become anions. That means there is bound to be some sort of interaction between these positive and negative ions. That is what we can see from this particular chart. Now, we have discussed in our previous interaction also the concept of octet. Now, what is this octet? Octet meaning having or complete fulfilling of 8 electrons in the outermost shell of a metal or a non-metal. Now, if you look at the electron configuration of some of the gases, some of the metals, gases and non-metals here, noble gases like helium, neon, argon, they seldom react. Why? Because their outermost shell, it fulfills the criteria of octet. For instance, helium, it has only 2 electrons, so 2. If you look at neon, it has 2 electrons in the innermost shell and the outermost shell has 8 electrons. That means the octet is complete. That's why its reactivity is very, very low. Similar case with argon. Argon, 2 electrons in the innermost shell. In the next shell, that is L shell, you have 8. In the next shell, the outer shell, in the M shell, you again have 8. That means you have completed the octet. So its reactivity would be very, very low. But if you look at other metals and non-metals, you will understand that they react on the basis of stability, reaching towards that stability. Now, if you look at a classic reaction between sodium and chlorine, you will understand that for sodium, if you look at its electron configuration, sodium, the atomic number is 11. So it has 11 electrons, 2 in the innermost shell, 8 in the outer shell, and in the outermost shell, you have only 1 electron. So sodium, to achieve that octet, either it needs 8 electrons, then the octet would be achieved, or it is very easier for sodium to simply give out that 1 electron. It will reach the octet level. So what is the best likely possibility? Better sodium loses 1 electron. So which is the candidate which I can find here, which has 7 electrons in this outermost shell? Now for this chlorine, what would be a better probability, right? Losing out 7 electrons or accepting 1 electron to achieve that octet. That is why you see a reaction between sodium and chlorine. And in their ionized form, we get ionic compounds. So how do metals and non-metals react? By sharing the electrons. That means in the ionic form, they lead to formation of ionic compounds. Classic example being sodium and chloride. So what does a reaction between metal and non-metal lead to? They lead to creation of ionic compounds. What are these ionic compounds? Ionic compounds are pure substances formed by reaction between a metal and a non-metal, where they tend to reach a stable phase, where they have chemically bonded, where there is some sort of ionic bonding between these two ions, between the cation and the anion. Now when we talk about ionic compounds, it can be between a metal and a non-metal, or it can be polyatomic also. There can be different atoms. For example, here sodium sulfate, right? Sodium sulfate, that's why Na2SO4, I told you it is not balanced, Na2SO4. So oxygen, sulfur and sodium are all three are combined here, right? Ionic compounds. Now, what are these ionic compounds? In our day-to-day life, we use so many ionic compounds. Let's try to understand some of the characteristics of these ionic compounds. Ionic compounds, in their physical form, they are solids. Generally, they are solids and they are hard. Remember, they are not malleable, they are not ductile. They are generally brittle in form. Classic example, NaCl, salt. Can salt be molded? No. Can salt be extended to wires? No. It is simply brittle. It consists of positive and negative ions. Apart from that, if you look at its chemical properties, the ionic compounds, they have high melting points and high boiling points. Why? Because they have reached a point of stability. Now to break them, I need to give too much of energy to break the bond between them. The ionic bond breakage, it needs a lot of energy. These are some of the exercises that you can carry on to understand what are the properties of ionic compounds. Classic being salt, NaCl. See, If you look at the melting and boiling point of NaCl, sodium chloride, 1074 Kelvin, it is the melting point, and boiling point is 1686 Kelvin. Same is the case with lithium chloride, calcium oxide. If you look at these ionic compounds. So ionic compounds in physical nature, they are solids, they are brittle. Chemically, their melting point and boiling point is very high. They are soluble in water. Now just try to conduct an experiment. We get all these things at a home. Okay, do one thing. Take pinch of salt, mix that in water. Of course, it will dissolve. That means we already know salt dissolves in water. But take same pinch of salt and take a little bit of petrol. Don't take petrol. Petrol has become quite costly. Take a little bit of kerosene if you find. Okay, mix salt in kerosene or petrol. See if it dissolves. Try to stir it. Will it dissolve? It won't. So you'll understand that their solubility is high in water, and they are not soluble. They are seldom soluble in kerosene, petrol, etc. Apart from that, when you create this solution, you do know this solution can become an electrolyte. That means they conduct electricity in their aqueous form. That is why we have seen in our previous interaction also, from a simple brine solution. What is a brine solution? Brine solution is concentrated NaCl solution. From a simple brine solution, we can get so many different compounds, so many different chemical compounds, so many different salts which we use in our day-to-day life. So ionic compounds, physical properties, chemical properties, solubility, and conduction of electricity, that we need to know. From exam perspective, it becomes important. A simple kind of MCQ can be created. Consider the following statements about ionic compounds. First statement: generally, ionic compounds have low melting point. Second statement: ionic solutions are good conductors of electricity. There are two statements. Options are simple: one only, two only, both one and two, neither one nor two. What would be your answer? You do know first statement was wrong because they have high melting points. Second one was easy, right? So some questions like this can be created. Right. Next, we'll talk about metals. Now we understood ionic compounds and our focus is on metals itself. How do we extract metals, or where do we find metals? First of all, we do know metals are found in earth crust. Now many of the metals can be found in dissolved condition in our ocean water. Now ocean water is a source of many of these salts, and from the salts we can get these metals. So what do we find? We find metals in form of minerals. Minerals how? We find metals in form of minerals which are dissolved. Example being sodium chloride, calcium chloride, magnesium chloride. They dissolve in water. We find many such stuff in our ocean water. But minerals which can be exploited easily, they are called as ores. So what is a ore? Ore is a mineral itself, mineral of a metal which can be exploited economically. So ores are found in earth crust. So mineral and ore, they are very similar. Please remember, elements, metals or metallic elements, they are not found in pure form in earth. Now except for some, say for example, I might find gold in pure form. Gold can also be found in ore form. Gold can be found in pure form. Silver, again, I can find silver in ore form also, maybe in pure form also. Platinum, I'll find it in pure form itself. So such metals can be found out in pure forms. So metals can be found out in pure form. Very few exceptions like gold, silver, platinum. Other metals, they can be in form of minerals dissolved in water. They can be in form of minerals which can be exploited profitably. They are called as ores. All right, ores. Now ores. Now what ores do we find? As I told you, gold, silver, platinum, copper also I can find them in free state, but others I do not find in free state. I find in ores, the metals at the top of the activity series like potassium, sodium, calcium, magnesium, etc. These are in mineral forms, and they are never found in free form. They are found in form of salts, in minerals which are dissolved in water, or they can also be found in form of different ores, the solid ores on earth crust which can be exploited, right? So now the question is, so what are the ores of different metals? Questions can be formed on this as well. For instance, sodium. Chile saltpetre, it has sodium. For aluminium, the most exploited ore is bauxite, but you also have corundum, feldspar, alunite, kaolin. Potassium, for potassium you have saltpetre again. For magnesium you have magnesite, dolomite. Now dolomite is something from which you can exploit both magnesium and calcium. Please remember this particular point. Again, for calcium you will find dolomite here, dolomite, calcite, gypsum, etc. Other important ones are copper. You have important ore of copper, which is cuprite. Silver and gold can also be found in ore forms, different ores. But for zinc, you have zinc blende. Please remember this, zinc blende is its ore. For mercury, very important, mercury can also be found in ore form, and its ore is called cinnabar. Cinnabar. Lead. Lead can be exploited from an ore called as galena. Galena. Bismuth from bismuthite. And for iron, we have different kinds of ore, and the maximum or the most exploited ore is hematite. We can also find magnetite, siderite, iron pyrite, etc. For uranium, we have pitch blende. Please remember this, because these are some peculiar ones. I would appreciate if you remember pitch blende. For manganese, you have pyrolusite. You have magnet also. For manganese, you have pyrolusite. For others, I have told you galena, cinnabar, zinc blende, etc. These are something on which I can simply create some MCQs. So better remember these. Now the next question is, sir, I understood. You told metals. You gave properties, physical properties of metals, chemical properties of metals. Then you also told metals and non-metals, they found some ionic compounds. And then you spoke about ores. Now I am interested in exploiting these ores to get my metals. How can I do it? How can I do it? See, exploiting a metal from its ore, it depends on its reactivity. If they are highly reactive, like potassium, sodium, calcium, etc., then you need electrolysis for it. If they are somewhere in the middle of the reactivity series, for example, zinc, iron, etc., for that you need reduction, and for this reduction you use coke. I am talking about iron specifically. How do you produce iron? Iron is produced by smelting of iron ore, by reducing it by using coke, high quality coke. Apart from that, if they are highly unreactive, they can be found in their purest form as well. So depending on the ore, if they are highly reactive, I go for electrolysis. If they have medium reactivity, I look at what particular ore is available, then I reduce that particular ore to its metal. And if metals have very low reactivity, then I go for roasting or calcining and then ultimately refining. So let's look at this process one by one. If a metal is low in its activity series, meaning, say, I am not talking here about gold or silver, but let's talk about mercury and copper. These are metals of very low reactivity. Now generally we find these metals of very low reactivity in form of oxides, because oxygen is abundantly available. So over a period of time we find them reacting with oxygen to form some sort of ore. So how do we reduce it into, or how do we get metal from it? By simply heating it. When an ore of these is heated in the air, first it is converted into its oxide form, and then slowly we can get that metal. For example, mercury in its ore form is available in the sulfide form, right? So mercury and sulfur, they combine. So when I burn it in presence of air, it first leads to formation of oxide. When I burn it further, it leads to formation of that particular metal. Similar is the case of copper. You have copper in form of a sulfide ore. I burn it in presence of oxygen. First I get copper oxide. I burn it further. I heat it further. Then I get copper. So for metals with low activity or low reactivity, I simply heat them in presence of oxygen. First metal oxide is formed, and then the metal itself is obtained. Now when we look at extracting metals in the middle of the activity series, this process is a little nuanced. When we talk about metals in the middle of reactivity series, we get examples of iron, we get examples of lead, zinc, even copper for that matter. Now, why this process is a little nuanced? Because these metals, they form ores in form of sulfides. They form ores in form of carbonates, meaning these metals are available as ores in sulfide form, in carbonate form. Of course, they are also available in oxide form. Now, we have already established that if an ore is available in oxide form, I can reduce that to the metal form easily. Now, here, what we do, if an ore is present in sulfide form, first I have to convert that into oxide form. The classic example being zinc sulfide ore. And for this, we use a process called roasting. So for a sulfide ore, we use roasting process. Now, what is roasting? Roasting is simply heating in presence of excess air or excess oxygen. Please remember, roasting includes excess use of oxygen because I need zinc to react with oxygen so that this sulfur is expelled out. So I get zinc oxide first. By roasting, I convert a sulfide ore into the oxide of that particular metal. Similarly, if a metal is available in carbonate form, say another example, zinc carbonate. Now for this, I already have oxygen in this. Now what do? I calcine this. I subject this zinc carbonate to the process of calcination. Now what is calcination? Simply heating it in limited air. I heat this in limited air. Now what will happen? This will then transform into ZNO, that is zinc oxide. So if it is a sulfide, I roast it, convert it into oxide. If it is carbonate, I calcine it, I convert it into oxide. And once I get the oxide of that particular metal, zinc oxide, then I reduce it. How do I reduce it? By using a reducing agent. Now for these, I need a reducing agent. For metals with low reactivity, I simply heat it. I do not need any sort of reducing agent here. They can be obtained directly. But here, I need a reducing agent. And what is the classic reducing agent I use? I use coke. That means carbon coke. You must have heard the smelting of iron ore. Iron oxide. For reducing it, we use carbon coke. So carbon coke is used in the furnace. Now we obtain that particular metal and gases are released. Carbon monoxide and carbon dioxide. So either we go for a reducing agent or we can also go for some sort of displacement or replacement reaction. That is also possible for extracting metals which are in the middle of the series. Now, if they are in the middle of the series, I want to replace or displace them with the metal which is in upper sequence. I have seen in the reactivity series, whichever is higher, that is going to replace the lower one. So if I want to get say a metal manganese, from manganese oxide I want to get manganese. So how can I get it? I can replace it with aluminium. I can displace with aluminium. Now what will that reaction run like? I get manganese, then Al2O3 is formed, and along with it heat is formed. This can also be one of the examples. So manganese dioxide is heated with aluminium powder to get manganese. How? Aluminium replaces that manganese. And one such reaction is also used to get iron. Iron is also reduced using aluminium because aluminium comes higher in the reactivity series. So if I have Fe2O3, I simply take aluminium here and I try to displace iron with aluminium here. Now this reaction, it gives extreme amount of heat. If I simply burn this aluminium, I get extreme amount of heat where I get iron, and that aluminium displaces iron to form Al2O3, and a lot of heat is released. Now in these exothermic reactions, we use them in many applications. One of such displacement reaction, one of such exothermic reaction is called as Thermit process. You must have heard of this Thermit process. Thermit process is classically used to fill the gaps between the railway tracks. Now this personnel here is using the Thermit process itself. Now how do you proceed with this Thermit process? In this Thermit process, we create we get aluminium oxide slag. After the reaction, aluminium is burnt, and this iron, it gets molted. Iron is formed, iron is molted, and it gets into the gap between the two iron railings, and I simply cut this. Now whatever excess is there, this is filed, this is cut off, and I get two rails which are joined. So a simple MCQ can be created. Thermit, this is also called thermit welding process. If you're a mechanical engineering, if you're a mechanical engineer, you'll know about that thermit welding process. In the thermit welding process, I use this particular reaction itself, Fe2O3 plus aluminum. A lot of heat is generated. Molten iron, it gets into this particular gap, and this is welded. Thermit welding process. So we spoke about how to extract metals of low reactivity, how to extract metals in the middle of the activity series, and the third one is how to extract metal which are at the top of the reactivity series. Now, since these metals are at the top, that means they are not found in the free stage. They are highly reactive. Examples being calcium, sodium, potassium, etc. Now, since they are highly reactive, can we use a reducing agent? Now, till now, for the low reactivity, for the middle reactivity, what we did, we simply heated them in the presence of oxygen. We also used some sort of reducing agent like coke for the middle ones. Can we do it? No. See, if we go for reducing, what will happen? These metals, since they are very reactive, they have more affinity towards oxygen than carbon. So I cannot reduce them. So what do I do? How do I obtain these metals like sodium, magnesium, calcium? I subject them to electrolytic reduction. So what do? I take their chlorides. Say I take their ore, say chlorides, molten chlorides. I subject them to electrolysis. So what happens when I give electricity to it or EMF to it? At the cathode side, I get the metal itself, and towards the anode side, the gas is released. So I get these metals. Similarly, for aluminium, I use electrolytic reduction of aluminium oxide. So for the most reactive metals, I perform electrolytic reduction. But in any of the cases, say for metals obtained of low reactivity, for metals of middle reactivity, for metals of top reactivity or top activity also, when I extract them, they are found mostly in impure form, whatever extraction method I use. So for that, how to purify these metals? I use another process called electrolytic refining. So how do I perform this electrolytic refining? Now, in the electrolytic refining, I use a pure metal strip as cathode. So one of the electrodes is pure, cathode is completely pure, and anode is the impure metal that I have obtained. I have impurities in it, and in this electrolysis process, when I apply EMF along with the electrolyte, what happens? Pure metal, it displaces, pure metal is displaced from the cathode side, and equal amount of pure metal is also displaced from anode side. It enters into the solution, and the impurities, they settle at the bottom. They are called as anode mud. This is a classic example of how do I purify copper through electrolytic refining. I use pure copper as cathode this side, impure copper which I obtained from the extraction this side, and I used acidified copper sulfate solution. So I get pure copper from here. All right. So we understood how do we extract metal from the ores. Now, when I talk about these metals have to be protected. Why? Because metals, they corrode. So corrosion is a process wherein metal, when exposed to moisture, that means humidity, when exposed to air, when exposed to water, or when exposed to acid, it slowly and steadily corrodes. A layer of oxide is formed over the metal, which ultimately weakens this metal. And in our day-to-day life, we have seen so many of these examples with iron. We have seen something called as rust. So iron undergoes rusting. Iron oxide is formed. A reddish layer is formed on the iron, which makes iron. It is also called cancer for iron. There are also metals like silver which get oxidized, which corrode slowly. When exposed to air, they slowly form a coating of silver sulfide. Similarly with copper, when with moist carbon dioxide in air, it slowly loses its brown shiny surface, and a green tinge is seen. This you must have observed also. If you have some sort of copper utensils at your home, or say copper utensils, especially around the temple areas, you must have seen them turning into greenish. That's corrosion itself. Another classic example is iron. When exposed to moist air for a long time, it undergoes rusting. An oxide layer is formed. So corrosion is basically formation of an oxide layer over the metal. In many cases, it leads to deterioration of these metals. And the question is, what does this corrosion depend upon? There is a classic experiment here that if you take iron nails in water where air is also present in this test tube, you will see that these nails, they undergo rusting a lot. They undergo rusting. But when you take distilled water and you separate air from this water, you use a layer of oil to separate air from this water, and now this is distilled water. Remember, it's pure distilled water. In pure distilled water, iron does not rust, especially when it is separated from air. That means oxygen will not enter this water, so it is not going to oxidize it. Similarly, if I simply keep iron nails in a test tube and I use anhydrous calcium chloride, which is a drying agent, that means it is going to suck out complete air. This air is completely dry because this calcium chloride, it takes out complete water from the air. So you will see that these nails will also not rust. So for rusting or for corrosion, I'm using the terms rusting and corrosion interchangeably. For rusting and corrosion, you need air. That means you need oxygen. You also need moisture. But in general, corrosion, it depends on many factors. Corrosion depends on the internal factors of the metal itself. It also depends on external factors. External factors can be environmental factors, or they can also be chemical factors. Let's delve a little deeper on this, because MCQs can be created with respect to this. Say if I ask you a question, rusting would be more towards mainland area or rusting would be more towards coastal areas of India, what would you choose? Right? Just ponder over it. You'll get the answer through this discussion itself. See, I told you corrosion, it depends on internal factors like reactivity of the metal. If the metal has high reactivity, there are higher chances of corrosion. If there is some chemical content or some sort of chemical impurities in it, there would be higher corrosion. If there are imperfections and residual stresses in it, corrosion would be higher in such cases. Similarly, corrosion also depends on external factors, especially environmental factors. Optimum temperature, humidity, and pH, they play a very important role in corrosion. Acidic pH leads to more corrosion. Higher temperature leads to more corrosion. Higher humidity leads to more corrosion. That is why you must have seen, especially in the coastal areas. In the coastal areas, you will find temperature and humidity factors leading to more and more corrosion. Have you observed it? If you live in coastal areas, you must have seen that metal benches, or say steel benches or iron benches that you have along the coast or along the beaches, they would undergo severe corrosion. Apart from that, there are some other chemical factors also. Meaning, for some metals, the nature of the oxide that is formed on the top, it decides whether it will corrode more or not. Classic example being, say, aluminium. See, for aluminium, when it reacts or when it undergoes corrosion, it reacts with moisture in presence of air. So it leads to creation of a small oxide layer, Al2O3, aluminum oxide layer. Now this aluminum oxide layer is highly stable. In fact, this oxide layer, it protects aluminum from further corrosion. But for others, this does not happen. So the nature of the oxide that is formed, it also decides whether the corrosion would be enhanced or whether the corrosion would be reduced. For metals like aluminum, the oxide layer which is formed on it, it acts as a protective layer. But that is not the case with iron. Apart from that, impurities. If there are impurities outside, or if there are impurities on the metal itself, it leads to more and more corrosion. It enhances the corrosion. As I told you, corrosion of iron is like cancer. So how do we stop it? We need to stop it, right? We need to stop corrosion. We need to stop that rusting. How do we stop rusting or corrosion of iron? Rusting can be prevented by painting iron. Simply paint it. That means you cut off the connecting link between iron and its environment. You cut off the link between iron and water, iron and air. Or you go for some sort of oiling. You apply oil in it. You saw this example. Simply cut off iron from air. Rusting would be less. Or you go for greasing, you apply grease, same thing. You galvanize it, you apply a layer of zinc over it. You go for some sort of chrome plating, you go for electroplating. You anodize. If you anodize iron, then the rusting would be reduced. This concept of anodizing is very prominent. If you anodize the iron, especially in water, in oceans, whenever a ship is traveling, the ship is basically converted into anode with respect to the oceanic water, where the rusting would be reduced or corrosion would be reduced. Or you can also make alloys. Classic idea. How do you do it? You have iron. Now, if iron undergoes rusting or corrosion, I add some other things to it. For example, I add nickel into it, I add molybdenum into it, I add chromium into it, so that I change its property. I create a stainless steel out of it. So alloying is a very good method of improving the characteristics or properties of metal. We get desired property from this particular method. That's why you see pure iron, it undergoes rusting or corrosion a lot. But on the other side, stainless steel, does it corrode? That's why you have stainless steel equipment, stainless steel utensils at your home, not iron utensils. They are stainless steel. Stainless steel is an alloy of iron. So I hope you have gotten a very good idea regarding metals, non-metals, and other properties connected with it from this chapter for NCERT class 10. Let me end this discussion with a couple of questions and some FYI for you. First, let me take you to the questions and then we'll talk about FYI, because those FYI, that means for your information, they are very interesting. Some questions can be created on the basis of reactivity. For instance, this is, I would say, this is a moderate kind of a question. Okay, moderate kind of a question. I can even say CSAT kind of a question. Okay, metal A can displace metal B from its salt solution, but cannot displace metal C from its salt solution. So three metals have been mentioned. Metal A can displace metal B, but cannot displace metal C from its salt solution. And metal B can displace metal D from its salt solution. So based on this particular information, you have to answer, or you have to arrange these metals in the decreasing reactivity. That means the highly reactive metal should come first and the least reactive metal should come last. Okay, do try to attempt this. I have put it in the moderate category. I would say this is a little moderate to tough question itself. You will get the answer for this question on my Telegram channel at Rahul Sai 222. I'll also put it on my Instagram with the same ID, right? Apart from that, this is an easy question. This is a very easy question. Consider the following statements. Malleability, property, malleability and ductility, its definition is given. You have to find if the definitions are correct. Options are easy. 1, 2, both 1 and 2, neither 1 or 2. This is an easy question. This is a very easy question, right? So such questions can be created. In fact, I can create so many questions from this particular chapter. Now, let me end the discussion with some FYI. Very, very interesting, because it will give you an insight into how you use your science and technology knowledge or your NCERT knowledge into your other subjects. Now, I told you that gold and silver, they are noble metals. They have very low reactivity. And that's why we see gold does not react much even with acids. But there is a solution called as aquaregia. Aquaregia in Latin, it means royal water. Aquaregia is a mixture of two acids, two concentrated acids, that is HCl, hydrochloric acid, plus your nitric acid. These two mixtures are called aquaregia, and this aquaregia can dissolve gold. It can dissolve gold. It has the ability to dissolve gold and even platinum, right? So they are concentrated. Beware, do not try to experiment at home. Now, apart from this, there is one more information. This is the information about the iron pillar, the Mehrauli iron pillar near Qutub Minar. It shows India's metallurgical prowess right from the medieval times itself. Now, this medieval tower, this iron pillar, it weighs about 6,000 kg, right? And it is about 8 meters high. And till today, we do not see that it has rusted. So it has got some sort of rust resistance. Scientists have been examining it to understand. So a very interesting snippet it is found here. How do you use it? Say, if I ask you a question, related to means that the Gupta age in Indian medieval history has been dubbed as the golden period. You have to explain, or you have to elucidate, give some inputs regarding that. So you have many other pointers like their temple architecture, their business, etc. But one of the pointers can be their accomplishment in science and technology, their accomplishment in their metallurgical development. This clearly shows the prowess in terms of metallurgical development from that particular period. All right. So you have to connect things like this. It's a small snippet, more to know in the NCERT itself. The iron pillar in Mehroli near Qutub Minar. It is a work which is built almost 1600 years back. So approximately, to go back somewhere around 300-400 AD, right? So you need to connect your knowledge, something like this. All right. So that's the end of today's discussion. I hope it was interesting and enlightening. Carbon and its compounds. As I told you, carbon is omnipresent. Carbon is everywhere. Now, if you look at this particular shirt, the shirt is made up of cotton. Cotton has cellulose. Cellulose is made up of glucose. Glucose has carbon in it. If you look at your food, what are carbohydrates? Carbohydrates have carbon. Proteins also have carbon. Proteins are nothing but amino acids. Amino acids have carbon. Fats, fatty acids, they also have carbon. That means carbon is almost everywhere. And it is very strange. When we look at the composition of carbon in Earth, be it Earth crust or in atmosphere, it is very minuscule. In Earth crust, only 0.02% of carbon is present. And in our atmosphere, we have already seen it is about 0.03 to 0.04% in form of carbon dioxide, mostly. But despite such low proportions, carbon is available everywhere in nature. As I told you, it is everywhere. It is in our body. It is in equipments everywhere. It is in all the things that you see. It's in the gas that we exhale out. So carbon is everywhere. Carbon is very versatile. It can react with many other substances. It can react with oxygen. It can react with nitrogen. It can react with carbonates. It can react with other stuff to prepare or to end up with different compounds. So let's talk about carbon. All right, what are the characteristics of this carbon? First of all, carbon, we represent it like this. That means carbon has atomic number of 6. It has atomic mass of 12. We have already discussed the isotopes. I've told you that carbon is present in 2 different isotopes. One is 6C12, that means carbon 12. We also have carbon 13 and we also have carbon 14. We know about this, right? Carbon 14 is used in radiocarbon dating. Carbon, in fact, is 4th most abundant element present in the universe itself. All right, after hydrogen, helium, and oxygen in the universe. I'm talking about not just Earth, in the universe itself. Apart from that, carbon is present in form of different allotropes. Carbon is present in free form as graphite, in pressurized form as diamond. Carbon generally is very inert. Carbon is generally inert in normal conditions, but it forms different compounds. Carbon is non-metallic. Carbon is tetravalent, and tetravalency is one of the most important properties of carbon. We'll talk about that in some time. Tetravalency means carbon generates 4 electrons and carbon forms covalent bonds. Carbon comes in different shapes, and carbon is a chemical element. It forms bonds with different elements like oxygen, nitrogen. It forms bonds with metallic as well as non-metallic elements. That is why carbon is omnipresent everywhere. In fact, when we talk about carbon, carbon is present in crystalline form. It is present in crystalline form as diamond. As I told you, if you have diamond, if you have a diamond ring or if you have a diamond necklace, the diamond is nothing but pressurized carbon. Carbon is present in graphite form. Carbon is also present in fullerene form. We'll talk about this in some time. Carbon is also present in amorphous form. Amorphous means powdery form. Basically, it is present in charcoal, amorphous, non-crystalline, non-solid form, coke, lamp black, or gas carbon. So carbon is very widely distributed almost everywhere. Carbon, as I told you, it is a part of living system. Carbon is present in living organisms. Our body has carbon in large amount. Plants use carbon dioxide for photosynthesis. Carbon is present even in non-living things. That means carbon is everywhere. Carbon is essential for photosynthesis. It is there in plant tissues, it is there in animal tissues, it is there as fossil fuels, as gas, as petroleum, everywhere. Carbon can occur in free state or in combined state as well. And I told you that carbon is present in different allotropic forms, meaning carbon in its free state can become diamond if certain conditions are met. Carbon in a pressurized form, it can become diamond, and diamond has very different characteristics. Diamond has shiny appearance. Diamonds are very, very costly. Carbon is also present in this particular format as graphite. As I told you, a child writing with pencil, that pencil has graphite. Carbon in its I would say nanostructure, it has different structure itself, like C60, that is fullerene. These days we talk about nanotechnology. We lead, or we create nanomaterials or nanoparticles. Carbon based nanomaterials include graphene. Graphene has novel properties. Graphene has in fact revolutionized the field of nanoelectronics. Now what is this graphene? Now this graphene is one carbon atom thick structure which shows novel properties. Similarly, we can make carbon nanotubes. We can make carbon fullerenes. These fullerenes are again nanomaterials which are in this round ball-like structure. It is also called buckyball. And these fullerenes have found application in many sectors. Say, for example, for gas storage, for drug delivery purposes. So many R&D stuff is going on nanomaterials, carbon-based nanomaterials. So carbon is present in different allotropic forms as diamond, as graphite, as fullerene, many other examples that I gave. What are some other characteristics of carbon? Let's talk about characteristics of carbon. Now, one of the novel characteristics of carbon is that it is tetravalent. We'll talk about this tetravalent. We'll be harping about this tetravalent continuously in this interaction. Now, what is the meaning of tetravalency? See, carbon in its normal form, I'm not talking about different isotopes, I'm talking about normal carbon form, we represent it as carbon 12. That means it has atomic number of 6, it has atomic mass of 12, meaning it has 6 protons, it has 6 neutrons. And protons or neutrons, where do we find them? We find them in the nucleus. All right, and it has 6 electrons. It has 6 electrons. Now, you do know that in the K shell, only 2 electrons, they fulfill K shell. So, 2 electrons in the first shell, and in the outermost shell, you have 4 electrons. You have 4 electrons. And we have already discussed that every element, it tries to achieve that stable configuration of the noble gases. That means it tries to achieve that octet, the stable octet. Now, to achieve that stable octet, carbon has 2 options. Since it has 4 electrons, what carbon can do is it can give away its 4 electrons, or it can accept 4 electrons from some other element to reach that stable level, stable configuration. And this is where the catch comes. This is where the versatility of carbon comes in. Because of its tetravalency, what happens? Carbon, since it has 4 electrons in the outermost shell, what it does is it does not lose out electrons, or it does not gain electrons, but it shares electrons. A very interesting characteristic of carbon. And when you share these electrons, it leads to formation of covalent bonding. And another very important idea is that carbon can share its electrons with itself. I told you that carbon is present in different allotropic forms, meaning one carbon atom, if see, how do we represent it? We represent this covalent bonding in dot structure. This carbon atom is going to share one electron with another carbon atom. It is going to share another electron with another carbon atom. It is going to share third electron with another carbon atom, and the fourth electron with another carbon atom. And that's why we find carbon in different configurations, in different structures. The structure of diamond is something like this. The structure of graphite is cylindrical in shape. The structure of buckyball or fullerene is round in shape. But in each and every case, one carbon atom is sharing its electrons with another carbon atom, something like this. Or we can also represent the dot diagram as something like this, where the carbon is sharing electrons. So it shares a pair of electrons or multiple pairs of electrons, not just with itself, but it can also react with other elements. Now, this is a slide from a previous discussion. Now, we saw that element, its atomic number and number of electrons in its outermost shell. Now, I told you that noble gases, they are most stable. If you look at this, they are most stable. They seldom react. Now, the question is with other metals and other non-metals. Now, when you look at carbon, carbon has a valency of 4. Its valency is 4. It has 4 electrons which it can give away or accept, but it does not do that. It shares electrons with others. For instance, chlorine, it can share 1 electron with chlorine. It can share 2 electrons with sulfur. It can share 3 electrons with phosphorus. Or if you look at nitrogen and oxygen here, now to complete octet of nitrogen, to complete octet of oxygen, what happens? This nitrogen, it can accept 3 electrons, oxygen can accept 2 electrons. So nitrogen can share 3 electrons, oxygen can share 2 electrons with carbon to form respective compounds. In fact, please remember, it's not just carbon that forms these covalent bonds. In fact, other elements like hydrogen, they also share electrons. Elements like oxygen. Now, oxygen, you do know oxygen molecule is O2. Now, what is this O2? In this O2, one oxygen molecule, it combines with another oxygen molecule, or it shares electrons with another oxygen molecule to form oxygen atom, to form oxygen molecule, that is oxygen gas. Similarly, oxygen has a double bond. For nitrogen, they share 3 electrons. That's why they form nitrogen gas, N2. It's not just carbon, but others also do this. And that's why carbon reacts with these also, forming a covalent bond. Now, what is this covalent bond? Please remember, we have discussed in our previous interaction, ionic bond between sodium and chlorine, Na plus and Cl minus. Right? These two ions form through an ionic bond. But in case of carbon, a covalent bond is formed. Covalent bond is formed when atom of one particular element and atom of another element, they share electrons. When a bonding is formed by sharing of electrons, sharing of one pair or multiple pairs of electrons, covalent bond is formed. Now, what kind of covalent bonds we observe? We can have a covalent bond which is single bond. That means sharing of one electron from either side. It can also be a double bond, which we classically find in carbon dioxide. Why? Because carbon, it forms a double bond with oxygen. All right, because you do know the valency of carbon is 4. So it forms a double bond with oxygen. Similarly, it can also lead to formation of triple bonds. We find triple bonds in many of the unsaturated hydrocarbons. All right. So covalent bond, very important. Now, we discussed ionic bond before as well. As I told you, ionic bond is formed between two atoms. When atom 1 and atom 2, they transfer electrons to each other, then ionic bond is formed. Ionic bond is because of transfer of electrons, whereas covalent bond is because of sharing of these electrons. Please remember this. All right. Apart from that, there are some other characters which have been discussed here. Ionic bond is normally found between metal and a metal, or a metal and non-metal, but covalent bond is generally found between non-metals. And a covalent bond is because of sharing of electrons, not transfer of electrons. Shared electrons leads to covalent bonds. Transfer of electrons leads to ionic bonds. We have already discussed that the ionic compounds like sodium chloride, they have very high melting point and very high boiling point. But covalent bonded compounds, they have low boiling point and low melting point. Apart from that, we have already discussed ionic compounds are generally crystalline. They're hard and brittle, and they have strong bonds. But the covalent compounds with covalent bonds, they are liquids or gases at room temperature. They are relatively softer, even if a solid substance is formed, that is organic compound. Apart from that, their bonds are normally weaker than ionic bond. Please remember, when I write weak bonds for covalent compounds in comparison with the ionic bond or the metallic bond. In fact, this is the hierarchy of the strength of different bonds that we have. A metallic bond is extremely strong. Then you have ionic bonds at the second number. Now, a little weaker than ionic bonds are the covalent bonds. Then the hydrogen bond, dipole-dipole bond, and London dispersion forces. So we'll talk about these bonds also in our subsequent classes. But do remember this sequence, because sometimes a simple question can be created that metallic bond is stronger than ionic bond is stronger than metallic bond, or with respect to covalent and ionic bonds. Please catch those things. Do not fall in the pit and commit a mistake. Right? When I say do not fall in the pit, it's metaphorical. All right. Right. Let's move on. This is the bond strength, difference between covalent bond and ionic bond. Let's move ahead and talk about carbon and its characteristics. Why carbon is so versatile? Now, by now you have already understood that tetravalency is one of the important characteristics of carbon, which leads to its versatility. Tetravalency means it has 4 electrons which it can lose or it can gain, but it does not do it. It shares it with different elements, different atoms, to create different compounds. So it reacts. It is capable of forming covalent bonds. It's capable of reacting with others like oxygen, hydrogen, nitrogen, sulfur, chlorine, leading to different compounds with different properties. Apart from that, the bonds that the carbon forms with others, they are fairly strong. When I say strong, again, I wrote weak in comparison to ionic bonds, but they are fairly strong in comparison to other bonds that are present. It is stronger than the hydrogen bond itself, right? Now, apart from that, there is one more reason for these strong covalent bonds with carbon, and that is size of carbon itself. Please remember this particular pointer, that covalent bonds of carbon are strong because carbon is of smaller size. Now, this is a very important property that you need to remember from MCQ perspective. The larger the atom size, larger the atomic size, weaker would be its covalent bonds. Please remember, and smaller the atomic size, stronger would be the covalent bond. Now, it makes sense also. If the atomic size is smaller, that means at the nucleus where there is positive charge, it is going to hold the shared electrons together, making the covalent bond more strong. It's a very important pointer from exam perspective. Now, apart from tetravalency, there is one more important property of carbon. It is called as catenation. Now, catenation is a self-linking property. As I told you that carbon can share its electrons with itself, or it can share its electron with other elements, other atoms as well. When it forms a bond with itself, it is called as catenation. And catenation is a property because of which carbon can form bonds and leads to formation of larger molecules, and these larger molecules, they give rise to different kind of compounds. Now we call hydrocarbons. Now it has the property to first of all form a bond with itself and bond with hydrogen. That is why in our organic chemistry, we have so many compounds which are carbon dioxide and hydrogen itself. We call them hydrocarbons. Why do we get them? Because of the property of catenation. That means we can add hydrogen to it, we can add more carbon to it, we can add other compounds as well. We'll talk about these hydrocarbons in some time. So carbon is versatile because of 2 reasons. First one is because of tetravalence, and the second one is because of the property of catenation, where it can lead to formation of different kind of branched molecules. For instance, carbon can lead to a straight chain carbon compound. Carbon can lead to a branch chain carbon structure. It can also lead to different branch chain carbons, something like this, or it can also lead to cyclic carbon compounds. We'll talk about them in some time, but I hope that you have already gained the insight that carbon is very versatile because of 2 reasons: tetravalence and the property of catenation, right? So you need to remember, if I ask a question MCQ that what is catenation? What is catenation? Catenation is a self-linking property of an atom where it can link with itself through different bonds. It can link with itself or it can link with others as well. So if it links with itself, it forms a branch structure. Carbon has the ability to do it. Now, apart from carbon, there is one more compound you can see here. Now, in addition to carbon, atoms may be atoms of different, say specifically silicon. It can also lead to some sort of catenation, but silicon-based compounds are rather unstable. Carbon compounds are much more stable. Silicon also has this property of catenation, right? Now, let's talk about organic and inorganic compounds, because due to this property of catenation of carbon, we find many carbon and hydrogen based compounds, and these carbon based compounds which occur mostly in nature, they are called organic compounds. Now, organic compounds are those that contain carbon usually bonded with hydrogen. For example, there is methane, ethane, ethanol, propanol, all these organic chemicals. Inorganic compounds or inorganic chemistry basically deals with inorganic compounds that don't have carbon. But please remember, when we talk about organic and inorganic compounds in general are compounds that contain carbon and that occur naturally. Apart from that, inorganic compounds, it includes carbides, oxides of carbon, carbonate, and hydrogen carbonate. Please remember, carbon compounds except for carbides, oxides of carbon, carbonates, hydrogen carbonates, they continue to be studied under organic chemistry. Apart from these, apart from carbon dioxide, carbonates, and other cyanides, carbides, they form part of inorganic chemistry. So organic chemistry means compounds that are composed of carbon in general. That's the general formula or general understanding. All right. Now let's talk about these hydrocarbons itself. That means we are entering the domain of organic chemistry. What are hydrocarbons? Hydrocarbons are a class of organic chemical compounds that are composed only of carbon and hydrogen. Carbon atom joins together to form a framework. As I told you, carbon can undergo catenation. Carbon can also form bonds with hydrogen. All right. So compounds in this particular form, in this framework, classic example, right? So hydrocarbons are the primary constituents of your petroleum, your gas. The LPG that comes at your home, that is nothing but hydrocarbon itself. Now LPG is predominantly composed of propane and butane, right? Largely propane and butane. Those are nothing but hydrocarbons. Hydrocarbons are also part of living system. Hydrocarbons, they occur in nature, they are present in plant itself. They form different pigments. For example, carotene. Carotene is that orange. You find that in the carrot, the orange or the reddish color is because of these hydrocarbons itself. Apart from that, hydrocarbons are present almost everywhere. As I told you, this cloth, cellulose is nothing but hydrocarbon itself, an example of hydrogen, carbon, and oxygen element. But when you talk about, say, rubber, right, naturally occurring rubber, that is nothing but hydrocarbon itself, right? So it is present almost everywhere. Hydrocarbons are also present almost everywhere. So the next question is, sir, how do we classify these hydrocarbons? Hydrocarbons are classified in two categories. One is saturated hydrocarbon. Now, saturated hydrocarbon is one in which that compound will have only single bond between carbon, only single bond. So saturated hydrocarbon means which have single bonds. You can note here, saturated hydrocarbons, example is alkane. But once any carbon or any pair of carbon, they have double bond or they have triple bond, then they become unsaturated hydrocarbons. Now, saturated hydrocarbons, unsaturated hydrocarbons, that is from the perspective of carbon atom or carbon element, where in this sense means if there are just single bonds, then one atom of carbon, it has been saturated to 4 different bonds. But here there is only, in these cases, there is double bond or triple bond formation, because the other conjugate element or conjugate atom, it is in deficient quantity. That's the basic understanding. Meaning unsaturated hydrocarbons are the ones which have double bond, triple bond. Just remember this particular factoid. All right. Now, the next thing, how do we name these hydrocarbons? Because hydrocarbons are a class of compounds and in different framework because of the catenation property of carbon. How do we go for nomenclature of hydrocarbons? The first thing that we see is the number of carbon atoms. Now, if number of carbon atoms is 1, we use a prefix called as meth. Meth. If the number of carbon atoms are 2, then eth, 3 prop, 4 butane, but right, 5 pent, hex, hept, oct, non, dec, right? Then what is the corresponding conjugate of this carbon? We try to see that. We try to see what is the conjugate or what is the different functional group to it. If it is just hydrogen, if it is just hydrogen, if it is saturated, then there is a nomenclature procedure. If it is saturated, if all hydrogen bonds have saturated the carbon, then we call them in short as alkanes. That means I call it methane, I call ethane, I call propane, butane. And if they are unsaturated, then we call them alkenes and alkynes. Apart from that, if the functional group is different, for example, if the functional group is the alcohol group, then I use all in front of it, methanol, ethanol, right? I use that depending on the functional groups. All right. So based on this nomenclature of hydrocarbons, I create different homologous series. Now, homologous series of hydrocarbons is a series or a collection of organic compounds which are identical in structure and identical in chemical characteristic, but they only differ in a CH2 group which is missing. Now, if you have not understood what is the meaning of homologous series, then let's look at an example. Now, a homologous series of alkanes is this. Nomenclature we have understood. There is only one carbon atom, that means meth. Then homologous series, where you see that all the carbon atoms here, they have saturated. That means for one carbon there are basically four hydrogen atoms here. That means saturated hydrocarbon, and we give name it as methane. So if we look at this homologous series, there is methane, ethane, propane, butane, pentane, hexane, heptane, right, octane. You go in that particular series, this becomes the homologous series of alkanes. Now, if you look at the difference between methane and ethane, you will see that the difference is only CH2. That's the basic idea. Similarly, alkenes are hydrocarbons which are unsaturated. Now, you will see here ethene, propene, butene. Look at this suffix. The prefix would be very similar, right? The first one would be methane, right? All right. Then you have got alkynes. Now it should be alkynes. Something missing here. The same stuff has come here. Do not refer to this particular part. But when you look at alkynes, you will get ethyne, propyne, butane. They're called as alkynes because of the nomenclature we saw the suffix. Apart from that, depending on the functional grouping that we have, we give the name to hydrocarbons as if there is a conjugate or if there is a functional group chlorine or bromine, that is called as haloalkane, haloalkene. If there is alcohol group, that means OH group, we name it as all. We give an all suffix to it. Let me give an example. If it is a haloalkane, meaning there is a combination of carbon and halogen, that is chloride. So we have examples of CCl3, that is carbon tetrachloride, CCl4, carbon tetrachloride is there. Chloroform, that chloroform is a compound which is haloalkane, CHCl3. This is chloroform. You have different alcohols. Whenever there is OH group like this, the functional group, then we suffix it with all. That means propanol, butanol, ethanol, methanol. If there is aldehyde is CO, we give it propanol, methyldehyde, acetaldehyde, formaldehyde. If you have a ketone group, you give it ONE. Here it is propanon, butanon. Carboxylic acid, if it has carboxylic acid group, then we give it oic acid. We name it as oic acid. methanoic acid, ethanoic acid, propanoic acid. We'll talk about these later on also. So you have alkenes and you have alkynes here. Now it should have been here, it should have been alkynes, right? Alkynes, both have been alkenes here. That's a small mistake. But if they are alkynes, we give it a suffix YNE, propyne, butane, methane, right? So that's the nomenclature. Apart from that, hydrocarbons in cyclic structure, they are of two categories. Hydrocarbons which are in cyclic framework, cyclic hydrocarbons, alicyclic hydrocarbon and aromatic hydrocarbons. Now alicyclic are the ones which are basically the alkanes which are in cyclic format, cyclopropane, cyclobutane, cyclopentane, whereas aromatic hydrocarbons are the cyclic compounds of carbon and hydrogen, like benzene, naphthalene, benzaldehyde, acetaldehyde, etc. Right? Sorry, not acetaldehyde, benzaldehyde. All right. So this is the example of cyclic hydrocarbons. Now, the next thing that we are going to discuss is the chemical properties of these hydrocarbons. The first property, combustion. Now, as I told you, hydrocarbons, they form majority of fossil fuels, or your what you extract from your fossil fuels. The gas that you extract, it has hydrocarbons. In petroleum, you have hydrocarbons. That means they burn. So how do they burn? They mix with oxygen to give you carbon dioxide, to give you water, and to give you heat and light. So they undergo combustion. They undergo combustion reaction. They combine with oxygen to give you these compounds. In fact, when you look at hydrocarbons, you will see that the saturated hydrocarbons, they always burn with a clean flame. That is why in your LPG you have butane and propane. When you burn LPG, it gives you clean blue flame. But if a hydrocarbon is unsaturated, then it burns with yellow flame, giving you a lot of black smoke. But in general, be it saturated or unsaturated, if you do not provide it enough oxygen or enough air, then there would be incomplete combustion. That means some amount of soot or black substances would be released for sure. That is why you must have seen whenever your gas nozzle or your whenever there is air which is in deficient amount, you will see that on your cooking utensils at the bottom, you will see some deposit of black soot or some black deposition at the bottom. But in general, remember, saturated hydrocarbons, they burn with a clean flame. Unsaturated hydrocarbons, they burn with a yellow flame, giving a lot of gases. We have fuels such as coal and petroleum. They not just contain carbon and hydrogen, but they also contain different impurities. They also contain nitrogen, sulfur. So when they are burned, you get a lot of pollutants like oxides of nitrogen and oxides of sulfur. That leads to pollution. All right. Now, apart from this, when you look at oxidation of these hydrocarbons, this is basically ethanol. Now, ethanol can be oxidized by strong oxidizing agents like alkaline potassium permanganate or potassium dichromate, acidified potassium dichromate. Now, in such scenario, the ethanol can basically lead to acetic acid. It leads to formation of acetic acid. So alcohol is transformed into an acid through oxidation by strong compounds or strong reagents. Apart from that, addition reaction. This is very important. Addition reaction. Now, addition means addition to add hydrogen in presence of some catalyst to a hydrocarbon. When I add hydrogen to it, it is called as hydrogenation. How can I add hydrogen to a hydrocarbon compound? It is through some sort of a catalyst. Catalyst is something that enhances the rate of the reaction, that aids in the reaction. Now, for hydrogenation reaction, we use catalysts like nickel or palladium, and we have seen these experiments in our day-to-day life as well. Now, hydrogenation of vegetable oil is very prominent in our everyday life. Vegetable oils are generally liquid form, right? Liquid form. But once we process vegetable oil through hydrogenation reaction, then it leads to solidification of that oil. So transportation becomes very, very easy. So vegetable oil, when it is proceeded through this hydrogenation reaction by using nickel catalyst, it leads to saturated hydrocarbons. Please remember, vegetable oils that we consume, they have unsaturated fatty acids. But once we push them through the hydrogenation reaction, it leads to saturated fatty acid. Now you must be thinking, sir, in case of fuels, if it was a saturated fuel, it gave clean flame. If it was unsaturated fuel, then it gave yellow flame. But when it comes to fats, do remember the pointer that for our body, when I talk about fatty acids, when I talk about lipids, I would like to have unsaturated fatty acids because they are good for our health. Unsaturated fatty acids are found in vegetable oil. We have the mustard oil, we have sunflower oil, safflower oil, groundnut oil. Those have unsaturated fatty acids which are good for our health because the fat deposition does not occur in our blood vessels, in our arteries. Why? Because liver is able to take the fat, because these unsaturated fatty acids, they contain high density lipoprotein, and this high density lipoprotein, it can also help in elimination of the other low density lipoprotein that we consume, because liver helps in detoxification of that. But once our body starts to accumulate these saturated fatty acids, they would be stuck in our body. Cleaning them becomes very tough. Then it leads to different diseases. That's why hydrogenated oils, it should not be consumed. Remember that our vegetable oils that we have, they are unsaturated fatty acids, and when we run them through the hydrogenation reaction by using nickel catalyst, it leads to creation of saturated fatty acids, and many saturated fatty acids, they are trans fat. Now you must be thinking, sir, if this is the case, then why do people do it? See, because the trans fat or the hydrogenated oil, it is easy to transport. It has longer shelf life because it solidifies at room temperature. When you heat it, it becomes liquid. It solidifies at room temperature. Meaning, when you fry food in it at room temperature, there would be a layer of oil which would be on that food. So the food and its shelf life is also enhanced. Apart from that, it also acts as taste enhancer. That's why people consume a lot of hydrogenated oil. That food, it tastes good, right? The normal samosas that you have, the chola bhatures that you have, the fried food that you have, it will have a lot of saturated fat, especially the street foods that we have. And do remember that WHO has a limit that you need to have trans fat, which is approximately 5 gram per day. If it breaches 5 gram per day, then that fat, it would not be removed from your body very easily, and it would be deposited in your body. It would be deposited in your blood vessels. It would be deposited in your arteries, and if it enters into your coronary artery, it starts depositing there. It leads to disease, finally heart failure, heart stroke as well. So please remember that trans fat is one of the main ingredients in the food processing industry. Although these days you will find that there have been many rules and regulations, and a lot of food products that you buy, you must have seen zero trans fat or trans fat free. In fact, Vanaspati, or the colloquially we call it Dalda. It's actually a brand name, but Vanaspati is the product. Dalda have recently, a few years back, they announced that they are also trans fat free. But do remember, from health perspective, unsaturated fatty acids are good for our health. Saturated fatty acids are not very good for us. There is a limit to the amount of saturated fatty acids that we must consume. All right. Now, apart from this, the hydrocarbons, they can also undergo substitution reaction. Generally, hydrocarbons are fairly stable, fairly unreactive, but when we add chlorine to it, the halogens, then substitution happens, and we get carbon, hydrogen, and chlorine based compounds, right? We have a carbon chlorine compound, as I told you, CCl4, which is used in cleaning industry. Carbon tetrachloride is used in cleaning industries. We have CCl3, which is nothing but chloroform. You must have seen in movies. Put chloroform on a handkerchief and person will become unconscious. So these compounds are created through substitution reaction. All right. So these are some of the characteristics of carbon hydrocarbons. And now let's talk about some of the commonly used compounds in our day-to-day life. Let's talk about their characteristics because it's very important. In our day-to-day life, we have so many hydrocarbons that we use. One of them is ethanol. You must have heard about ethanol. Ethanol is the second member in the homologous series of alcohol. Please remember, homologous series simply does not mean alkane, alkenes and alkynes. Homologous series can also be of alcohol, meaning methanol, ethanol, propanol, butanol, pentanol. That is also homologous series. Or for example, say acid, methanoic acid, ethanoic acid, right? Propanoic acid, butanoic acid, that also becomes a class of homologous series. So in the homologous series, the second product is ethanol. Ethanol is ethyl alcohol. Now, ethyl alcohol can be prepared by fermentation of molasses. You know that in a sugar industry or a sugar factory, you get molasses. By fermentation of that molasses by yeast, you ultimately get ethanol or ethyl alcohol. The molecular formula of ethanol is C2H5OH. All right, C2H5OH. Now, OH is this functional group that is represented. That's why ethanol. Now, when we talk about ethanol, ethanol has certain characteristics. First thing is ethanol is also a covalent compound. Ethanol is less denser than water, a little less denser than water. Its density is about 0.8. It has very low boiling point. Ethanol's boiling point is around 78 degree itself. And ethanol generally has a little unpleasant smell, not depending on the person. Some people might like that smell, okay? But jokes apart, ethanol has unpleasant smell and it has burning flavor in terms of taste. If you drink ethanol, it has burning effect throughout your body till it reaches your stomach. Because stomach itself is acidic, right? Now, apart from that, ethanol is neutral in general. It is neutral in nature, meaning if you put litmus paper in it, it is not going to turn its color. It is neutral. Its pH is around 7 itself. Apart from that, ethanol is extremely flammable. Now we have seen that hydrocarbons, they burn. Ethanol burns. Ethanol, when combined with oxygen, it burns in presence of air. It gives you carbon dioxide, it gives you water, it gives you heat and light. The same reaction that we saw when hydrocarbons are burned. So it burns, it gives you carbon dioxide, water, light and heat. Apart from that, it also undergoes oxidation. We saw the oxidation reaction. Hydrocarbons can be oxidized using strong oxidizing agents like potassium permanganate or acidified potassium dichromate. This leads to creation of acid. That means ethanol, ethyl alcohol, it gets transformed into ethanoic acid. Ethanoic acid is nothing but the acetic acid. In our common colloquial language is called acetic acid as well. Apart from that, ethanol can also react with sodium. Alcohols react with sodium, leading to evolution of hydrogen gas. How to understand hydrogen gas? You simply burn it. It will burn with a pop sound, right? So it leads to formation of sodium ethoxide. So ethanol reacts with sodium. Ethanol also reacts with or ethanol also, when we heat it in excess sulfuric acid, ethanol from a saturated compound, it leads to becoming unsaturated. So it gives ethene. So when we heat it in presence of a strong acid, then saturated product is transformed into unsaturated hydrocarbon, that is ethene. These are some of the common reactions of ethanol. Now, apart from this, ethanol in our day-to-day life, we see it often. You must have seen a drunk person who's completely drunk on alcohol. They do not have consciousness, or they do not know what exactly is happening, because ethanol is present in their body. They have consumed ethanol, not pure ethanol, of course. They have consumed ethanol in form of that alcohol. All right. So in our day-to-day life, when large quantities of ethanol are consumed, then it impacts your central nervous system. It depresses your central nervous system. It leads to mental confusion, right? People feel light. Yes, it leads to lowering of inhibitions. You feel drowsy. That's why people have a habit of consuming alcohol, because because it relaxes the central nervous system. It leads to inhibition, it leads to lower inhibitions, and you sometimes, if you consume too much, you lose sense of judgment as well. And ethanol is the prime constituent of that alcohol industry. Ethanol, whatever people consume, be it beer, whiskey, whatever, ethanol is the prime constituent of it. Of course, pure ethanol should not be consumed. Remember this, pure ethanol, if it is consumed, then it will harm a person more and more. Similarly, there is another alcohol, that is methanol, right? Methanol. Now, methanol, that is the first in the homologous series. Methanol is actually poison. If a person by mistake consumes methanol in the body, it leads to creation of methanol in liver. And when liver creates this methanol very quickly, rapidly reacts with the different components of cells, and it coagulates the protoplasm. That means in your cell, the protoplasm, it coagulates and stops working. The cells start to die, and ultimately it affects a person and may lead even to death. You must have seen in news so many times the idea of local alcohol. Have you seen it? Right? In many cases, the local alcohol that is created, it has heavy quantities of methanol, and people consuming methanol, they die. Right? You must have seen deaths because of the fake alcohols or the local alcoholic drinks that people create. So alcohol has this effect. Apart from that, ethanol or ethyl alcohol is also produced largely in industries. Now, this industrial ethanol should not be diverted towards other purposes. That's why ethanol is mixed with methanol, or many a times, to identify it, there is some sort of dye or some sort of reagent which is added to it, right? And such alcohols are called denatured alcohol. When dyes are added, you get blue color so that it can be easily identified. This alcohol is called denatured alcohol. Denatured alcohol. In fact, this ethyl alcohol is used in many industries. You must have seen during COVID-19, a lot of sanitizer was used. Sanitizer has alcohol in it, ethyl alcohol. Now, apart from this, ethanol can also be used as fuel. As I told you, ethanol burns. It undergoes the combustion reaction. It burns with air to give you carbon dioxide, water, heat, and light. So, alcohol can also be used as fuel. And that is why you must have seen the government is running a very important program, that is blending, ethanol blending in your petrol. Right now, ethanol is being blended into petrol, and the government has suggested that they are going to blend up to 20% of ethanol in petrol. Slowly and steadily, we are reaching towards that target. Already 5% ethanol blending is already happening, and that's why ethanol is being produced more and more in our sugar industry. The sugar factories, the cooperative sugar factories that are running, those are producing ethyl alcohol, ethanol from the molasses, and they are supplying that to the oil companies. That means the fuel that you are using right now, or which we will be using in future, it will have 80% petrol plus 20% ethanol. And for this, there is no need to change the engine composition, or slowly and steadily, if we try to increase this amount, we need to move towards changes in engine as well. All right. So this is some idea that you need to know, because when you're preparing for UPSC civil service examination, you need to understand that ethanol blending in petrol, it has its own set of advantages and it has its own set of challenges. You can read about the case study of Brazilians, how Brazilians have introduced different flexi fuel engines in their country. You can always read about that, right? Now, apart from ethanol, there is also acetic acid or the ethanoic acid. I told you that you oxidize ethanol using a strong reagent like potassium dichromate, it leads to ethanoic acid. Ethanoic acid is nothing but acetic acid. Now, acetic acid is a part of carboxylic acid group. Now, carboxylic acid groups are those acids which are generally found in nature. Right? For example, the citric acid, the oxalic acid, the folic acid, very similar to acetic acid. Now, acetic acid, when you add to water, 5 to 8% solution of acetic acid in water, this is called vinegar. Have you used vinegar in kitchen? Of course, you must have used. Vinegar is a common compound in many of the kitchens. The melting point and the boiling point of, again, acetic acid are quite low. Melting point of pure ethanoic acid is about 290 Kelvin, and it often freezes during winter. All right. So as I told you, carboxylic acids are those acids which are found in nature, and we have already discussed those are weak acids. That means in an aqueous solution, they do not ionize completely. Strong acids like mineral acids or inorganic acids like hydrochloric acid, sulfuric acid, they ionize completely in aqueous solution. So these carboxylic acids are weak acids. Now acetic acid, it undergoes different kinds of reactions. When acetic acid is subjected to esterification reaction, esterification means acetic acid mixed with ethanol, ethyl alcohol under acidic condition, it leads to creation of different esters. And these esters are used in production of soaps. These ester based compounds are used in perfumes. They give good fragrance. They are used in making perfumes, and on treating with sodium hydroxide, which is basically an alkali, they would all again be converted back to alcohol. They can again be converted to alcohol as well. But this is basically the esterification reaction of ethanoic acid. Apart from that, when it reacts with a base, when ethanoic acid reacts with a base, you do know acid and base is nothing but neutralization reaction. Neutralization means it leads to formation of salt and water. What salt is formed here? Sodium acetate. When you add sodium hydroxide to acetic acid, it leads to formation of a salt, sodium acetate and water. Sodium acetate is again a very important compound. It is used in many industrial applications. For example, sodium acetate is used in textiles. It is used as disinfectant also in many cases. Similarly, when acid reacts with carbonates and hydrogen carbonates, it again leads to formation of salt plus water releasing carbon dioxide. We have learned this when we discussed about acids. I hope you remember that. Do you remember? When acid, that means ethanoic acid, when it reacts with carbonate or hydrogen carbonate, it leads to formation of different salts. Same again, sodium acetate is formed. I told you applications of that. All right. Now, apart from ethanol, ethanoic acid, we regularly use soaps and detergents, right? We regularly use soaps and detergents. Have you taken bath today? You must have used some sort of soap, probably Lux, right? You must have used Lux soap, very very prominent example. Or these days, say a costly soap like the Dove soap, right? Dove soap or Synthol, whatever soap you use. Soaps and detergents, they are produced by saponification reaction. Saponification reaction happens between sodium hydroxide, basically some base, sodium hydroxide or potassium hydroxide, and vegetable or animal oil. That means some ester. So when I add ester and a base, it leads to creation of alcohol and soaps. Please remember this. That's why we discussed this esterification reaction. From ethanoic acid, we got esters by reacting that with base. Now when ester further reacts with base, it leads to formation of soap. Now this is saponification reaction. So soaps and detergents are produced by saponification reaction. Now, what are the characteristics of these soaps? Now, you do know soaps generally, if I just think from common sense, soaps, when I mix it with water, I get lather, right? They have property of lathering. They give this kind of foam, right? Soaps, I have generally seen that soaps are solid material, right? Solid material, they are hard material. They have cleaning property. Now, once it gives lather, they clean stuff. What do they clean? They clean dirt. They clean other oil. Say, for example, if you have oil in your hand, you take detergent or you take hand wash and you wash your hands, and you will feel that your hand is dry now. There is no soap, there is no oily feeling. Apart from that, these soaps have fragrance. Why? Because they are made from esters. After esterification reaction, esters are produced. Esters are fragrant. Now, this is the raw material for that. These are the basic characteristics. Now, the most important characteristic of a soap or a detergent is cleansing action. Now, why does this cleansing action happen? Because soaps lead, when soaps or detergents, when put into water, they lead to formation of micelle. They lead to formation of micelle. Now, what is this micelle? Now, micelle is a reason because of which we get that cleaning action. When soap is added to water, it leads to formation of different micelles. Now micelles are basically compounds which lead to formation or a structure something like this, where every micelle it will have two ends. One end is hydrophilic, that means it likes water. Hydrophilic, it likes water. And the other end is hydrophobic, it does not like water. So what happens soaps or detergents, when they are added to water or in water, they lead to formation of micelle structures. Micelles, now these micelles, they form, or they align in such a way that the hydrophobic ends, meaning one that is not water. And what is not water in your cleaning action? Oil is not water. What is not water? Dirt is basically not water. So the hydrophobic part of this micelle, it will hold on to the dirt, it will hold on to the grease, it will hold on to the other impurities. And once we clean it along with this micelle, you will see the grease, dirt being taken away with this micelle itself. Because of this micelle formation, because of micelle action, we see, or we get, or whatever you pronounce, micelle or micelle, right? Because of this micelle action, we have cleaning of clothes, we have cleaning of utensils, we have cleaning of your hands, because this micelle will take away dirt along with it, because of this hydrophobic end. Please remember, it will have hydrophilic end and hydrophobic end. So hydrophobic end, soap molecule, it will have two ends, hydrophilic end, hydrophobic end. And the hydrophilic, it loves water, or it likes water, it will be with water. But the other part, it attracts the dirt, and when we wash it, everything goes out with that. All right, that's the basic idea. Clear? So we have seen carbon based compounds, we have seen hydrocarbons, we have seen saturated hydrocarbons, unsaturated hydrocarbons, their different chemical properties. We also discussed about some common compounds that we use: ethanol, ethanoic acid, that is acetic acid, and soaps and detergents. That's the basic completion of our NCERT chapter 4. As I told you, very important one. And this basically forms our chemistry background or chemistry knowledge required for civil service examination. All right, now let's take up some questions that can be formed on this. Questions which have come, I've seen in UPSC old pattern, some questions have appeared from chemistry from these parts, but many times questions have appeared in state PSC. All right, so here is one question: most carbon compounds are good conductors of electricity. You have to consider these statements. First one is, most carbon compounds are good conductors of electricity. Second statement reads, most carbon compounds form covalent bonds which are stronger than ionic bonds. All right, and you have to tell me which are correct, incorrect. Do let me know the answer for this in the comment section. I'll give the answer for these questions on my Telegram channel. The Telegram channel ID is this again, Rahul SAI 222. I'll also post these questions on my Instagram as a story also. Okay, so you can follow there and you can get the answers. Again, I would put this question as relatively easy. I have already given you a hint that you have to find incorrect ones. The second question is, a soap molecule has hydrophobic head, hydrophobic tail, hydrophobic head, hydrophilic tail. Again, from these options you can check the answer. Again, this is a very simple question, The next question, I would put this question in moderate category. All right, consider the following statements. Saturated hydrocarbons are the ones where valency of carbon is satisfied by single bonds only. Saturated hydrocarbons are the ones where valency of carbon is satisfied by double bonds only, and you have to tell which of the statements are correct. I hope through this interaction you have already gotten the answer. All right, you have already gotten the answers of these questions. These are fairly easy questions. Do attempt them in the comment section and you'll get the answers here. All right, I told you our discussion is about periodic classification of elements. Now, where have you heard this term element? In our earlier interactions, we discussed about pure substances. Do you remember? we discussed pure substances, and one of that was element. We saw mixtures there. Mixtures are not pure substances. Elements are pure substances. And why did we say elements are pure substances? Element. Now, element, it contains atoms of only one type. Atoms of only one type. For instance, I say oxygen. Oxygen as an element, it contains atoms only of oxygen, no other atoms. All right, those are pure substances. And throughout our history, slowly and steadily, we came to know about more and more elements. For instance, we came to know about iron during the Iron Age. During the Chalcolithic Age, slowly we came to know about copper. From ancient times, we knew about gold, silver, very valuable elements. We knew that gold and silver, they do not react much, but there are some other elements which react. So slowly and steadily, we were building our database of chemicals, database of these elements. Today, if we talk about different elements, there are about 118 elements, and majority of these elements, they occur in nature. Some of the elements have been synthesized in the lab. But since the beginning of the modern period, different scientists, different chemists, they started their voyage of classification of these elements. Now they thought that some elements, say like gold and silver, they do not react, but some elements, say chlorine, bromine, others, they immediately react. So can I categorize these elements into one group or some kind of classification where I get to know more about the properties of these elements if I group them together? So classification always helps. All right. So scientists began classifying. Initially, there was very crude level of classification, but slowly and steadily that classification or the categories, they refine, and today we find modern periodic table. So what are we going to discuss in this chapter? We are going to discuss the journey of making order out of chaos of different elements. So how have we developed modern periodic table? Initially, scientists like Dobereiner, they gave different laws. He simply classified them as triads. From Dobereiner's triads to Newlands law of octaves. Again, a very non-scientific idea, but quite effective. We'll talk about Newlands law of octaves. Then Mendeleev, the Russian scientist who laid the foundation of modern periodic table, I can say. So he gave Mendeleev's periodic table. Later on, we improved over that, and mostly later on Niels Bohr, they contributed a lot towards the evolution of modern periodic table. So this has been the journey of classification of elements. So let's try to understand one by one. First one is Dobereiner's triads. Johann Wolfgang Dobereiner, by name itself, a German chemist, a German scientist. He studied in University of Strasbourg. So he attempted, one of the earliest ideas was to attempt classification of elements which can be clubbed together based on physical and chemical properties. So what Dobereiner did was he gave the law of triads. He said that he can group elements which have similar chemical properties, similar physical properties on the basis of the atomic mass. Remember, he categorized on the basis of atomic mass, and he put them in categories of 3. Triads means 3 elements put together. Right. He gave a law. Dobereiner's law of triads, it basically says that elements, when arranged in the ascending order, that means increasing order of their atomic weights or atomic masses, you will see that the middle one, the middle element, will always be or will always have the mean of the atomic masses of top and bottom. That's the basic idea. And it is quite impressive. Now, if you look at his time period, it is 1780 to 1814, probably just the beginning of 19th century. So at that time, he categorized or he grouped elements into one category on the basis of their physical and chemical properties. Look at this. Now, he categorized lithium, sodium, and potassium. He put them in one triad or one group, and they have similar properties. Yes. And he said that if you look at their atomic masses, people at that time knew atomic numbers and atomic masses. Slowly and steadily, that idea was known. So categorization is based on atomic mass here. If you take average of first and the third, you will get the second element. That is what Dobereiner said. Right? He gave 5 triads basically. Initially, he only gave 3 triads. Calcium, strontium, barium were put in one group. Chlorine, bromine, iodine, quite impressive. Halogens were put in one group, where you can see if you take the arithmetic mean of first and third, then you will get the weight, closely the weight of the second one. Not very accurate, but still we need to give him some credit. He also created other groups like sulfur, selenium, tellurium, iron, cobalt, nickel. Again, these metals, they were put here. All right. Now, you already understand that there are a lot of limitations, or there are a lot of limitations of Dobbe-Naes triads, right? Now, what are the limitations? First of all, very limited amount of classification is done. Very limited amount of classification is done, and it does not hold true for other elements which were slowly and steadily being discovered. So what happened was another method of classification was developed. Now, this was developed by John Newlands. John Newlands was a British chemist, and at that time in 1864, when he gave his Newlands law of octaves, there were about 62 elements that were known. So what he did was he arranged these 62 elements from 1 to 62 in the ascending order of their atomic masses, again on the basis of atomic weights. Please remember, I am specifying here atomic weight or atomic number. Again, Dobbe-Einer, atomic mass, same with Newlands. He arranged them in ascending order of their atomic masses, and he said that every eighth element has similar properties. That is basically the law of octaves. Law of octaves states that elements that are arranged in ascending order of their atomic masses, every eighth element has comparable properties, comparable physical and chemical properties. Now, this was quite interesting. Now, you would be thinking, so why did he say every eighth element, and is there any merit to it? See, Newlands concept of these octaves was based on the musical notes. Now we have musical notes sa, re, ga, ma, pa, da, ni. Those are 7 notes. So he said after 7, the 8th note or the 8th idea, that's why it's law of octaves. Now very similar to how we have sa, re, ga, ma, pa, da, ni. In the Western tones, they have do, re, mi, fa, sol, la, ti. All right. So when he categorized, when he created this table, he categorized and he put eighth element in one particular group. You can see here fluorine comes here, chlorine comes here, bromine comes, but some other elements also come. But you will see that to some extent, yes, okay, we can understand, because we do know the idea of octet now. Now we can talk about octet, because every element, it tries to achieve that stable configuration or stable octet that the noble gases have. So based on these musical notes of sa, re, ga, ma, pa, da, ni, he said that every 8th element, its physical and chemical properties would be comparable. But there are many loopholes in this particular theory. First of all, the entire idea itself is non-scientific. So many scientists, they initially ridiculed this idea of how can elements be classified on the basis of musical notes. So scientific community was a little skeptical about that. Apart from that, you see a big loophole here itself, where you group hydrogen, and hydrogen, again, in the modern periodic table also, hydrogen has a very peculiar position, number 1 itself. You will see that. But fluorine, chlorine, bromine, this is very fine. But what are cobalt and nickel doing here? That's the question. There are many loopholes, and again, his idea, it holds true up to some level, only up to calcium, right? Only up to calcium, it is quite okay. But after that, slowly and steadily, the law of octave fails. The law of octaves, it fails. Added to this, if you see the time period, many new elements were continuously being found out. So one of the most important attempts towards classification was done by Dmitry Ivanovich Mendeleev. Now he started classifying the elements not just based on their atomic mass, but even looking at some other properties, and he created his own periodic table, right? Periodic table. Why? Because Mendeleev's principle, it first of all rejected Newlands law of octaves. He did agree that the periodic table elements, they have to be classified, they have to be based on atomic mass. Agreed. But not just atomic mass. Apart from atomic masses, we will also look at some of the fundamental physical and chemical properties. And based on these, that is based on the atomic mass, based on the physical properties and chemical properties, what Mendeleev did was he created a table. he created a table. Now, when you create a table, you do understand table has certain rows and it has certain columns, correct? So the rows that he created, he gave them the name as period, and the columns that he created, he gave them the name as different groups. That means he put elements in different groups and in different periods. So what he created was, he created a table like these. That means groups. There were different groups like group 1, group 2, group 3, 4, 5, 6, 7, 8. He created 8 different groups and he created periods in the vertical side. And he started to fill these elements. And by that time, more than 60 elements were already known. So he started to put these elements, say hydrogen was put here. Then there is lithium, beryllium, boron. So he characterized them through periods and groups. Please remember, Mendeleev's periodic table, it laid the foundations of our modern periodic table. All right, let me just show you Mendeleev's periodic table in a different format. These blue boxes that you find, these were the elements that were already known to Mendeleev. Please remember, when he created the table, he did not know about these noble gases. When he created the table, he did not know about gallium, he did not know about germanium, he did not know about all these elements which are there in red. But despite that, he created the table and he left these things empty. Based on his observation, he said there should be some element, he left them empty and he said we will find them very soon. All right. So Mendeleev has contributed a lot towards the development and classification of different elements. That is why there are a lot of achievements. While developing the table, first of all, there were some anomalies. Of course, there were some anomalies. For example, the atomic mass of cobalt and the atomic mass of nickel, they have been mixed, they have been interchanged. But there are different anomalies also, because when you are dividing or when you are classifying on the basis of atomic masses, this was bound to happen. Apart from that, Mendeleev also saw that there were many gaps, because as you can see, there are so many red things which are not known. And for your reference, you can see what Daubeney did initially. Daubeney triads, these are the first Daubeney triads. This is the second Daubeney triad. This is the third triad. This is the fourth triad. You will see that these triads, they come under same groups. So you can see that Daubeney was actually on the right track, but the concept of tabular format, or he did not evolve a more sophisticated kind of classification. So Mendeleev did it. You will see they align, right? They align to some extent. But Mendeleev's biggest credit goes to anticipating, or I would say forecasting, that we are going to find some other elements which are not known to us today. In fact, he named them also wherever they were missing. For instance, there is aluminum, there is silicon here. He saw that below silicon, below titanium, there were some things which are missing, right? There is scandium, gallium, germanium. They were not discovered by that time. He named them without knowing them. What he said was, we need, or we will find some element called as eka-boron. This is the Sanskrit term. You do know Sanskrit numerical for one is eka. So he named them eka-boron, eka-aluminium, eka-silicon, eka. Later on, when we discovered them, these eka-boron, eka-aluminium, eka-silicon were appropriately replaced by the elements that were discovered and based on the different nomenclature. So that is the biggest credit or biggest achievement of Mendeleev, that he anticipated there are some elements, there are some loopholes in my table, but he did not stop there. He gave that table, and later on we slowly and steadily filled it as well. But there were certain limitations as well. The first and the biggest limitation with Mendeleev is this hydrogen atom. Now, when you look at this, he put hydrogen in the first group itself, along with lithium, sodium, potassium, and you can see in the first group you have copper and you have reactive metals. You also have noble metals like gold, silver. There is gold, silver, and other metals. Now you will see platinum on the other side. There are some loopholes. All right. Now these are some of the issues. First of all, hydrogen. Where would you place hydrogen? Hydrogen is one of the biggest flaws or biggest issues with Mendeleevs table. Apart from that, the isotopes were not discovered when Mendeleev gave this periodic table, or he would have further refined his table for sure. But Mendeleev's periodic table, it laid the foundation for our modern periodic table. Now, modern periodic table was developed by Henry Moseley, where Henry Moseley proposed that we need to classify, or we need to put in a tabular format, the elements not on the basis of atomic mass, but on the basis of atomic number rather than atomic mass. Because by this time, different scientific equipments, X-ray, different experimental setup were developed, and Henry Moseley's law is basically dependent on the frequency of the emitted X-ray by that element in the X-ray experiment. He said that the frequency of the emitted X-ray, it depends on the atomic number of the element and not the atomic mass. Please remember that the modern periodic table, it is based on the atomic number rather than atomic mass. And that atomic number, again, we can cross verify that through the X-ray experiment. This was given by Henry Moseley, and later on the entire periodic table and new elements, they were further added, and the periodic table was developed by Niels Bohr. And what we find today as the periodic table is basically this. We have seen this before also in our interaction when we discussed metals, non-metals and metalloids. I have told you that these red, they indicate metals, the blue ones, they are non-metals, and somewhere in the middle, boron, silicon, germanium, arsenic, these are tellurium, these are metalloids. All right. Now let's look at this periodic table, and you need to understand that this is based on the classification of atomic number. Atomic number is the identifier. Now this, again, this periodic table, it has different periods, as I told you, periods. Now when we looked at our Mendeleev's periodic table, we saw that he divided the table in different periods and different groups. Now we have taken the same template that Mendeleev developed in the modern periodic table also by Moseley. We have different periods. We have 7 periods. Now periods are these horizontal rows. Periods are the horizontal rows. All right. Periods are these horizontal rows, and groups are these vertical columns in the periodic table. And we have 18. We have 1 to 18, and the periodic table should be read in this direction. From period, you will see atomic number 1 is your hydrogen, atomic number 2 helium. The atomic number is written here, and you will see lithium, beryllium, boron, carbon, nitrogen. So proper classification based on physical and chemical properties has been done in the modern periodic table. There are 7 periods and 18 groups, and on the basis of this, different groups based on their physical and chemical properties. If you look at this, the 18th row is of the noble gases. You will see helium, neon, argon, krypton, xenon, radon, oganesson. Then you have halogens here. So different groups, you will see they have similar kind of chemical and physical characteristics. And as I told you, majority of these are metals, and this series has the period 6 and the period 7. There are 2 series called as lanthanoid series and actinoid series, and many of these have been rather synthetic elements that have been discovered. But let's look at some of the characteristics of these periodic table. Again, from UPSC Civil Services perspective, you don't need to focus too much on the periodic table or mugging up or anything like that. All right. What you need to understand is some of the characteristics. Now, when I look at any period, what do I see? And when I look at any group, what do I see? See, in a group, I told you they have been categorized. I say halogen, noble gases, etc. But when you look at a period, how valency, how atomic size, and how metallic nature varies. If you look at the valency in a period, if I see this particular period, the valency, it increases. That means it goes from 1 to 4, and again it decreases. It goes from 4 to 0 again. And why 0? Because these are the octets. They do not react. Absolutely 8. The last electron shell will have 8 electrons in it. So it increases from 1 to 4, again 4 to 0. Apart from that, when you look at a period, the atomic size decreases from left to right. Now this is a very important pointer. This is a very important point. Please remember, in a period, the atomic size, it decreases. What is the atomic size? Atomic size means this is the nucleus, and the last electron shell that you get, if you say this is the last electron shell, then this defines you the atomic radius. From the center of the nucleus, this defines the atomic radius. Now the question is why does the atomic size decrease? This is very interesting. Now if you look at the elements in a period, you will see, say, take potassium, calcium, scandium, titanium, vanadium, whatever you take, you will see that the atomic number, it increases by 1, right? Atomic number, it increases by plus 1. That means the number of proton, it increases by 1, and the number of electron, that also increases by 1, correct? The number of electron, that also increases by 1. Now if you look at this, if the number of protons increases, then the size of nucleus would increase. But when an electron is added, is another shell added to it? The answer would be no. If another electron is added, then the same electron will go to this shell itself until and unless that shell is filled. So what is happening? The nucleus size is slowly increasing, but since the nucleus size is increasing, meaning the attractive force of nucleus is also increasing, because of which the electrons would be attracted more and more, and that's why you will see decrease in overall size of the atom. That means the atomic radius will decrease slightly. I hope it's clear. All right. Now apart from that, metallic nature, the metallic nature of element, it decreases as you move from left to right. This is quite understandable. This is very easy also, because if you look at this, if you move from here to here, because periodic table has to be read like this, right? So if you move from left to right in a period, you will see from metals, slowly and steadily you're moving towards non-metals. That means the metallic nature, it goes on reducing. Now similarly, the same properties, if you look for a group, that means in a vertical way, the valency, all the elements in a group shall have same valency, because there will be same number of valence electrons. All right. Now this is interesting, right? In a group, if you see in a group, that's how we have put them on the basis of their physical chemical properties. If you look at this, look at chlorine, bromine, you will see Cl-1. That means the valency would be exactly same here. These will have almost zero valency, because they have achieved their octet. They would not react. Similarly, if you look at any other thing, lithium, sodium, potassium, you will see +1 there, right? Na+1. So the valency would be same in a group. Apart from that, when you look at the atomic size, it grows. Means when you move down in a periodic table, the atomic size will increase. This is quite understandable. It's quite obvious also. If you move in this direction, the atomic size will increase continuously. And similarly, if you move down in a group, the metallic character of element, it increases. As you move from top to bottom. Meaning from top to bottom, you'll find the metallic nature, it increases continuously. Metallic nature increases. All right. So these are some of the basic properties. Apart from that, let's look at some of the other things. The noble gases that we have, right? Helium, neon, argon, krypton, xenon, radon, right? They have zero electronegativity. That means they are extremely stable. They do not accept any electron. They do not lose any electrons. So they have achieved their octet. Apart from that, these are called noble gases. Apart from that, there are 118 elements in our periodic table. Out of that, about 98, I wouldn't say 98. This is again, this is a number that NCERT gives, but somewhere around 90 to 92 elements are the ones which are found naturally. They are found naturally, and about, I would say, 26 to 28 elements, they have been synthetically prepared. All right. Apart from that, the lightest element is hydrogen, and the heaviest element is organoson. This is Og. You will find it here. Its number is 118. Organoson. Just remember some of the facts. They might help you in the examination. But again, from chemistry perspective, do not focus on mugging up, or do not focus on remembering the periodic table, right? That's the basic discussion from the periodic classification of elements. Now, what are these life processes? You do know that cell, which is the structure and the fundamental unit, it has to undergo certain process. For example, reproduction is one of the life process. Metabolism is one of the life process. For metabolism, we need nutrients, be it a unicellular organism or a multicellular organisms like humans. We need nutrients, and then we need to absorb those nutrients so that we survive. So life processes are the processes that are needed for sustenance of life, like nutrition, metabolism. Today we'll discuss about nutrition and metabolism. We'll discuss about what is this respiration. We'll discuss about transportation that is needed for survival of life. What is excretion, excretory system, both in plants and animals. And in our subsequent discussion, we'll talk about reproduction separately, because there is a chapter itself which is dedicated, chapter 8, how do organisms reproduce. We'll talk about the life process of reproduction in our subsequent discussion. So let's begin the first interaction, that is nutrition. Now we have already established that any living organism, be it unicellular or multicellular, they need certain nutrients for their survival. The cell organelles, they need oxygen, they need water, and they need nutrients, that is carbohydrates, proteins, lipids. They need vitamins, they need other micro and macro elements. So nutrition is the general requirement of any organism for energy and for maintenance of the life process. Now we need to maintain our body temperature at an optimum level. We need energy to carry out our basic work, right? Now, when we talk about living organisms, how do they gain their nutrition? When we dissect a little into this topic, we'll understand that living organisms can be divided into two categories broadly. One kind of organisms which can produce their own foods. Those are called autotrophs. And the other category is us humans and animals who rely on other organisms or who rely on other things to get their nutrition. So nutrition or systems of nutrition can be divided broadly into two categories: autotrophic organisms or autotrophic nutrition and heterotrophic nutrition. Now autotrophic means those that can produce their own food. They can produce their own food. The classic example being plants. Now when we divide autotrophic nutrition, we can get two kinds of ideas. One is photoautotrophic organisms or photoautotrophic nutrition, and then the second one is chemoautotrophic. Now photoautotrophic is relatively easy. Classic example being plants. Now what do plants do? Plants use sunlight, plants use carbon dioxide, plants use water, and they create their own food. That is, they create glucose, and the byproduct is oxygen, which we need for our respiration. There are some organisms which can produce their own food, or which can use the nutrition from certain chemicals, especially certain kind of bacteria. We call them as chemobacteria. These use some chemicals, especially the sulfur-based chemicals are used by some bacteria. They are called as chemotrophs, meaning they use chemicals for their nutrition. So autotrophic can be photoautotrophic depending on sunlight, or chemoautotrophic, that is depending on certain chemicals. Then the second category is heterotrophic. Broadly, heterotrophic means they depend on others. They depend on other plants, or they depend on others for their food. The first category is holozoic. That means us. Humans are holozoic. That means they depend on plants for their nutrition. They depend on animals for their nutrition. We can talk about different animals as well. For example, herbivores. The herbivorous animals, they depend on grass. They depend on green plants for their nutrition. Carnivorous animals like, say, lion, tiger, they depend on other animals. They depend on meat for their food. So they are also heterotrophic. There is another category under heterotrophic, that is parasitic. Now these parasites, they depend completely on other organisms for their nutrition without ending them. It's not a prey for them. That means they simply suck out the nutrient or suck out the energy required for them. We have discussed some of the parasitic protozoans, right? When we talked about different cells, protozoans classically come under parasitic beings, and these parasites, they are heterotrophic. They get their nutrition from others. Apart from that, there is another category under heterotrophic, that is saprotrophic. Now saprotrophic, they get their necessary nutrients from dead material. It can be dead plants or dead animals, and the classic example for this is the fungi. Majority of fungi, they are saprotrophs. They get their nutrients from dead organic matter. So this is the kind of nutrition that we get. Now, when we talk about autotrophic, I gave you example. Autotrophic are the plants. How do plants produce their own food? They use sunlight. So plants come under the category of photoautotrophic organisms. They take carbon dioxide from the atmosphere, they take water from the soil, and they take sunlight. Photoautotrophic. Using these three, they produce their own food. That means they produce their own food. Glucose, along with it, a byproduct, oxygen is produced, which is required for us. Now, apart from that, when we talk about this process of photosynthesis, it simply runs through this reaction. As I told you, they need sunlight, carbon dioxide, water, 6 CO2 plus 6 H2O, C6H12O6. This is the basic formula of glucose, or the simplest of sugar, that is the monosaccharide, and then oxygen is released, which is required for maintaining the stability of our atmosphere as well, which is required for our survival as well. Apart from that, there are heterotrophs. Heterotrophs, like other unicellular organisms. Yes, we are also heterotrophs. We rely on others for food. We come under the holozoic category. Now, when we talk about unicellular organisms, let's take example of some unicellular organisms like amoeba and paramecium. Let's try to understand how they get their food or how they digest their food. Now, amoeba, it does not have any regular shape. It can change its shape. You do know that. And whenever there is a food particle which is in its vicinity, what happens? It changes its shape to form pseudopodia. This pseudopodia, it engulfs the food particle, and then eventually that food is completely digested by this amoeba. Similarly, when we talk about other protozoans like paramecium, now paramecium has specific organs for taking in food and specific organs for leaving out the waste materials. This is the classic diagram of a paramecium, where it has certain cilia. Now, using these cilia, it is going to take food inside. You can say that it has an oral groove, or you can even call it oral cavity or the buccal cavity. Once the food enters, then the food goes inside, it is digested, and once the metabolic activity is done, waste material are also produced, and those waste material, they are left out through this anal pore. A very simple kind of unicellular organism which has some input system, digestive system, that means it digests the entire food, and then the waste product is thrown out through the anal pore. So we find simple structures to complex structures, and we are one of the most complex beings, right? In humans, nutrition or the metabolic activity, it is run through the GI tract, or the digestive tract, what we call AI tract, alimentary canal, intestinal tract. Now, it starts with mouth. And the food, once it enters through mouth, we chew it, it enters into esophagus. From esophagus, it enters our stomach. From stomach, it goes into small intestine. From small intestine, which is about 5 to 7 meters long, it enters the large intestine. Majority of large intestine is called colon as well. From large intestine, the waste material, it is expelled out through the anus. That is the basic nutritional setup in humans. Now, when we look at this nutrition setup, the process of nutrition, the first step is ingestion. That means taking in of food. I take, say, I have a plate full of food. What do? I take a chapati, I take some vegetables, and then I crunch it. I take it in my mouth and I chew it, right? So, process of taking in the food, it's called ingestion. Then the process of digestion, it starts immediately in our mouth itself, because mouth has saliva. Salivary glands are present. Saliva is released. Saliva helps in breaking of carbohydrates. Saliva has salivary amylase in it, which helps in breaking down carbohydrates. Then there is the next process is absorption. That means slowly and steadily I have to absorb the basic nutrients. When I have food, say for example, if I had idli in morning, now idli along with some chutney, if I have that, it will have proteins, it will have carbohydrates, it will have certain lipids as well. That means the carbohydrates, the proteins, and the lipids, it has to be broken down. For that, it has to be absorbed. Where will it be absorbed? It will go into blood, and from there, from that blood, it will reach to each and every cell, where the nutrients are assimilated in our body, which is the fourth step. And then finally, the byproduct of our digestive system, that is whatever is not whatever is not digested, whatever is not absorbed, assimilated, whatever waste material is left out, it is ingested. That is, egestion is the process of removal out of the waste. So this is the process. A simple MCQ can be created where I can ask you the chronological order of our digestive system. Remember, ingestion, digestion, absorption, assimilation, and egestion. This is the process. Now, where does this start? As I told you, it starts first from the mouth and the buccal cavity. Mouth and the buccal cavity. Now, as soon as I eat food, what do? I chew it. Now, for chewing, I have teeth. Now, buccal cavity, I have teeth, right? Using that teeth, I am going to tear the food, I am going to masticate it, I am going to chew it, and it is going to be mixed properly using my tongue. And in the mouth, there is already saliva in it. From mouth, the food enters esophagus. Esophagus is this particular pipe from which the food, which now we call that food, which is just taken inside. It's called bolus. The bolus will pass through esophagus. It will reach into stomach. From stomach, it will move to small intestine. From small intestine, it will move to large intestine. Now, what happens? As I told you, as soon as I consume food, I chew it. Food is properly mixed inside my mouth. Digestion starts here itself because it has salivary amylase in it. As soon as I take it inside, right? As soon as I take the food inside the bolus, it enters stomach. In esophagus, there is not much of a digestion or any sort of absorption because esophagus is more of a pipeline which enters stomach. The next step is stomach. Stomach is a J-shaped entity. It is approximately about every individual's fist, a little larger than the fist. Its capacity is somewhere around 750 ml. All right. So when the food enters here, stomach has highly acidic pH. The pH is close to 2. When I say pH of 2, it is highly acidic. Why? Because the stomach lining or the mucous lining, it will secrete the hydrochloric acid. That means the food that is inside my stomach, it has to be broken down, especially the proteins. And to break proteins, I need this acid. That's why sometimes we feel that I feel acidity. Why? Because in the stomach, the quantity of acid has become very high, and slowly and steadily that acid is simply reaching this lower esophagus. That's why you feel heartburn or you feel acidity. So what do? You take antacids. Why stomach pH is acidic? Because I want to break proteins. Acid helps in breaking down of those nutrients. Now you must be thinking, sir, food has to be broken down, and for that I have carbohydrates, I have proteins, I have lipids, and on that some kind of proteins or some kind of enzymes have to act. But stomach has highly acidic pH. Will there be any enzymes there? Yes. Stomach will have specifically one particular enzyme which is activated in the acidic medium, that is called pepsin. And this pepsin, it specifically works on proteins. It helps in breaking down of proteins. Stomach also receives some of the other digestive juices. Mainly, it helps in breaking down of proteins, and stomach is also aided by some amount of juices from liver and pancreas as well. We'll talk about liver and pancreas in some time. So food enters my mouth. From there, it goes to esophagus, then to stomach. After that, the food enters small intestine. Now, when it enters small intestine is about 5 to 7 meters long, where it has 3 different sections. First section is called duodenum, second is jejunum, third one is ileum. Now, when we talk about our mouth, please remember, let me just give you some idea about the pH that we have. Please remember, pH in our mouth is basic. It is basic. You must have seen it. Why do we have bad breath once we get up in the morning? Because during the night time, the microbial activity increases. That means the pH in your mouth has slowly increased a little. That's why bacterial activity has increased and your mouth stinks in the morning. Mouth pH has to be basic. That's why you brush in the morning. When you enter stomach, its pH is highly acidic. Now, from acidic, again, it has to turn to basic in the small intestine. In small intestine, it should be again basic. Especially when we reach jejunum and ileum, it has to be basic. And then when we enter large intestine, especially in the lower colon, it has to be acidic again, because it will contain high amount of urea, ammonia, uric acid. So it will be acidic in nature. All right. So from basic to acidic to again basic to acidic again. Small intestine. Small intestine, it receives juices or secretions from pancreas, and this pancreas is going to release pancreatic juice, which will contain pancreatic amylase, pancreatic lipase, as well as trypsin, pancreatic trypsin. They help in breaking down of carbohydrates, fats, and proteins. And here the major absorption occurs, meaning the food, the digested food, from it the nutrients are absorbed. Now the nutrients have to be absorbed directly into the bloodstream. That's why small intestine has pillar like projection. They are called as villi. Now these villi have extensive capillary connections, and through these capillaries, you do know that nutrients can pass through capillaries. Capillaries are single celled blood vessels, which can help in to and fro transport through osmosis, to and fro transport of nutrients and other stuff as well. So here nutrients, they enter into these capillaries, and these capillaries, they will take these nutrients to individual cell for metabolic activity. So absorption and assimilation majorly occurs in small intestine. And please remember, when we talk about small intestine of other animals, especially say when I talk about small intestine of herbivorous animals and carnivorous animals, remember the carnivorous animals small intestine is actually longer. It is longer. This is a misconception among many students. They believe that since the carnivorous animals, they eat meat, and for it to be digested, small intestine has to be long. No. Herbivorous animals, they consume plants. That means they consume majority cellulose. And for breaking cellulose, the small intestine of herbivorous animals is longer than many carnivorous animals. Please remember this fact from MCQ perspective. That means most of my food is now digested, majority of it is absorbed as well, and whatever food that is left out undigested or some amount of absorption is left out, it now enters the large intestine. Large intestine is first of all wider. That means its girth is higher than small intestine, but its length is shorter. Small intestine is approximately 5 to 7 meters, whereas large intestine is hardly 1.5 meters. And most of the large intestine, it is basically even called as colon also. I can use the terms interchangeably because majority of large intestine is colon. It is divided into different sections of colon. This colon will be connected to rectum. Now the responsibility of large intestine is mainly to absorb water, mainly to absorb residual nutrients, and whatever is undigested food, it will be stored in rectum. And when the rectum is full, it will send signals to our brain. Then the bowel movement will start, and through the anus, waste material is released. It is excreted. This is the entire life process of nutrition in human beings. Is it clear? Right. From MCQ perspective, do remember the role of small intestine. Do remember some of the enzymes. As I mentioned, amylase, it works on carbohydrates. Lipase, it works on fats. And trypsin, it works on protein. Trypsin and pepsin, specifically on proteins. Apart from that, this digestive system is held by three important glands, that is liver, gallbladder, and pancreas. Liver, it releases bile juice. It is a yellow color fluid. Which helps in digestion. It also helps in eliminating specially fats, because bile helps in emulsifying the fats. Please remember this fact. Now whenever we talk about bad fat or bad cholesterol, the activity of liver is extremely important. Liver releases bile. Bile is stored in gallbladder. Whenever it is necessary in our small intestine, the gallbladder releases bile juice into small intestine, and bile juice, it helps in emulsification of fat as well as removal of bad cholesterol from our body. But it has its own limitations. If we consume more and more amount of bad cholesterol, that means the low density lipoprotein, that means saturated fats or trans fats, then it will be continuously accumulated in our body, in our muscles, and in our arteries, that means blood vessels, which ultimately leads to many problems. Apart from liver and gallbladder, there is one more gland, that is pancreas. I told you pancreas releases pancreatic juice directly into small intestine. It helps first of all increase the pH. That means it helps in bringing basicity in our alimentary canal. It also has different enzymes, as I told you, amylase, lipase and trypsin, to break down carbohydrates, lipids and proteins respectively. All right, that's the nutrition setup in our body. Now, after nutrition, we have to talk about another life process, that is respiration. Please remember, respiration is a catabolic process. Respiration is a catabolic chemical process which will help in releasing of energy into cells, meaning glucose would be broken down, or glucose, it has to be utilized by our body. For that, respiration is important, and for that, oxygen is very necessary. Remember, it is a catabolic process. Now, when we talk about respiration is a process of breaking down of the nutrients, breaking down of glucose into simpler compounds. And for that, oxygen is very much necessary in our body. But in some organisms, in some living organisms, especially cells, oxygen may not be necessary. That is why respiration can be of two types. That is aerobic respiration and anaerobic respiration. Aerobic respiration, it needs oxygen. It needs oxygen to break down glucose. Glucose is broken down into simple constituents. Glucose is broken down into simple constituents like carbon dioxide and water, giving you energy when oxygen is present. But when oxygen is absent, it is called as anaerobic respiration. And if oxygen is absent, then two kinds of respiratory systems can be seen. In fact, in our body, we find two kinds of respiratory setups. One is the aerobic respiration. We also find some amount of anaerobic respiration, not in all of our cells, but especially in our muscular cells. But it is not completely anaerobic respiration. I could call it as a semi-aerobic respiration. So respiration can be of three types. First thing, you have to break down the glucose in your cytoplasm. Glucose is broken down into pyruvate. It is a 3-carbon molecule. Energy is released, and this has to be further broken down. And if oxygen is absent, in such a case, this glucose and later on pyruvate, it is converted into alcohol, that is ethanol plus carbon dioxide plus energy is released. Now, this kind of anaerobic respiration is seen in many microorganisms like fungi, typically the yeast. Apart from that, in our muscles, if I do not have enough oxygen, say I am working out, and my muscles need more oxygen, but my other life processes, they need oxygen as well. What muscles do is they will let go of this aerobic respiration, and for some time they will undergo some amount of semi-aerobic or semi-anaerobic respiration. Deficient oxygen. Now, when I say oxygen is deficient, I wouldn't say completely absent. Oxygen is deficient. Now, in such a case, what happens is this glucose in cytoplasm, it breaks down to pyruvate, where oxygen is not present. It becomes lactic acid, plus it will give you energy. This lactic acid is continuously stored in your muscles. It has to be broken down later on when oxygen is replenished back. That is why we get cramps. You must have seen, or that is why when I get up in the morning, I feel that my muscles are very tense, very stiff. Or when you work out, when you continuously run, you get cramps. What are these cramps? These cramps are due to process of anaerobic respiration by your muscles, where lactic acid has deposited, or lactic acid amount has increased. Now, what do you do in such scenario? What do? You ensure that more oxygen is available for those muscles. What do? You do some massage, or you apply some heat, you apply some sort of ointment. What happens? That muscle normalizes. You keep it moving, then oxygen will be supplied there. Once oxygen is supplied, that lactic acid would be broken down, and then normal muscular process would start. Apart from that, the normal kind of respiration is this. In presence of oxygen, carbon dioxide, water and energy is released. This happens in almost majority of cells that we know. All right. But when we talk about respiration, now respiration in plants is reversed. In animals, they take in oxygen, they leave out carbon dioxide. Now, whatever I told you, the respiratory system, this was for animals. Now, for plants, it's much simpler. For plants, what do? They build up glucose. They build up glucose through Calvin cycle. That means they are going to take in carbon dioxide, they are going to leave out oxygen, and they are going to produce some amount of energy, that is glucose. But in us, it's the reverse. In us, it's the catabolic process. Respiratory system or our respiratory process, it's a little complex. It starts with our nasal passage. That means I have nostrils. From my nose, I'm breathing in. That means air enters this nose, then it enters the trachea, which is also called windpipe. From this windpipe, it will be bifurcated through two bronchi into two lungs, and these lungs have bronchioles, and these bronchioles ultimately have something called as alveoli. These alveoli are millions in numbers, and alveoli have capillary structure around them. Why? To exchange the gases. Alveoli are balloon-like structures on which capillaries are wound, and these capillaries help in gas exchange. As I told you that the breaking away, respiration is basically the process of breaking down. It is a catabolic process, and in our system, what do? We inhale air, we take in air, we give out air. But in that air, the amount of oxygen that we take in, see, we take in 21% of oxygen, we give out only 15 to 16% of oxygen. That means we use 5 to 6% of oxygen from air, and we take in 0.04% of carbon dioxide. But when we leave out, that is about 4% of carbon dioxide. That means we breathe in air, we breathe out air, but oxygen is utilized by body, carbon dioxide is expelled from the body. Why? Because the gas exchange has to take place in my metabolic activity. As I told you, in my metabolic activity, whenever the cellular respiration takes place at mitochondria, the energy is being utilized. That means the pyruvate, first glucose, later on pyruvate, it is being converted into your energy, water plus carbon dioxide. That carbon dioxide has to be expelled out. Where is it expelled out, or where is it exchanged out? It is exchanged out through the alveoli. Alveoli are the air sacs where the gas exchange takes place. How does this gas exchange take place? This gas exchange again occurs through blood. Please remember, in our body, blood is the important carrier for your nutrients. It is the important carrier of your gases. It is the important carrier for all other chemicals like hormones or any other thing. So what happens in blood? We have a protein called as globin. We call it colloquially as hemoglobin. Now what happens? This hemoglobin, it can reversibly react with oxygen, and it can reversibly react with carbon dioxide as well. Through this reaction of oxygen, it forms oxyhemoglobin. When it reacts with carbon dioxide, it forms carbaminohemoglobin. And at the alveolar sacs, it exchanges. The reversible reaction takes place, and oxygen is taken in, carbon dioxide is expelled out. That is the basic idea of respiration. And when we talk about respiratory system or respiratory mechanism in our body, we have three kinds of respiratory mechanism or processes that run. First one is the external respiration. This is nothing but inhalation and exhalation. This is the mechanical process, the external respiration. I inhale air, I exhale air. But there is an internal respiration which is running at the alveolar site. Now here the real respiration occurs where the gas exchange is taking place. That means oxygen is taken in and carbon dioxide is left out. Please remember, at any point of time, lungs cannot be completely emptied. Even if I exhale, some amount of air is already left out. That is why we say that even if I stop external respiration for some time, say I stop external respiration for say 1 minute, right now I'm not breathing, but internal respiration is going on, right? For some time, the air would be there. Apart from that, at the cellular level, at the mitochondrial level, cellular respiration is running. Now, what is the cellular respiration? This is what I told you at the beginning. That is glucose plus your oxygen that has now been absorbed. It will be transformed into energy, plus carbon dioxide is released and water is formed. That's the basic cellular respiration that runs. Clear? So we understood our nutrition system, we understood our respiratory system. Humans have a little complicated system, but many animals, they use oxygen. Say for example, aquatic animals, they use oxygen from water. Some other organisms, they have other systems. For instance, respiration is amoeba is because of diffusion. It does not have any nostrils. Through its cell wall, there is diffusion of oxygen inside and there is diffusion of carbon dioxide outside. Similarly, in aquatic animals, what do they have? They have certain mechanism through which they take water inside and they use oxygen from the water itself through the gills, right? These animals have gills. Some organisms like earthworm, we have studied this before. How does earthworm respirate? Through its skin. Through its skin, it takes in oxygen again through diffusion itself. It takes it through its skin, oxygen and carbon dioxide through the skin itself. Some other organisms like frog, they again have nostrils, they have mouth cavity, and they also have lungs and other respiratory organs, very similar to how human beings have. All right. Right. Let's understand another life process, that is transportation. Now, transportation is extremely important in any living organism. When we talk about humans, I told that in humans, the system of transportation is extremely important. We have blood for transporting nutrients. We have blood for transporting gas. We have blood for transporting hormones. We'll talk about human beings first, then we'll talk about animals. So transportation is very much important for every organism. In humans, it is quite advanced. In humans, there is a connective tissue called blood, which helps in transportation of different nutrients and transportation of other things. Now, when we talk about transportation in human beings, we have a complex circulatory system. This circulatory system was discovered by William Harvey. And in us, in humans, we have a closed circulatory system, meaning the connective tissue or the fluid tissue that runs, it is never expelled out. That means it always runs through different vessels, through different pipelines. But there are some organisms where they might have open circulatory system, especially insects. In open circulatory system, there is heart, which basically pumps blood, and the blood is pumped up in open system in something called as hemocole, or it is also called simple cole. Hemo is blood itself. It is pumped into cole, where the necessary exchange takes place, exchange of nutrients, whatever exchange, and then it will be pumped out through the body continuously. Clear? We have a closed system. Now, when we look at this closed system is found in amphibians, reptiles, birds, and mammals. The blood is always flowing through different vessels. We'll talk about these vessels, and this blood is pumped through entire body by an organ called as heart. Now, this is the cross section of heart. Human heart has 4 chambers in it. It has 4 chambers in it. The upper chambers are called atria. Upper chambers are called atria. The lower chambers are called ventricles. Please remember, vent means sending out, meaning both the ventricles, they will be responsible for sending oxygenated blood somewhere, deoxygenated blood to the lungs. So blood, first of all, it enters the heart from entire body, and it also enters from the lungs. Please remember, the blood that is coming from the lungs, it is oxygenated, it is pure, and now that blood has to be pumped through entire body. Whereas there is a setup of our blood vessels which is going to bring deoxygenated blood from the entire body into heart, which has to be pumped to lungs for purification. So how it happens? Because of heart, because of these valves. This heart has 4 chambers, and the blood, when I say atrium, the blood enters atrium from the deoxygenated blood. It enters right atrium through the superior vena cava. That means from the entire body, the bad blood or deoxygenated blood, it enters right atrium, then it goes to right ventricle, then it is pumped to your lungs. Whereas from lungs, I receive good blood from the pulmonary vein. It enters the left atrium, then it enters the left ventricle. From left ventricle, it is pumped through the aorta to the entire body. This is how the circulation runs. From lungs, good blood is coming into the left atrium, then it goes to left ventricle. From left ventricle it goes to the entire body. This is good blood. And from the entire body, the bad blood is coming through the superior vena cava. It enters your right atrium, it goes to your right ventricle, and it is sent to the lungs for purification. So blood, which is composed of cardiac muscles, it is like a pump which never stops. Our heart beats 72 times, lub dub, lub dub, and it pumps blood throughout our body. The volume, the stroke volume of our heart, it varies. Say whenever I'm running, whenever I'm exercising, if I need more amount of oxygen, if I need more amount of energy, then the blood can increase its stroke volume, or it can also decrease its stroke volume according to the requirements of our body. So we have a system where there is double circulation, meaning there is a division of blood into deoxygenated and oxygenated. Now what happens? From the entire body, you will see that the oxygen poor blood, it is collected, it is sent to the heart. From the lungs, the pure blood is again collected and it is sent to the heart on the other side. That means heart is divided such that on one side there is deoxygenated blood, bad blood. On one side there is oxygenated blood, which is good blood. And this good blood has to be pumped to the entire body. Bad blood is already used by our body and it has to be sent for purification to the lungs. That's how the double circulation runs in our body. All right, so clear? So circulatory process, that is a life process. Apart from that, we have blood pressure. As I told you, we have blood pressure. Our heart is made up of cardiac muscles. Now these cardiac muscles, they continuously pump blood. That's why heart beats in a rhythmic fashion, lub dub. 72 times it beats in a minute normally. And when it beats, or when the pressure is high, it is called the systolic pressure. The systolic pressure of our blood is 120 millimeter Hg normally, and the diastolic blood, that is when it says lub 120 millimeter Hg, dub, it is diastolic pressure, that is 80 millimeter Hg. This is the normal level. That is why we say the normal blood pressure, we say, is 120 by 80. So 120 is the systolic pressure, 80 is diastolic pressure. And as I told you, whenever a person is excited, say I have run for 1 kilometer continuously, if you check my blood pressure, it will be extremely high. Why? Because the heart has the capability to alter the stroke volume according to the needs of individual. So at that time, as soon as I run, then the blood pressure would be very high. In many cases, because of certain chronic diseases, you must have seen people having high blood pressure, especially in case of diabetes. So this is the normal blood pressure level. Systolic pressure 120 mm Hg, diastolic pressure 80 mm Hg. Clear? Right. Now this was about the circulatory system itself, and I told you we have a closed circulatory system, and in this circulatory system we have a connective tissue called as blood. It is a fluid connective tissue, blood. Now this blood is carried out always in certain pipelines. These pipelines are called blood vessels. In our body we find three types of blood vessels. We find arteries. Arteries always carry oxygen rich blood. We have veins. They always carry CO2 rich, or I can say, I'll write CO2 rich blood. Fine, it's not an issue. CO2 rich blood, that is deoxygenated blood. And there are capillaries. Which carry oxygen rich or carbon dioxide rich, depending on where they are transporting. All right. Now that means if a vein transforms into capillary, it will have deoxygenated blood. If an artery transformed into capillary, it will have oxygenated blood. Now when we look at arteries are always thick. Remember, out of these three blood vessels, artery is the thickest. Artery has multiple layers. It has a thick outer wall, it has a small lumen inside, and it is made up of thick elastic fibers of thick muscles, because it carries pressurized blood, because the heart is pushing blood. When I say lub, that is at 120 millimeter Hg, blood is being pumped into the aorta. Aorta is an artery itself. So in arteries, blood is at a higher pressure, whereas In veins, blood is of lower pressure. Why? Because the blood from entire body is now pushed towards the heart, so it is lower pressure, and that is why vein is thinner. Vein is thinner, it is not very thick, it is thinner. And that's why you must have seen that whenever a doctor gives you injection or draws blood from you, what do? They look for a vein, they never look for artery. Why? First of all, if an it doesn't mean that I cannot take blood from artery. Please remember that I can take blood from artery as well. But when I try to take blood from artery, first of all, the pressure is very high, and when I puncture an artery, it will take more time for repair. That's why we look for veins. So you find a vein, blood is in lower pressure, you put your syringe inside, you draw the blood, and you simply close it out with the cotton, and you will see that the healing will be very, very fast. Apart from that, we have capillaries. Now, what are these capillaries? Capillaries, as soon as arteries and veins, when they reach an organ or a tissue, what happens is they will divide into smaller vessels. And these smaller vessels, remember, they are only one cell thick. They're only one cell thick. That means I can easily put something into capillaries. I can easily take out something out of capillaries through osmosis. It's like a one thick permeable membrane. That's why the gas exchange takes place. That's why the nutrient exchange takes place. Clear? So artery and veins, they transform into different capillaries. Clear? Right. Now, apart from this, our blood, that is a fluid connective tissue, it has certain other things as well. It has some things called as platelets. Now, these platelets, they help in clotting of blood. You must have seen that if you get an injury, the blood comes out and the blood clots, the blood solidifies there itself. Now, if there are no platelets in your blood, then if a small puncture is made to any blood vessel, continuous blood will flow. Platelets, and these platelets, they basically contain vitamin K, that is phylloquinone, which is responsible for blood clotting as well. Apart from this, the blood also contains lymph. Please remember that lymph or a lymphatic fluid or lymphatic tissue. These are responsible for our immune system. So from lymph, there are many cells which enter our bloodstream, the WBCs basically, which form the immune system of our body. All right. So this is the basic transportation system that we have. Now, when we look at the plants, their transportation system is not as complex as humans. Why? Because plant simply needs water. That means they would need one conduit for water transport. They also have some food in them. They will produce food. They need another conduit for transferring the food. Now we know for water transport, water has to reach from the roots to the tip, and for that you have water transport setup. Water transport setup is called as xylem. Now water, it enters roots, it reaches to the tip, and you do know, because of sunlight, because of heat, there is always transpiration. Transpiration is the water lost by the plant because of sunlight, and because of this transpiration, the water can be sucked from the soil as well. So from soil, water reaches up because of two actions. One is the capillary action, the other one is the transpiration pull. As I told you, the transportation in plants is less complex. They have two different kind of conduits. We have already discussed these two different kind of tissues. These are called vascular tissues. They have xylem for water transport, xylem for water transport, water plus minerals, of course. Please remember, this is always one way. That means from roots towards the shoot. They also have a conduit or a vascular tissue which is called as phloem. Phloem, it is a two-way system. Phloem is a two-way system. That means the movement of material is upwards as well as downwards. And what do they transport? They transport water, they transport food, they transport nutrients, they transport minerals, that they can transport everything. Please remember this. Please remember, xylem is a one-way conduit, phloem is a two-way conduit. We have also discussed different kinds of cells that are present in xylem and phloem, like the tracheids, etc. All right, in our previous class. So this is the simple transportation system in plants. All right. Right. Next, move on to the next life process. Living organisms, living cells, You do know they undergo metabolic activity. What is the meaning of metabolism? That means they are going to use the nutrients, they are going to use the inputs. For us, we use nutrients, we use oxygen, we use water to run our metabolic activity. And after that metabolism is done, energy is released. I need heat and energy for survival, but some waste byproduct is also produced. And to remove that waste byproduct, I have live process called as excretory systems. In humans, the excretory system is something like this. Excretory organ, main excretory organ is kidney. From kidney, two ureters emerge. We have two kidneys. Kidneys are bean shaped. Two ureters emerge, and in these ureters, concentrated urine in which waste material is already there. It is collected in the urinary bladder, and when the urinary bladder is full, then we expel out this urine through the urethra. That's the basic excretory system. Now, for any metabolic system, I told you that our cells perform certain work. They release energy and they also release waste products. Now, these waste products, again, at the cellular level, mitochondria, at the mitochondrial level, I say, mitochondria is inside the cell. In the mitochondria, the Krebs cycle is running. When the Krebs cycle runs, I use glucose, I use oxygen to give you energy, I give you liquid water, and then carbon dioxide is released. Apart from that, there are some other waste byproducts that are released, and those byproducts, they again enter your bloodstream. Why? Because blood is the only connective fluid tissue which is responsible for transporting everything. It transports oxygen, carbon dioxide, it transports nutrients, it transports hormones, it also transports your waste materials. So waste material, they now enter your blood. Now from this blood, it has to be cleared. Now what is the waste material that is left out after all the nutrients are utilized and after it is assimilated? The cellular respiration, it will give out the ions or the compounds which are not useful for us. For example, sodium ions which are in excess, potassium ions which are in excess, ammonia, uric acid, urea. These are the waste products that are produced, and these waste products, they have to be expelled out of blood. They have to be expelled out of blood. Now, how do you expel it out of blood? It is expelled by the kidney. We have two kidneys. Kidneys are bean shaped, and when you look at the cross section of kidney, you will find kidneys having millions of nephrons. And each nephron is having a complex connection of different capillaries. There are millions of nephrons. Each nephron, it looks something like this. When I take a cross section and zoom in, then this is an individual nephron. Remember, there are millions of nephrons which are connected, and what happens? The blood capillaries, they form a network around these nephrons, and when blood moves through these capillaries, what happens? The nephron, it absorbs the waste material. It can release water, excess water. It can also release or absorb or release some other ions and other secretions. So what happens when the blood moves through this nephron, whose main part is this Bowman's capsule or glomerulus? The Bowman's capsule, the blood vessel through it is called as glomerulus. When the blood moves through it, the Bowman's capsule or the nephron, it is going to absorb the waste material from blood. Directly waste material is absorbed now into nephron. Now this nephron, it has certain other parts like the proximal convoluted tube here, the distal convoluted tube here, and this is the loop of Henle. Please remember that nephron, it has a descending loop of Henle and an ascending loop of Henle. So these convoluted tubes, proximal and distal convoluted tube, what do? They help in reabsorption and secretion into the filtrate. That means blood is now filtered, and this filtrate, it enters. This filtrate, it has to be continuously concentrated. Why? Because if I have to remove ammonia from my body, ammonia in a dissolved form in water, it is extracted or it is filtered in the glomerulus and it reaches inside this nephron. But you do know, if too much of water is wasted as urine, you will see a lot of dehydration in our body. That means some amount of water has to be reabsorbed back by the blood vessels. Some other waste products have to be given out. Some useful ions which have been absorbed along with the waste material, that have to be given back. So in the proximal convoluted tube and the distal convoluted tube, reabsorption and different secretions take place. And similarly, in the loop of Henle, in the descending loop of Henle, in the ascending loop of Henle, water, excess water which has been captured as the filtrate, it is given back to the blood vessels, and other secretions and other reabsorptions, they take place in the loop of Henle as well. And the final filtrate, it passes from here and enters the ureter. And once from the ureter, I told you, from the ureter, once it reaches the urinary bladder, once this urinary bladder, it gets full, it sends signal to a brain that it's time now to urinate, to pass the urine, and urine is passed out. Now this passing out of urine, it is called as the process of micturition. The release of urine is called as process of micturition, and the reflex, it is called as micturition reflex. Please remember this as well. This is the excretory system in humans. Please remember, human digestive system or human alimentary canal is not the excretory system primarily. Our primary excretory system is the kidney and its functions. All right. Now, apart from that, there are some other excretory organs also, but their primary role is not excretion. Please remember, lungs help in excretion or removal of carbon dioxide. Your skin helps in excretion of excess salts, right? Your liver, it helps in removal of cholesterol. So these can also be dubbed as excretory organ, but not exclusively. Apart from this, there is one more pointer that you need to remember. I told you we have a pair of kidneys. That means we have two kidneys. Imagine one of your kidney has stopped functioning, or imagine both your kidneys have stopped functioning. And kidney is an organ which you can donate also. That means I can transplant kidney from one person to another person, depending on the match, right? Depending on the blood match and other parameters which doctors would decide. That means if, say, imagine both my kidneys are not working, can I survive? I can survive, because these days medical advancement has happened and we have created different machines like hemodialysis, artificial kidney or hemodialysis. That means every 2 to 3 weeks, what do I do? If my kidneys are not working, every 2 to 3 days, what would happen is I would go to a setup where there is a dialysis kit, and using this dialysis kit, all the blood, it will circulate through the dialysis machine, and what kidney performs, it is performed by this dialysis machine, and blood is purified. Now, a person who is undergoing hemodialysis, they need to undergo this process according to doctor's advice, or in general every 2 to 3 weeks once. And the cost of dialysis, it depends. Now these days the cost of dialysis is slowly and steadily going down. If I'm not wrong, per session it costs somewhere around 2,000 rupees. So every 2 to 3 weeks a session of dialysis will help in cleaning your blood out. In fact, these machines are also being sold by big companies now. They are up to the tune of, say, 6 to 7 lakhs approximately. Not very sure with the price, but hemodialysis is a process of artificial purification of your blood. Whatever kidney does, since your kidneys are not doing it, this dialysis machine will perform that job. Right? Right. Now, apart from this, we know that plants, they do not have any specific excretory system or excretory organs, but we know it has stomata. Now stomata, it expels, according to plant, the waste product is oxygen, which is very useful for us. So it expels out oxygen. Similar to that, plants, they do also excrete. For example, oxygen itself is a waste product for a plant. It is excreted out. Similarly, excess water is excreted out. Dead cells or some kind of cellulose or some parts which are stored inside the cell, they are expelled out in different forms. For example, as I told you, gaseous waste is expelled through the stomata. For a plant, oxygen is a byproduct, it is a waste product, so it is expelled out. That is excretion for it itself. Similarly, water vapor, excess water, it leaves the plants through transpiration, or even in form of dew. Apart from that, you must have seen many a times solid waste which is stored inside the plant vacuoles, it is excreted sometimes through the leaf itself. Or dead cells or other waste material or the excreta which is stored inside the vacuole, it is expelled out as gums and resins. So in plants, we do have certain excretory mechanisms, but not as extensive or as complex as present in the human beings. And remember, it's a very strange thing. the things that is considered as waste for the plants, oxygen, it is very useful for us. Water, this is very useful for us. And these things, even the excreted product of the plants, they are very useful. Gums and resins are very useful economically and from the health perspective also for humans. All right. So these are some of the life processes from chapter 6, and in our subsequent discussion we'll talk about some other complex biology concepts like heredity, control and coordination, and then we'll also talk about how organisms reproduce in our subsequent discussion. That is it in this particular video. Thank you for watching this. As I told you in our previous interactions, we discussed about life process. For metabolism, we need different life process like the digestion. For instance, as I told you, right now I am using some gestures and I'm creating sound. For that, energy is needed. That means I need to have food. I had food, that food was digested, it was absorbed, assimilated, and using that energy I am able to perform certain activities which are based on motion, which are based on coordination. That is what is the agenda of our today's discussion. Now the first question is, sir, do all organisms move? Yes, to a large extent. If it is a living organism composed of a living cell, they have some sort of movement, some sort of coordinated movement, and some sort of control movements for sure. Now you must be thinking, sir, with me I understand, with humans I understand, because we move, we walk, we run. I am right now making gestures. With other organisms also, yeah, I can understand that amoeba, if it wants to move, it changes its shape. All right. But sir, what about plants? Do they move? See, plants are relatively stationary. Once they grow, they are relatively stationary. But plant during their growth phase, they have movement, isn't it? They have growth movement. We have discussed about different tissues, the apical tissues, the meristem tissues. They grow, right? For example, if I take a simple seed, I put it in the soil, I water it, it starts germinating. Now, once it starts germinating, what is it doing? It is moving, it is displacing the soil. It has displaced the topsoil. Then it germinates. Then it becomes a seedling, then a sapling, then a herb, shrub, and tree. Even during its growth phase or the maturation phase, it has some sort of a movement depending on the input. We'll talk about that in this interaction. That means, sir, why do these organisms have control and coordination in them? The answer to it is to look at, or control or coordination, to look after its interaction with the environment, with its surroundings. For instance, humans, now we have some sort of control system. Say if I go at a place where there is very low temperature, what do? I need something to cover myself. Why? Because it's extremely low temperature. For an animal, there is a need of control and coordination. For instance, for some it is to look after their surroundings, and for some it is for their living itself. For example, let's talk about the prey and the predator model. For a predator, it needs movement, control, and coordination to catch the prey. And for the prey, it has to survive. Take example of cat and mouse. A cat has to run to catch the mouse. A mouse has to run to live. So it's not just about its own surroundings, of course, interaction with their surroundings and environment, but many a times control and coordination, it becomes very important for living itself. All right. So control and coordination systems are present in organisms because of these reasons. In order to live, in order to protect themselves, in order to interact with their surroundings and environment. Now the next question. So what is going to be our focus in this discussion? Our focus is going to be the human nervous system. First we'll talk about humans, and then we'll talk about animals, then we'll talk about plants as well. When I say humans and animals, again, they have nervous system. With respect to plants, they do not have a well-developed nervous system, but they have some sort of control and coordination mechanism. We'll understand that. First, human nervous system. This is the controlling mechanism for our coordination. The human nervous system, it consists of a neural setup which helps in coordination. As I told you, right now I am making these gestures. For example, we have reflex action also in us. Means if I go closer to, say, a flame, I have some sort of an action that I don't want to go near that. It might harm me. Now, for all these actions, we have the nervous system, and nervous system, it comprises of two parts: the central nervous system, and the peripheral nervous system. So our entire control and coordination mechanism is handled by the nervous system. The central nervous system, it consists of the brain, and it consists of the spinal cord. So please remember, brain and the spinal cord, they comprise your central nervous system. This is like the controlling mechanism. All the messages, all the information, it is relayed through this central nervous system, and ultimately from here it is connected to the peripheral nervous system. And please remember, our entire nervous system, it is a combination of the basic cell, that is a neuron. What is brain? Brain is basically a ganglion, or an amalgamation of billions of neurons. In fact, it is said that in human brain there are billions of neurons, 100 billion, right? In fact, they say that it is ever increasing, the number is ever increasing, because more and more intelligence we gather, number of neurons and the neural connections, they all increase. When we talk about brain and then the spinal cord, it is nothing but an interconnection of these neurons. Similarly, with respect to peripheral nervous system, it is an amalgamation, or it comprises basically of different ganglions and different nerves. You must have heard about the nerves. Like, I have a sciatic nerve somewhere here, I have a ulnar nerve here. You must have seen during our school days, we used to have this prank, right? You simply hit a person here, then they feel some sort of a current. Why? Because there is a nerve there, the ulnar nerve. So nerves are a part of peripheral system. We'll understand what is the job of these in some time. But this entire human nervous system, the control and coordination mechanism, it comprises of the basic fundamental unit called a neuron. Now, very similar to how we discussed about the other life processes, in kidneys we have nephrons, in lungs we have alveoli, millions of alveoli. In kidney we have millions of nephrons. Similarly, in a nervous system, it is comprised of a fundamental unit called neuron. A neuron has an elongated structure like this. Of course, it will have a cell body, that means it will have center, that is a nucleus. Now, along with it, it has different parts. It has dendrites. Now you can see these dendrites are finger-like projections, and from here the information has to be relayed to the axon. This is the axon, and at the end there are axon terminals. Means the information is going to be relayed in this particular direction. Apart from that, there are other parts like the myelin sheath, the cell membrane, the axon hillock, etc. But from the broader perspective, from UPSC examination perspective, I would say that you need to understand that the dendrites receive the impulses, they transmit the impulses through the cell, through the axon, which reaches to axon terminal, and these axon terminal ultimately help us in control and coordination. All right, how does this work? I want to understand what exactly happens. As I told you, a simple neuron is this, and if you see the complex neural structure, at the end the axon terminals are connected with your, say, muscle fibers. Now what happens? Right now I have to move this pen from one place, from here to here. That means my muscles have to work. For the coordination or for this movement, my muscle has to act, my muscle has to work. But a message has to go to this muscle that you have to move this from here to here. That's your job right now. All right. So what happens? The nerves or the neuron, it receives this information at the dendritic tip. At the dendritic tip, my brain has just now sent a signal that you have to move this pen from here to here. And please remember that the signal passes, or signal transfer, it happens in this format. That means chemical to electrical and electrical to chemical transformation happens. That means as soon as the message comes, there is some sort of a chemical reaction near this dendrite. This chemical reaction, it changes that signal into an electrical impulse, and that electrical impulse, it passes through the axon body, reaches the nerve endings or the axon terminal, and this axon terminal, it is going to send a message: Rahul, please move your muscle so that the pen goes from here to here. All right. So nerves, they also have different sensory parts. Now when we talk about our nerves, we have some sort of a reflex motion. This is the motion which I told you, it is a controlled motion. That means through my consciousness, I told that to teach in a better way, to explain in a better way, I told you that I have to move this pen from here to here. It's a controlled motion. But many a times what we have is a reflex action. Now this reflex action, It is a combination of different kind of nerves. You must have seen that if I go near the flame, I try to move away. That's a reflex action. If there is a strong wind gushing right towards my face, I close my eyes. I want to safeguard my sensory organs. Those are eyes. If something pinches, example, if I touch a thorn, then I feel pain and I suddenly take my hand back. If I touch a hot utensil, I take my hand back. That's the reflex action. Now, how is this reflex action controlled? Now we need to understand how exactly this works. As I told you, our entire body is composed of the central nervous system and the peripheral nervous system. The peripheral nervous system, it is mainly connected with your nerves, which ultimately send the signal to your motor neurons. Now, when we talk about our nerves or neurons, there are three kinds. One is a sensory nerve. We sense it. We sense in our body. There are approximately 20 or more than 20 sensory receptors. For instance, I have gustatory receptors. Yes, in my tongue I have gustatory receptors. I can sense if something is spicy, if something is bitter, if something is salty, based on these gustatory receptors. I also have cutaneous receptors on my skin, meaning if something touches my skin, I sense, okay, something is touching. If something is pinching, I sense that because I have cutaneous senses. I have photosensors in my eyes. If there is too much of light, then I close my eyes. I have other for instance, I have ear based senses. I also have olfactory senses, meaning in my nose I can sense the smell. These are sensory nerves or sensory neurons which help by sending signals to your central nervous system, to your brain and spinal cord. Meaning, if I sense something, that information first of all goes to your brain, if it is a good thing or a bad thing. Apart from that, we also have motor nerves or motor neurons. Now, these motor neurons, they help you in your coordination. There is another kind of neuron or nerves in our body which is called as interneuron, or a mixed kind of neuron. It can be a mixture of motor and sensory both. Now, because of these neurons or because of these nerves, I'll be using these terms interchangeably. Because of these neurons, I have a reflex action. Now, what is this reflex action? I'll give you an example. Right? I am going to touch a flame, a hot flame. See, as soon as I go near to that flame, what happens? Here, my cutaneous sensor or my skin, it feels that warmth or it feels that heat, and it sends a signal to my central nervous system, which consists of the spinal cord and the brain. So sensory nerve sends the information to brain that there is some sort of a danger, and brain immediately sends a signal back to your motor neurons that do not go near there. Just take your hand back. That's your reflex action. Why it happens? It's because of this reflex arc. Let's try to understand this, right? As I told you, we have our brain and we have a spinal cord, which are a part of central nervous system, and this forms, or it's a part of the arc itself, the reflex arc. That means I get a message sent from brain through the spinal cord, and this motor neuron is activated. I just go here and it says, oh, this is very hot, I shouldn't touch this pan because its temperature is very high. That's how our coordination and control mechanism works. All right. So there is some sort of a chemical reaction or chemical change which leads to creation of electrical impulse. That electrical impulse eventually transforms again into a chemical signal so that your muscles work. So it's a transformation between chemical and electrical stuff. All right. Right. Now, when we look at the central nervous system, the main part in our central nervous system is our brain. Brain is here right inside the head. Now, brain, it is composed of billions of neurons. There is a neural connection of billions of neurons leading to formation of different parts of our brain. Broadly, we can classify the brain on the basis of matter that we have. We divide it into four brain. That is the frontal brain. It's here, forebrain. It basically comprises of 80 to 90% of your brain. Then we have a midbrain. It connects your forebrain with your hindbrain. Now, hindbrain, it controls body's functions. It is somewhere here. So we can say this is your forebrain, midbrain is somewhere in the middle, and your hindbrain is here. Now, in this, we have different parts. In this, we have different parts. Now, from exam perspective, we need to remember the functions of these basically. In the forebrain, the important part is cerebrum. Cerebrum is this huge part. Cerebrum is this huge part. All right. Now, if you see human brain is somewhere around 3 pounds approximately, right? Out of that, the maximum weight is of cerebrum itself. The cerebrum, it comprises of gray matter and white matter. And gray matter, again, gray matter comprises of nerves or neurons itself, neurons. And that gray matter, it helps us in our learning, in our reasoning, in our thinking. So 80% of our brain is the cerebrum, and it is the important part of our brain which is responsible for regulating our emotions, our reasoning, our learning, and other senses as well. In the forebrain, just below the forebrain, at the connection, I would say at near the midbrain, we have thalamus. Now, thalamus is called as switchboard of our brain. Thalamus. Now, thalamus here, thalamus is called the switchbrain of our brain, switchboard of the brain. Thalamus is responsible for all the sensory functions that we have, like the sight, sound, touch, etc. It helps us in sensing. Below the thalamus, there is hypothalamus. Now, hypothalamus, it is a very important gland in the head which helps to secrete hormones which control the body temperature, heart rate, hunger, mood, etc. Apart from that, in our hindbrain, we have two important parts. There are three. There is pons, there is cerebellum, and medulla oblongata. Cerebellum and medulla, these two are very important for movement. Since we are talking about control and coordination, I can say that cerebrum, thalamus, and hypothalamus, they are mainly responsible for control, and for coordination, cerebellum and medulla oblongata. Now, cerebellum, it controls the voluntary muscles. For example, right now I'm speaking, I'm making certain gestures, I'm moving my feet, my hand. That is because of cerebellum. Why? Because it is responsible for your coordination, posture, balance, and motor skills. But there are some other movements which I cannot control, and medulla oblongata, it controls those. For instance, my heart, it is beating, I cannot control it. The internal muscles, the soft muscles that we have, I cannot control it. I cannot control some involuntary muscles or some automatic processes, and those are controlled by medulla oblongata. Mainly the cardiovascular and the respiratory system that we have, it is controlled. The breathing, the blood pressure, etc. All this is maintained by the medulla oblongata. So now we have understood the control and coordination is because of brain, and brain is connected to the spinal cord. This is the central nervous system. So that means brain has to be protected at all the costs, right? So we have some sort of a mechanism of protection of our brain. As I told you, our brain is located here, right, at the head. So this has to be protected. For the physical protection, we have cranium. Cranium are these bones. Cranial bones, or the cranium, it is connected to your facial bones as well. They protect your brain inside. Now, inside the cranium, there are three layers. There are three layers of muscles or tissues, I can say, which protect the brain. They are called as meninges. Meninges are three layers of membrane that not only protect the brain, they also protect the spinal cord as well. The three layers are dura mater, arachnoid matter, and pia mater. Apart from that, the brain and the spinal cord, it also has cerebrospinal fluid. Now, this cerebrospinal fluid, it helps in normal functioning of the brain and the spinal cord. It is basically responsible for, I would say in simple terms, metabolism activities that are connected with your brain. Brain also needs blood. Brain also undergoes some sort of metabolic activities. So it helps, it protects your cerebrum, spinal cord, and it also supplements your sensory tissue system as well. All right. So this is about coordination in plants, coordination control in plants. Now, we know that animals and us human beings, we have extensive neural networks and the nervous systems, the central nervous system and peripheral nervous system. But plants do not have this. Plants do not have such extensive systems. But plants do have some sort of reactive or some sort of coordination measures for sure. As I gave you example, they have or they respond to some sort of stimulus. Classic example being the mimosa plant or the touch-me-not plant. The touch-me-not plant. If you see this touch-me-not plant, what happens? You just touch this, then it closes suddenly. How does this happen? How does this happen? I told you they do not have any nervous system, but they do have some sort of chemical signaling for sure. Even if it is not a chemical signaling, then in many other plants they have certain other mechanisms which are connected with water or changes in their cell structure. Many a times we see swelling or shrinking so that the plant changes its shape, right? We have seen so many examples responding to the stimulus. Touch-me-not is one of the examples, and the insectivorous plants, insectivorous plants, they also have some sort of a mechanism for reaction. As soon as the insect touches it, it reacts. Many a times the leaves or the cells, they shrink, they swell. So that is also one of the mechanism for their coordination, immediate response to some sort of stimulus. But apart from this, they also have movement which is connected to their growth. Now this is very interesting. Now you must have observed this in our day-to-day life. We have observed so many plants, they climb up, especially if their stem is very weak. If their stem is very weak, or if their fruits are very heavy. For example, pumpkin, right? Pumpkin. So a pumpkin or the bottle gourd, those plants, they cannot grow because their fruits are very heavy. So what do? They grow as creepers, or some others they grow as climbers. How? Because they have a growth mechanism. They want to find the inputs that they want. See, what is the input for a plant? They need water, or they're getting it from the roots. Okay. They also need sunlight. And many times what happens, say if there is an epiphyte which wants to grow, but there is another tree which is hiding sunlight or which is taking all the sunlight, then what does that plant do? That plant, it slowly and steadily, it reaches to the top to get or catch that sunlight. How does it do it? It does it by some sort of modification, bringing tendrils. Those tendrils help them in climbing. Or according to the growth factors, many plants show some sort of coordination or a shift in their growth pattern. That is called as tropism. Right? So tropism in the plants, it is the development that is prompted by a path based on their input, so that their growth continues. It is their improvement that they seek. As I told you, what are the inputs that they need? They need water, they need sunlight, they want to protect themselves. So it can be input factor or environmental factor as well. For example, if there is sunlight, now see, they show some sort of phototropism. Wherever there is sunlight, the plant, it tries to grow in that direction. Now you must have seen this classically with sunflower. You have seen this? You must have seen the sunflower. The flower itself, it turns its head according to the movement of the sun. That is called phototropism. Apart from phototropism, there is also geotropism. Now, geotropism is a classic idea where you need to understand that the shoot, it always tries to grow against the gravity, and the root, it always tries to grow towards the gravity. So if one of your plant structure, it just falls down, so what do you see? You see that the roots will still grow in this direction, but the shoot will start growing in this direction. It's a response to gravity. Apart from that, there is also thigmotropism. Thigmotropism is classically the touch, some sort of stimulus. Thigmotropism is the example of touch-me-not. I touch it, it closes leaves. Or we also have hydrotropism. Now, hydrotropism is a response to water. Wherever there is water, you will see that the roots, they tend to move in that direction towards the water. They try to seek water. Many a times they also have some sort of chemotropism. Chemotropism means wherever you find your requisite nutrients or chemicals, you move towards that. Apart from this, the control and coordination mechanism in plants is also controlled by phytohormones or plant hormones. In plant, there are different kind of hormones which help them in growth or which help them to stop the growth. For example, if there is extreme sunlight, if there is too much cold, then the plant, it wants to conserve its energy and not grow, and basically whether this storm or whether this cold temperature or hot temperature, then it again starts to grow when there are favorable conditions. These are governed, or these are controlled by the phytohormones. the important phytohormones or the plant hormones are growth promoters and growth inhibitors, that is auxins, cytokinins, gibberellins, ethylene, abscisic acids. Let's talk about these. Auxins, these are basically chemicals that are produced by a plant which help them in growth. Auxins, they help in cell extension and development of the plant. When auxin is released, auxins, please remember, auxin is not a single hormone. Auxins are a set of chemicals. One of the examples can be the indole acidic corrosive or indole butyric corrosive. There are different kind of auxins which help in cell elongation, cell growth. That means the height of the plant, it increases. There are also other phytohormones like gibberellins. Gibberellins are plant chemicals that advance in cell separation, that also help in breaking of the seeds. Seeds, they have to germinate. Seeds have to break the outer coating, and for that gibberellin helps. Example is some of the chemicals produced by Bacillus licheniformis. Okay. Apart from that, cytokinins or cytokinins, right? These are plant chemicals that advances cell division. It also helps in kicking off the stomata, predominantly found in the apical meristem. These are some of the growth promoters, but there are some other growth inhibitors. As I told you, the plant has to weather the tough season, and for that we need some phytohormones which help them in shedding of leaves, which help them in stopping of growth, and these are abscisic acid and ethylene. Now, abscisic acid, it helps in hindering development of the plant and helping the plant to shed their leaves and fruits, etc. are shed. The flowers are shed, the fruits are shed, the leaves are also shed during that tough season. The examples of this are jasmonate, cytokinin, right? Cytokinin is a chemical, all right? Now, apart from that, ethylene. Now, ethylene, I would say it's not exactly a growth inhibitor, but it acts as both. It enhances growth also, it inhibits growth also whenever necessary. Now, ethylene, it acts as both promoter and inhibitor. In trace amount, ethylene helps entire plant in regulating and stimulating the opening of flowers, fruit ripening, and shedding of leaves as well. And remember, that's why ethylene is used in artificial ripening, not from now itself. From ancient times, ethylene is used in ripening of fruits. You must have seen many times a fruit, it ripens very quickly if you put that in your mandir. You must have a small temple or a small worshipping place at your home, and if you put a banana there and you obviously light a lamp and then also light some sort of incense sticks, right? We call them agarbatti colloquially. So when you light it, you will see that the next day the banana has ripened. It has got certain dots on it. Why? Because from that agarbatti, ethylene gas is also released, which helps in ripening of fruits. A classic example from our common day-to-day life. All right. So plant hormones, they also help in control and coordination. Now, apart from that, we also have hormones in human body which help us not just in control and coordination, but in the development of entire body. In humans, we have two kinds of gland. We have two kinds of gland system. All right. When we talk about different gland system, we have endocrine system. We have the endocrine system. We also have the exocrine system or exocrine glands, right? The difference between these two is that exocrine gland, they do not release whatever is secreted by these exocrine glands. It is not released. It is not released in bloodstream. It is not released in bloodstream. But the endocrine glands, they release the hormones or they release the chemicals directly into your blood. That's why I told you blood is a connective tissue which carries a lot of things. It carries the impurities, it carries oxygen, carbon dioxide, different chemicals, nutrients. It also carries the hormones which are released by endocrine glands. And in humans, we have different endocrine glands like the pituitary gland, which is called the master gland. We have hypothalamus, we have thyroid gland, which releases the thyroxine hormone. We have parathyroid gland. In males, there are testes. These release sex hormones. In females, there are ovaries which release the sex hormones. Apart from this, there are also other glands like pancreas, which help in regulating the sugar level in the body or the glucose level in the blood. Apart from that, there are adrenal glands which help to trigger the fight or flight response, right? Adrenal glands, it helps in release of adrenaline, or we call it chemically as epinephrine. As epinephrine is released, then you feel that excitement, right? When you go on that roller coaster ride, adrenaline is released. So this is a list of some important hormones that are produced, and hormones are predominantly protein hormones. Hormones can be proteins, hormone can be some sort of steroidal chemicals like testosterone, right? Progesterone, cortisol. It can also be iodothyronines. You do know that this thyroid gland, it produces thyroxine, and for production of thyroxine, iodine is very important. And if iodine is missing, then thyroxine is not produced, and it leads to certain disabilities or disease. Goiter being predominantly one, where you get this swollen neck. That's why we have fortified salt which contains iodine. And as I told you, there are certain hormones for your reference. Again, pituitary gland, it releases some of the important hormones like vasopressin. It controls your water retention in kidney. It also releases growth hormone responsible for growth. It releases LH and FSH, luteinizing hormone and follicle stimulating hormone. This in turn helps the sex hormone release, or the sex organs release those sex hormones. Apart from that, pituitary releases two important hormones. I want you to remember this: oxytocin and prolactin. Oxytocin, again, colloquially it's also called the love hormone, right? Oxytocin, it stimulates the contraction of uterus and initial milk production in the mammary glands. Later on, milk is produced because of release of prolactin. Apart from this, hypothalamus, it produces certain important hormones like the growth hormone, the thyrotropin hormone, the gonadotropin releasing hormone. Kidneys and pancreas also release important hormones. Please remember, pancreas releases two important hormones. One is glucagon, another one is insulin. Insulin lowers the blood sugar level. Glucagon increases the blood sugar level. These are released by pancreas. Apart from that, the testicles, so the testes in males, they release testosterone. In females, ovaries, they release estrogen and progesterone. Please remember, in males, the testicles are also responsible for some amount of estrogen production. And similarly, in ovaries, in females, the ovaries, they also produce some amount of testosterone. In fact, in females, testosterone is produced in small quantities in ovaries as well as in the adrenal glands. Very important pointer. Please remember this. All right. Right. Now, apart from this, there are some other hormones like thyroid gland. It produces the thyroid hormone or thyroxine, adrenal, epinephrine, and there are some other hormones for your reference here. All right. Right. So this is basically the completion of the chapter control and coordination. But before going or before exiting, before going out, let's look at some of the questions that can be framed. For example, from UPSC perspective, questions like this can be formed. Consider the following statements. You have to find out incorrect statements. First statement is shoot of the plant shows positive geotropism, root of the plant shows negative geotropism. Did you get the answer? Right? Please try to attempt this. We have to find out incorrect statements, and I would say both are incorrect. Think about it and let me know. All right, I'll be giving these answers in my Telegram channel as well. All right. Apart from this, another question, you have to find out which statements are correct. Auxins are phytohormones that promote growth. Okay. Gibberellins are phytohormones that inhibit growth. I think this is a wrong statement. You can get it right easily. It's an easy question. Apart from that, pituitary gland is responsible for development of sex organs. Hypothalamus is responsible for stimulation of all body organs. Which of these are incorrect? You have to find out. Then you have to discuss, consider the following: neurons, meninges, cranium, and synapses. Now, there's a term synapses which is written here. See, when one neuron, these are dendrites, these are axon terminals. When one neuron is connected to another, it is through something called as synapses. Synapses are the nerve endings or the connection between two neurons. So you have to tell which of the above are responsible for protection of brain. So I think you can find out. This is also a relatively easy question. I'll be giving these answers on my Telegram channel as well. Before this, we spoke about life process. We said that there are certain life processes like breathing, like respiration, like eating food. Nutrition is very important for us. transportation system in our body. Blood carries all the nutrients, the waste material, the gases, oxygen and carbon dioxide through it, hormones. So we saw all those things. So there was a mention of reproduction also there. But what I feel, from a technical perspective, reproduction is not a mandatory or a compulsory life process. Especially again for humans, yes, is reproduction really mandatory? Some people like to live celibate life, right? So the question is, reproduction, is it really a life process? In fact, you speak about other processes. They generate energy for you, they help in coordination, in movement, but in reproduction there is a lot of energy which is lost. But despite that, why organisms reproduce? Have you ever thought of this? The answer to this is to leave that legacy, to continue your genetic lineage, to transfer your inheritance, to transfer your genes. Without reproduction, there would be no population on Earth for any organisms, right? For unicellular, or for humans, or for animals, for that matter, plants, anything. Without reproduction, there would be no population on Earth. We wouldn't call Earth as biosphere. So that's why, although strictly speaking it's not really important again for humans, but for animals it is needed for their survival, right? So reproduction also becomes a kind of a life process. So when we talk about reproduction, there are two kinds of reproductive processes that organisms follow. One is asexual reproduction. Please remember, when I say asexual reproduction, the plain and simple definition for this to remember is there are no gametes involved. This is just the simplest definition of asexual reproduction. There are no sex cells involved, there are no gametes involved. Without the involvement of gametes, without the involvement of sex cells, if there is a reproduction, it is called asexual reproduction. That means, what is sexual reproduction? Where there are gametes, where there are sex cells. That's the basic definition. Now, what are the types of asexual reproduction and where do we find them? Asexual reproduction is generally found in unicellular organisms. Generally, I told generally. Now, examples of that, the first one is binary fission. By the name itself, you do know binary. That means one cell divides into two. Fission means breaking. A cell breaks, or one cell leads to formation of two daughter cells. Binary fission is observed typically in unicellular organisms. In most of the prokaryotes, that means in most of the bacteria, we find binary fission. Examples, again, other examples are amoeba. In amoeba, we find binary fission. From one cell, it divides into two. In your leishmania, one cell divides into two, binary fission. Now, in this binary fission, you do understand that the daughter cells are exact replica of the parent. Exact replica. Phenotypically also, and remember, genetically also. Genetically also, whatever DNA was present here, exactly the same kind of DNA, exactly same kind of chromosomes are present here as well. So genetically, the exact replica is formed here. Now the question is, sir, when do these processes happen? For example, when asexual reproduction happens, that is a question that comes in aspirants' mind sometimes. See, that information is again in the specified DNA of this cell, and that information is dependent on the favorable conditions that cell achieves. For example, for a bacteria, when do they divide? When do they undergo binary fission? At the max, right? That means maximum reproduction happens when there are certain favorable conditions. For example, for a bacteria, it needs warm temperatures. That's why you see during the summer season, microbial activity is more, or during the warm season, microbial activity is more. For instance, in tropical areas, more diseases; in the colder areas, lesser diseases, because of the activity. Temperature is one controlling factor. Apart from that, moisture, water is needed. Yes, they need nutrition. That's why they need proteins, they need nutrition. That's why they are decomposers. Many bacteria and many fungi, they are decomposers. They need nutritive medium where they can undergo reproduction. And another important factor for a bacteria is also the pH, the acidity or basicity of that medium. And a bacteria, it needs basic to neutral kind of pH, where along with the temperature, moisture, nutrients, it leads to binary fission, more and more binary fission, right? So one of the methods is binary fission. Another method is fragmentation. By the name itself, it suggests fragmentation, meaning a single parent breaks into two fragments. Now here also you will see exact replica. The DNA would be exactly same. The genetic information would be exactly same. Then again, these two can create more fragments as well. It's not necessary just like this. It's not exactly binary fragmentation many times, but remember that fragmentation means a small piece of this particular organism, it cuts off, or it leaves its parent body, and it becomes the other organism. All right, fragmentation is predominantly seen in organisms, multicellular organisms, mainly multicellular organisms, example being Spirogyra. It can also be present in some unicellular organisms as well. Apart from fragmentation, there is one more method of asexual reproduction, that is regeneration. Now this is very interesting. Please remember, fragmentation and regeneration, they are not same. Fragmentation means any kind of fragment from the parent, it is capable of surviving on its own. But regeneration means if you simply cut this organism, this happens in organisms like planaria. Now if you make fragments out of this planaria, please remember, fragmentation means now this is capable of surviving on its own, but regeneration means this, it regenerates again into the entire organism. Now you will see same exact copy of the DNA. Regeneration, fragmentation, there is a small difference that in regeneration, the entire organism, it regenerates. We see some sort of regenerative mechanism in multicellular organisms also. Say for example, in our day-to-day life, we have seen lizards. You've seen lizards. Now if you cut off the tail of a lizard, it is capable of regenerating the tail. All right. Now apart from that, there is another method of budding. Now budding is seen in many fungi. Budding is seen in Hydra as well. Budding means this parent organism, let's take example of Hydra. This parent Hydra, once favorable conditions are reached, slowly and steadily a bud develops, and this bud eventually develops into the daughter organism, or new Hydra is formed. Once it matures, it detaches, and you will see another one. Please remember, it's not binary fission. One has created another bud. It can happen in such a way that multiple buds can also be formed. In many fungi, we see budding as a method where multiple fungi are formed, and when they detach, multiple fungus would be produced. That is budding. Now apart from budding, there is vegetative propagation. Now this is predominantly seen in plants. Vegetative propagation. An example of this can be grafting that we do in our basic gardening. A rose plant, you have a rose plant, you cut a branch or a stem of rose plant, and then you plant that again in another medium at new place, it will grow. We can see such things in bryophyllum as well. In bryophyllum, a simple leaf which falls on the ground, it is capable of producing multiple saplings like this, right? Through slowly and steadily, you can see another entity being grown here. And the same concept we do use in something called as tissue culture. Now, in our future subsequent classes, we'll talk about genetically modified crops. When we talk about genetically modified crops, we see that a new gene is inserted into a cell, a plant cell, and that plant cell is cultured. That plant cell becomes a tissue, the tissue is cultured, and then we can get a new sapling or a new plant itself. In tissue culture, new plants are grown by removing a tissue or even separating a cell and putting them in an artificial medium where we provide them necessary nutrients. And in that nutrient medium, it grows, it divides and it grows. This is called tissue culture. Now, apart from this, we also have one more method of asexual reproduction called as spore formation. Asexual reproduction through spores. Now, this is predominantly seen in fungi. This is seen in fungi, the fungi Rhizopus. This is also seen in different fungus. Now, what happens in a fungus when it grows, when it matures? It grows sporangium. And this sporangium, when it bursts, it leaves spores. And once this spore, it touches the moist surface, or I would say if it touches the soil, another fungus is grown. All right. Now, you should not get confused here with the idea of pollen grains. Now, you must be thinking, sir, this is very similar to pollen grains. This same thing happens in plants as well. The pollen grain, when it falls on the stigma, pollination occurs and a new plant comes. But here, please try to understand, this is not like the pollen grain. Remember, say imagine if a pollen grain, it falls on the ground, will it lead to a new plant? The answer would be no. Why? Because pollen grain will have half the chromosomes. But here, this spore is capable, once the spore, it falls on the moist surface or soil, it is capable of producing another fungus. But please remember, these spores are haploid or diploid. It depends on the plant. It depends on the fungus or organism. It's not exactly like pollen. In some funguses, there is some sort of sexual reproduction based on these spores itself. The male spore and the female spore, they combine to form a zygospore, and a zygosperm would be a diploid fungus. Some examples of spore-based sexual reproduction found in few funguses, few funguses or few fungi. Funguses would be wrong. Again, grammatically, it would be fungi, not fungus, fungi. All right, right. I hope it's clear. Spore formation between spore and pollen grain, the difference is quite clear. Right. Right. Let's move now to sexual reproduction. This should be sexual, right? Not asexual. This should be sexual reproduction. A small mistake, right? Sexual reproduction. As I told you, sexual reproduction, again, simply there is involvement of the gametes, meaning the male gamete, it joins the female gamete, and it leads to formation of something called as a zygote. And this zygote slowly and steadily grows. That's the idea of sexual reproduction. Now, first, let's talk about sexual reproduction in plants. What kind of sexual reproduction do we find in plants? What are the reproductive organs? See, you must have seen a flower. A flower is nothing but the reproductive part of the plant. And a flower contains both the reproductive parts, both the reproductive organs. That means the male part and the female part. This is a typical flower that we see. In this typical flower, there are petals, and you see that petals are quite colorful. Petals are quite colorful. You also have sepals at the bottom. Now, these sepals are protection. You must have seen that before the flower blossoms, there is a green covering over it. Why? Because the flower, it has to be protected, right? That's why the sepals are there. Once the flower blooms, the sepals go down and the petals come out. And among those petals, you will find the androcium and gynocium. Androcium is the male part or the male reproductive part in a flower, and gynocium is a female reproductive part in a flower. All right. Now, please remember one more term. There is a term called as estivation. Sometimes an MCQ can be created on this. Estivation. Estivation is the mode of arrangement of the petals. Many a times you must have seen there are some flowers which have only 4 petals. There are some flowers which have 6 petals, 8 petals. So the petal arrangement, it is called as estivation. Now, what happens? What happens? As I told you, the male and the female part are already present in the flower. What happens? The male part, it is called androcium. Androcium consists of stamen. Stamen. Now, you must have seen in a flower stamen like this. It has a filament and it has anther. When the flower blooms, when the plant matures, it starts flowering. And in this anther, there are pollen grains. This produces pollen grains. Now, we already know that plants, more or less, they remain stationary. The question now is, this pollen has to reach where? This pollen has to reach to the female part. The female part is called gynocium, and gynocium consists of 4 parts: stigma, style, ovary, and ovule. Stigma is the topmost part which receives the pollen. This receives the pollen. And style, it allows only a certain kind of pollen to fertilize the ovule. Ovary is a part which after maturation develops into a fruit, and inside that ovary are ovules. Inside that ovary are ovules. Now, ovules can be considered as eggs. These are female part, eggs. And once a pollen reaches here, the pollen fertilizes the ovule and it creates the seed inside. That's why when you see a fruit, that fruit is nothing but the ovary, and inside there are seeds. Those seeds are fertilized by pollen. So what happens? Now, pollen has to reach here. Now, please understand, pollen has to reach here. Now, plant cannot move. plant cannot move, but still the pollen will reach. How? It can reach by wind, it can reach by water. Many a times humans, when we move, we also facilitate pollination. The major pollinators are insects. Now what happens? There is a bee. Imagine there is a bee. Now there is this filament, there is anther, and this anther has small pollen. Now please remember, this pollen has half number of chromosomes here, right? It has half number of chromosomes. And when this pollen, it reaches stigma, how does it reach? Say this insect. Now if from a same flower the pollen reaches the same stigma, it is called as self pollination. It is called as self pollination. But if the pollen from one flower, it reaches the pollen of other flower by any kind of medium, say insects, it is called as cross pollination. Clear? Now once pollination occurs, what happens? The pollen, it reaches, and the pollen slowly and steadily, it reaches the ovules, and then it fertilizes. This ovule is also haploid, but once pollen fertilizes, it leads to formation of diploid seeds, which will help in movement of those genes forward. Clear? Now there can be one doubt in your head, right? One doubt. You must be thinking that, sir, what happens? Say imagine this is a rose flower, and imagine this is a marigold flower, and this bee, it brings pollens from a rose to marigold. Will pollination occur? No, pollination will not occur, right? That is why the job of this style is to ensure only correct pollen. That style, it basically is like a filtering mechanism. It does not allow other pollen to pollinate other flower. All right. So this is how reproduction takes place in plants. Right. Apart from that, human reproduction system, in males and females, different reproductive parts are there, different reproductive organs are there. Again, from here you do understand, gamete from male, it has to reach the gamete from the female, and both have to combine, leading to formation of zygote. Now male reproductive system, it consists of testes or testicles, which are responsible for production of sperms. Female reproductive system, it consists of ovaries, which is responsible for production of ovum or egg. And sperm from male, it has to meet ovum from female for fertilization to take place. So human reproductive process can be understood through these concepts. The idea of gametogenesis takes place first, then there is process of insemination, then fertilization, then blastocyst implantation and gestation. Let's try to understand these one by one. The first process is gametogenesis. Now what is the meaning of gametogenesis? At an appropriate age in males and in females, that means in boys and girls, the pituitary gland, it releases specific hormones which activates the sex organs in males and females. In boys, it will be testes. In females, those are ovaries. So the luteinizing hormone and the follicle stimulating hormone, when they are activated, then the puberty starts. And at puberty, you must have seen there are characteristics which appear in boys and girls. This we have discussed before also. The secondary characteristics in boys, mustache appears, beard appears, suddenly the muscle growth increases, voice becomes hoarse, and the testes, they start producing sperms. And this process is called gametogenesis or spermatogenesis in males. In males, spermatogenia or the spermatocyte, it undergoes the process of meiosis, and one spermatocyte, it leads to creation of four sperms, right? Now please remember, the initial spermatocyte, it will have 46 chromosomes, but after undergoing the meiosis process, each sperm will have 23 chromosomes. In our subsequent discussion, we'll understand the determination of sex as well. Why a female child is born, a male child is born, and what does it depend on? We'll talk about that in a subsequent discussion. But in males, spermatogenesis takes place, sperms are produced. And in females, at the age of puberty, the oogenesis starts, and a primary oocyte, after the meiotic division, it leads to creation of a single ovum or a single egg. And along with this ovum, there are three polar bodies which are produced, which are rather useless. That means every menstrual cycle an ovum is released. That's why it is said in the ovaries at the birth itself there are about 4,000 eggs. Slowly and steadily these eggs are released one by one after puberty. Clear? Right. So what has happened? Gametogenesis has happened. Now after gametogenesis, you need insemination. Now for insemination, there has to be some sort of sexual activity. That means during the sexual activity, the male sperms are transferred into female body, and in the female body, slowly and steadily, sperms compete, and one of the sperms, it reaches the egg. It leads to fertilization. So insemination can be natural through sexual activity, or these days artificial insemination is also followed. You must have heard about the in vitro fertilization, test tube babies, etc. So artificial insemination has also been developed these days, right? So sperm, it reaches the ovum. Now once one sperm reaches the ovum, then the ovum, it develops some sort of a protective layer outside it. The other sperms cannot fertilize it because it's already fertilized. And once it is fertilized, it leads to creation of zygote. And this zygote now starts to undergo cell division. So after a few days, the cells multiply and they are arranged as blastocysts, something like this. They are arranged along the circumference, the outer circumference, like this, blastocyst. And this blastocyst, it will implant itself in the uterus. This is called as implantation. And once blastocyst attaches to the uterus in the female body, it leads to pregnancy. And once pregnancy begins, then the gestation period, that means development of fetus, it takes 9 months in humans. It's called gestation period. In humans, it is about 9 months. In elephants, it is about 22 months. For other animals, it has lesser time period also. Now, during this gestation period, through the mother, the infant slowly and steadily develops. And after 9 months, when it is time, some sort of neuroendocrine mechanism runs and oxytocin is released, which leads to contraction in the female uterus, which leads to contraction in female body. Then you will see the delivery of the baby, and the process is called parturition. After the delivery, the mother and the child or the fetus, they are attached by umbilical cord, which is cut. Later on, the umbilical cord as well as the placenta, they are released or expelled out of female body. Once the baby is born, the baby is continuously fed for the first 6 months with the mother's milk only, because the mother milk, it contains colostrum, which has several antibodies which builds the immune system of the child. Apart from that, once parturition occurs, then the oxytocin, it also activates the mammary glands in the female, so that milk production starts, so that milk can be provided to the child. Now this is the process of reproduction in humans. Now you have a question, sir, what happens if no sperm reaches, or if there is no sexual activity, or if the sperm is not able to fertilize the egg? Then what happens? See, as I told you, the fertilization has to occur. For fertilization has to occur, there has to be sexual activity. If there is no sexual activity, the sperm has not reached the ovum. Even if there is sexual activity, if the sperm is not able to fertilize the egg, then what happens? See, what happens? Every menstrual cycle in a female body, they have a menstrual cycle. As I told you, the ovary at birth, it has about 4,000 eggs, and slowly and steadily after puberty, one egg is released every menstrual cycle. So once the egg is released, the uterus, it is waiting that the egg would be fertilized, and implantation will take place. So once the egg is released, the uterus in the female body, it develops endometrial layer. Why? Because it is preparing for a possible blastocyst, and to attach that possible blastocyst, there is a special layer which is developed inside the uterus. But if the fertilized egg does not reach here, then what happens? If the fertilized egg does not reach, this endometrial layer, is slowly and steadily left out. And that is why you see the menstrual cycle or menstruation in female body. That means if pregnancy occurs, then there would be no menstruation during gestation period, and after that for some period. That's the common understanding. Clear? That's the basic idea. I hope it's clear now, right? Now, apart from this, we also need to know that reproductive health is extremely important. That's why I started this discussion with the concept of sexual education as well. Sexual education is very important, especially among adolescents. There are so many questions, there are so many doubts, so many confusion regarding pregnancy, how pregnancy occurs, what exactly is the meaning of pregnancy, what is menstrual cycle, what is menstruation, right? Please have an open conversation about this. There has to be no taboo connected to this space, right? So you do understand that to avoid pregnancy, even if there is some sort of sexual activity, to avoid pregnancy, there are many measures. That's why these days there is a movement that children have to be by choice, not by chance, not just by sexual activity. Now, in humans and in some animals, sexual activity is also performed as a means of pleasure. For that, if it leads to pregnancy by chance, what to do, right? For that, contraceptive methods are available. There are short-term contraceptive methods available, right? For males, there are condoms which are available. For females, there are pills that are available. Contraceptive injections are available. Contraceptive rings are available. These are short-term contraceptive methods. There are also long-term contraceptive methods which are available for females, like the copper T coil, contraceptive implants, or the hormonal coils. Apart from that, the permanent contraceptive methods are also available. That is vasectomy for males. In vasectomy, the vas deferens is cut so that sperms are not released, and in females, the fallopian tubes are cut so that the egg is not released. These are permanent contraceptive methods. All right. So that's the basic idea of how organisms reproduce. Clear? Right. Heredity. Now, in our previous interactions, we have understood how organisms reproduce, and we understood two concepts, right? Now, we say the reproduction process can be asexual reproduction or sexual reproduction. Now, in both the cases, you need to understand that even if it is asexual reproduction, if it is a cell, the cell's genetic information is present in the nucleus, and you see when it divides, say it undergoes binary fission, then the same genetic information passes to the next progeny or the next generation. Now you will think that if this genetic information is this exactly same with this, you will think that if this is N, then these two would be exactly same. That is why asexual reproduction is also called as clonal reproduction, because it produces exactly same clones. But we will see that there would be some kind of genetic variation in the offsprings, even in the asexual reproduction. Why? We'll all understand that also. But when it comes to sexual reproduction, we have seen if I need an offspring, that offspring, if this is the individual, I am simply telling that it is a multicellular organism for sexual reproduction whose cell it has nucleus. But you do know that the genetic information in this nucleus, it comes from the father's side as well as the mother's side. That means it comes from two entities. For example, in a plant, we have seen sexual reproduction. Flower is the reproductive part. You have stamen, you have pistil. Stamen, that's the androecium, pistil as the gynecium. Pollen grains will contain half the set of genetic information, and the ovule will contain half the genetic information. When we talk about humans, the sperm, it is going to contain half the genetic information. Ovum, it is going to contain half the genetic information, and when these two combine, you will get complete set of genetic information. Correct? Now, what are we going to discuss? That how this genetic information, it keeps on passing from one generation to another generation. Can there be any specific changes? What are the rules and regulations of this inheritance? All right. Now, to understand that, we first need to understand what is the basic unit. For what is the basic unit of life? We have cell, and in that cell we have a nucleus, and in the nucleus we have chromosomes. So chromosomes are present in the nucleus. I told you, if this is a cell, if this is the nucleus is composed of chromosomes. Now, when we dissect this chromosome, or when we look closely, chromosome, it is composed of DNA in a dense form, and this DNA is our genetic information. Genetic information. Now, a specific locus of this DNA, it is called a gene. So, a human body, it is made up of different cells. Cell has nucleus. Now, inside this nucleus, you have genetic information, which is called as chromosome. Chromosome, it is dense form of DNA, and one particular locus of that particular DNA is called a gene. And this gene is responsible for one particular trait. Say, let me just give you an example. Say, this is Rahul sir. Now, Rahul sir has brown eyes. His ear is of this particular structure. He has black hair, not blonde, black hair, right? His height is this much. That means in his genetic information, some section or one particular gene, it translates to his eye color, that he needs to have brown color. Why? We'll talk about that also. His height would be this much. Why? We'll talk about that also. That means in our concept of heredity, we need to understand that your genetic information passes from one generation to next generation, but in the next generation, you will have certain changes to it. Now, it is observed in even asexual reproductive organisms, and in sexual reproductive organisms, you have to see that because it makes sense also. I told you why. All right. Now, the question is, sir, are there any rules of this inheritance? For asexual, it's quite simple because they follow clonal reproduction, and even in them also we'll find some sort of genetic variation. Why? Because they need to survive. That means the changes in genetic information is according to the environment. Now, in the organisms with sexual reproduction, they have inherent mixture of genes, and their genes would also be changing corresponding to environment. We'll talk about that in some time. But are there any rules and regulations which are followed, especially in sexual reproduction? When I talk about inheritance, this pertains to sexual reproduction. All right. Now, as I told you, our body is composed of cells. Cell has nucleus. Nucleus has chromosome. Chromosome is dense form of DNA, and a specific locus on that DNA is called a gene. And what is this gene? Gene translates to certain trait. Now, what will this gene do? Say, for instance, I told you Rahul sir's height is this much. That means there would be one gene in my DNA. There would be one gene in my DNA which is responsible for developing a protein. And this protein will basically lead to that growth hormone. And as that growth hormone is produced, then you will see the growth. And if that growth hormone is not secreted, or growth hormone is not working properly, then probably height would have been less. All right. And how that gene is expressed, how that gene is made, we'll understand that in some time. So gene is a portion of DNA which defines certain trait. Now, when we talk about Mendel's law of inheritance, Mendel explained that there are alleles which are specific portion of genes or specific form of genes which have expression in your phenotype, meaning, see, for example, you do understand we all are humans. Now, in humans, our 99.99% of DNA is same. That means in all our DNA we have similar kind of genes. That means we all have 5 fingers, right? We all have similar kind of a body structure. We all have basically 4 limbs, right? We have 2 hands, 2 legs. Basic kind of genes, 99.99% same. But there is a difference of 0.01% in us. Now, that inheritance, it comes from parents. You do know that. As I told you, I have black hair, not blonde. There would be a person in US or somewhere, they might have blonde hair. Why? Because certain specific genes which we call allele, that phenotypically can be seen. As I told you, the black hair. So alleles are some form of gene which are responsible for expression of that trait. And you do know that in case of sexual reproduction, as I told you, if you see this, in sexual reproduction, half set of genes or half set of chromosomes are coming from one side, other half is coming from other side. Now, you need to understand that every paired chromosome, that is why we have paired chromosome, every paired chromosome will have same kind of genes, but may have different alleles, and depending on the kind of allele, whether it is dominant or whether it is recessive, your phenotype or your that genetic expression can be seen. If it is a dominant allele, you will see that expressed in the individual. If it is recessive, then that gene or that allele would be suppressed. Now let me give you an example. Now see, let's try to understand this from my personal example. As I told you, I have brown eyes. Let's try to understand this concept of alleles. Now say this is Rahul sir. This is Rahul sir. I told you brown eyes. All right, brown eyes. Now for this, you need to get information from one side, that is the father's side. You also need to get information from the mother's side. Now whichever gene is responsible for the eye color, from the father's side, I would be getting half set from the father's side, half set from the mother's side. And whatever allele is present here, if one of them is dominant, say brown eyes is a dominant allele. If one allele connected to eye, it is dominant, brown eyes would be expressed for sure. But if one of the allele, you do know that father set of chromosome, they come from their grandparents, mother set, they come from their grandparents. That means there is an equal probability of father having both the dominant alleles, or even mother having both the dominant alleles, or one dominant, one recessive as well. It all depends on the probability of the genetic development from different generations. All right. So how would I get brown eyes? Brown eyes means I would be having the allele for brown eye to be dominant. Now if I have this allele, then brown eye would be expressed. Now if you're not able to understand this, let me just explain through another example. As I told you, alleles, for every gene you have two alleles. Now that allele can be a dominant allele. Now it is written here as B itself. Let me just give you from brown. It can be dominant. I am expressing dominant allele in capital, and I am expressing recessive allele through a small letter. Now if I get a B allele, a capital B allele, I will get brown eyes. Now as I told you, there is a possibility that half the information coming from father side, mother side, when you just combine, say if one of the parent, father, he has one dominant allele, one recessive allele, and if mother has one dominant allele, one recessive allele, there is a probability of getting brown eyes 75%. But there is also a probability of getting recessive allele, blue eyes. All right. This is just an example to explain how alleles work. Right. Now Mendel, what he did not experiment with humans. Please try to understand. Gregor Mendel, he experimented with plants, where he gave certain laws of inheritance, how alleles express themselves. Now what he did was he took two plants of a species. One of them was tall, one of them had height, right? It was tall. So this was expressed as TT. Now both the alleles that have come from the previous generation, both have been dominant traits or dominant alleles. He crossed that with another short plant, and this short plant, of course, if it is short, that means both the alleles, they have to be recessive. So what he did was he crossed them. Now when he crossed them, he observed that whatever the first generation came, it was completely tall. All of them were tall. But he understood that in all these plants, now there is one dominant allele and one recessive allele. But that recessive allele has remained dormant, and the dominant allele, it has expressed itself. So we have 4 plants of same height. That means higher height. He saw that in the first generation, that recessive trait, it was not expressed at all. It remained dormant. But in the next generation, when he used these 2 plants as crossing, so he used these 2 and he crossed them, he saw that there was a 25% probability, or one of the variants was short. That means the same allele as expressed. Here you will see three variants crossed, which are tall itself, but they do carry dominant allele. One of them, it does not carry the recessive allele. All right. So by using these methods of crossing, he tested with different varieties. He tested with different varieties. He tested with different varieties and different traits as well. On the basis of height, on the basis of fruit, on the basis of wrinkled fruit, short fruit, different seeds, etc. He came up with three different laws of inheritance. He said whenever there is sexual reproduction means gametes should be formed. He said whenever gametes are formed, he said after the offspring is born, or when the offspring comes, that offspring will always show the dominant trait in the phenotype. This is called as law of dominance. Law of dominance, meaning always the dominant allele, it is going to express itself, whereas the recessive allele, it will remain dormant. That's why you see when he crossed these two, he got all the plants as tall. But you will see in all the offsprings, there is one recessive trait which has not been expressed at all. So law of dominance, if there is a dominant trait, it will be expressed. The second law was the law of independent assortment, meaning during the gamete formation, you do know the genes are separated. Half genes or half set of genes come from father side, half set of genes come from the mother side. Again, when I say half set, meaning say for humans we have 46 chromosomes. Correct? So we get 23 chromosomes, 23 side from father, 23 side from mother, but those chromosomes will have complete set of genes. You do understand, right? When I say half side from mother side, half from father side, we get half set of chromosomes, yes, but those will have complete genes. And in that gene, which would be dominant, which would be recessive, it is completely independent of each other. Means there is a 50% chance, or equal opportunity for hereditary factors to come from either side. Apart from that, during the gamete formation, another law is law of segregation, which simply says that whenever there is gametogenesis, there is segregation of genes in such a way that they are equally distributed, or they equally come from both sides. They equally come from father and mother side. All right. So these are the three laws given by Gregor Mendel. Let me sum them up in very short. As I told you, first law, it pertains to law of dominance, meaning a dominant allele will always mask the recessive allele. It is always the dominant allele which is going to give that expression, or which is going to express itself. That's the law of dominance. Apart from that, the second law is law of independent assortment, means alleles or genes on chromosomes, they are distributed randomly in individual organism. That means there is equal opportunity, equal chance of any gene, any allele expressing itself from either side, from the mother side or from the father side, equal opportunity for expression. Apart from that, the third law is the law of segregation, which I would say a simple extension of law of independent assortment itself. That means in any diploid organism, see, we are a diploid organism, we have 2n set of chromosomes, right? One set of chromosomes coming from father side, another set of chromosomes coming from mother side. When gametogenesis occurs, these are divided equally. In humans, 23 set of chromosomes come from one parent, 23 from other parent, and this genetic information will be combined. Now when I say 23 chromosomes, I'm repeating this again. 23 chromosomes will have all the genes. That means one set of genes or one set of alleles come from the parent side, another set of alleles, they come from the mother side. Clear? Right. Now based on this knowledge, let's try to understand how sex is determined in humans. Now, there is a misconception in Indian society that a woman is responsible, or woman determines the sex of the baby. Not like that. Right? We need to educate, or we need to understand that further. As I told you, humans have 23 pairs of chromosomes. That means we totally have 46 chromosomes. Correct? Right. Now, when we look at human chromosomes, we have a maternal copy and a paternal copy. That means 22 chromosomes or 22 pairs are exactly same. 22 pairs are exactly same from maternal side and paternal side, right? Because as I told you, same species. I give you example also. Our 99.99% DNA is same. Yes. So we get 22 pairs which are exactly same from mother side also, from father side also. But there is one pair. There is one pair which is called as sex chromosome. So for a male, they have 22 pairs of chromosomes plus XY set of sex chromosome, and for a female, they have 22 pairs of chromosomes plus they have XX set of chromosomes. And you do know in the law of segregation or through the law of segregation, that means these would be divided equally. That means during gametogenesis, these set of chromosomes are going to be divided equally, meaning when a gamete is formed, now this gamete, it is going to have 22 chromosomes plus X, and this is going to have 22 chromosomes plus Y. Whereas on the female side, they can only have chromosomal set where it is 22 plus X always, 22 pairs plus X always. And whichever sperm, if it is the X sperm, if it fertilizes the ovum, you will get a female offspring. If it is a Y based sperm or Y sex chromosome based sperm, if it fertilizes the ovum, you get the male offspring. So means it ultimately depends on the male, which sperm fertilizes the ovum, because on the female side there is always X chromosome present. Even after segregation, you will see the same X chromosome itself. Clear? Now you must be a little confused on what is this terminology. For different organisms, for different species, there are different set of chromosomes which decide this, which decide the sex of the offspring. As I told you, for humans, 22 pairs, or I would say 44 plus XX, and here 44 plus XY. When you segregate it, 22 plus X, 22 plus XX, 22 plus XY from these side. Both will combine. X or Y will determine the sex. Same thing for other animals, like for the chicken, you have 76 plus ZW. Now determination from the female side, sex determination from the female side, but on the male side, you have same set of sex chromosomes. Here there is a difference. But for the other organisms, say for insects, 6 chromosomes from XX from the female side, 6 chromosomes XY from the male side. You can see this for your reference. The nomenclature is given in a different way. Clear? Right. So we understood Mendel's laws of inheritance. We understood sex determination. Now let's talk about the concept of heredity and evolution. Now we understood heredity means how your genetic information is passed on to the progeny or passed on to the offspring. And I told you, even for asexual reproduction, there can be change in genetic information based on their environment. Do you remember that pointer? Now let's try to understand more about that. See, many people, they get confused between these terms, heredity and evolution. These are some of the fundamental topics. Both concepts are interrelated, of course. Heredity comes first. Now, because of this heredity, because of genetic information being passed from one generation to another generation, we see the concept of evolution. So heredity is basically transmission of properties from parent to the organism or the offspring, whereas evolution is the outcome of changes that happen to specifically inherited genetic information. Now you have a question. Sir, how do this genetic information change? What is the reason for that change? It can be anything. And please remember, genetic information, it changes depending on the environmental factors. Meaning an individual has to adapt. Now based on that environmental factor, it can be any reason. It can be a mutation, meaning change in gene because of certain factor. It may be because of, say, radiation. It may be because of any other environmental factor. It may be because of hybridization. Now genetic changes can occur because of hybridization, meaning within a species itself. You saw how Gregor Mendel, through hybridization, he saw that if I crossbreed two species, or if I crossbreed two plants, he saw a tall plant and a short plant. He saw the offsprings, they were all tall. Again, hybridization can be one of the reasons, or recombination of DNA. Recombination of DNA these days We have also developed a lot of research and development in the biotechnology domain. So recombinant DNA technology has come up. Recombination can be one of the reasons. Apart from that, natural selection can be one of the reasons for genetic information change. Geographical isolation can be one. You can see this especially with the bacteria. Say for instance, bacteria. You think, sir, bacteria, there is no concept of sexual reproduction there. That means in the offspring, technically I should not see any sort of genetic change. Why? Because it is clonal reproduction. The same bacteria, it simply copies, it makes itself into two. It basically copies itself. Then what is the case of genetic change? Say, for example, if the location changes, if there is some sort of isolation, you find some bacteria which are adapted to chemicals, some bacteria which are adapted to heat, some bacteria which are adapted to something else. So that genetic information is changed because of isolation. It can also be because of genetic drift or gene flow for different species. We'll understand these terms in some time as well, right? So evolution can happen because of these reasons. Let's try to understand more about this concept of evolution. You have a question, sir, is evolution always beneficial? You told it may be because of environmental reasons. Yes, but is it always beneficial? You cannot say it, right? Evolution may be beneficial, and in most of the cases it is beneficial because an organism or a species is trying to adapt, but it can also lead to adverse results. Let's take example. Say we have some beetles. The beetles are some insects, and generally beetles are red in color. Now you see, if there are beetles on a plant and if all of them are red in color, what happens? The crows can come and they can eat them. The beetles are basically prey for this predator, that is crow. So if it is red in color, it can easily see it and it can capture it. So what happened? To survive, one of the beetles, it had genetic change and it became green. Now you see, if the beetle is green in color, the crow cannot see it, so it has higher chance of survival. So over a period of time, what happened? Whatever red beetles were there, they were continuously eaten. They were continuously eaten by the crows. That means their population goes down, and at one point of time, you will have all the beetles which are green. Means they have now found out a means of survival. They have found out a means of survival for themselves. So this is beneficial for them. I would say the first example is a positive example where their population has increased. But many a times it might be adverse also. It might be reverse also. And evolution can happen like this as well. Now this is an example where there are red beetles. Now red beetles, one of them has transformed itself into a blue beetle. This is not useful because the crow was able to see the red beetle, it captured it. The crow will also see the blue beetle. It will capture that also. That means it is not beneficial from the point of view of survival. If it was green, because it was able to camouflage itself, because plants are green, so crow cannot see it. But here there is no advantage from the crow side. But imagine they are surviving somehow. Both the species are surviving somehow, and some sort of catastrophe occurs. Say an elephant has put a foot on one particular tree or one particular plant, and that plant had all the red beetles. Now what happened was, because of this intervention of elephant, and it was very innocent intervention, all the red beetles are gone now. Only blue ones have survived, and blue ones will reproduce, and this blue species is produced. But please remember, it does not have any advantage. There is no advantage here. There is no advantage to safeguard themselves from crows, because the blue beetles can also be seen by the crow. But do understand, both of these are inherited traits, meaning there is something inherently changed in their genetic structure because of which they have changed their color. Why? Because they want to survive. Now here it thought becoming blue color might help it in survival, but from crows it has not helped. But somehow, because of some other factor, it might have survived. All right. There is another example of acquired trait. And this acquired trait is not a change in its genetic structure. For instance, see, there are red beetles. Now, imagine these red beetles, in one particular area, there are no crows. So these red beetles, what happens? They'll keep on eating the green plants, and their population has increased. But once those plants are consumed, they do not have any food now. And if they do not have any food now, then what happens? Their mass reduces. They become small in size. Now, this is not a genetic change. This is simply an acquired trait because of shortage of food. Say probably for one generation, you have low weight or low mass beetles. For another generation, yes. But by this time, what has happened? Those plants have also regenerated. And once they have regenerated, then you will see again the normal kind of beetles. Now, this is called an acquired trait. An acquired trait from environment. This is not genetic. And please remember, when the trait is acquired, it is not transferred to the future progeny. It is not transferred to the future progeny. It is simply depending on the environmental factors, that is shortage of plants. That's why I'm not able to get my food, and that is why you see that lower weight, or I would say in a colloquial language, these are malnourished beetles. These are healthy beetles, these are malnourished beetles. And these malnourished beetles will continue till they get food. Once they get food, they again become normal. They again increase their weight. This is an acquired trait. An acquired trait is not transferred genetically. It is only inherited trait. Inheritance. Red becomes green. Green has survival rate. That's the meaning of the inherited trait. All right. Now, because of this idea of heredity and evolution, people are trying to answer this question. How exactly different organisms, different species have come? And for that, the concept of speciation has started. Speciation. All right. Speciation. Why it comes? As I told you, different organisms have different set of chromosomes. Different changes have occurred over a period of time. I'm talking about billions of years now. So how it has changed? One is through mutation. Now, mutation is an inherent change in the genetic information because of any factor, and that can be transferred into next generation. It can occur because of genetic drift also. Now, genetic drift means the genes drifting, meaning change in the frequency of allele within the population. Remember, occurring very randomly. There is a chance drift possibility that the genetic frequency has changed or the allele frequency has changed. It can happen because of natural selection also. Natural selection means whoever is fit to survive, whoever is able to adapt, whoever is able to change, they survive. Now, please remember here, genetic drift in a specific way is called natural selection. Genetic drift is random, but once genetic drift or its reason has been identified, it becomes natural selection. There is another concept of gene flow as well. Gene flow means that there is a transfer of alleles from one population to another population. Gene flow, probably because of say migration or movement of organisms. Because of that, gene might flow. And due to these, what we have seen is origin of different species. Now, please remember, speciation and evolution both are connected concepts. If I have to explain you in a very simple term, let me just draw something and I'll try to explain. Now, this is called evolution. Now, within evolution, if you draw a subset, this becomes simply speciation. Meaning different species have come into being. So evolution is a continuous branch. It's a continuous branch where we say that all of us we have come from a common ancestor. Probably there was no life right at the beginning of the earth. There were unicellular organisms, but slowly and steadily complex organisms evolved, and from those complex organisms different set of species have evolved. We are Homo sapiens, and our ancestors, we say our ancestors are, or in our Homo family, Homo sapiens family, or Homo sapiens is basically the humans, or in the we find so many organisms like the orangutan, the Hulon gibbon, right? We have different apes. Now all these, they belong to same family. You do know that there is speciation which has occurred. Now evolution is a broader idea, but speciation, it is a formation of different species. It is a part of evolution, but it is at a small scale level. It is a smaller process of evolution within a branch, one can say. And speciation occurs in a comparatively smaller period of time. Now the question is, sir, why does speciation occur at all? Why do different species come up? It may be because of two different reasons. One is because of geographic isolation, other one is isolation in terms of reproduction. So geographic change or geographic isolation, it leads to allopatric speciation, it is caused by physical isolation. Reproductive isolation, it's called as sympatric speciation, and there is one in between, it is called as parapatric speciation, which is caused because of partial geographical separation, again between the populations of same species. Now this, because of intermixing, because of interbreeding, the recessive alleles, so the recessive alleles, they slowly and steadily disappear. All right, that's the basic idea. Speciation and evolution. Now the question is, sir, I want to understand it further because I'm still getting confused. I'm not able to understand what is speciation. Speciation can occur because of some particular event. For instance, as I told you, all have common ancestors, but because of one particular speciation event, it may be connected to reproduction, it may be connected to some environmental factor, it may be connected to geographical isolation. You see that one specific species has evolved and other species has continued, meaning now these two species, they cannot intermix, they cannot reproduce. Clear? Right, that's the basic idea. All right, speciation versus evolution. Now, how have we understood all this? Because this is the human evolution. A human evolution from a primate, from an ape, we have come to this particular level. Now we cannot go back now, right? There is no concept of intermixing or interbreeding now between these different species. Now, how have we understood all these things? So you have told me many things. I have understood majority of them, but how have we studied this? Now we have understood this from different evidences. For instance, fossil evidences. From fossil evidences, we have seen that billions of years ago, we have gained expertise into radiocarbon dating. Because of that, now we can decipher age. These days, we have also made advances into science and technology, and DNA analysis has started. Now, because of DNA analysis, we have been able to study evolution in a more cogent way. Apart from that, we also go for evolutionary relationship. For instance, you see that how we have evolved. Now we have 4 limbs, correct? We have 4 limbs, we have 2 legs, we have 2 hands. We see that there are many 4-limbed animals as well, different species. Yes, there is tiger, there is cat, there are feline species, are different species, but you see that there are 4 limbs, and somehow the human species or the human race, they have been able to advance their control and coordination. That means our genetic diversity, our genetic evolution has been in a better way, so that we are able to coordinate ourselves. We are able to walk only on 2 limbs, and the other 2 limbs are used for other purposes. We have developed the opposable thumb. But if you look at other organisms, if you look at other common organisms, we see that in evolutionary stages, we have hands. If you look at avian species, those avian species have 2 limbs, right? They have 2 feet. Some other adaptation has happened. Some have webbed feet, some have claws for their own protection. But if you look at the wings, what are those wings? Do you think those wings have, or their 2 limbs are basically their wings, 2 wings for flying? These are the kind of relationship that we have made and understood evolution slowly in studies. Apart from that, evolution has happened even in stages. As I gave you example of this here, human evolution through different stages, different animal evolution through different stages. And once you enter the next stage, that means the speciation has evolved slowly and steadily. Speciation has occurred. Different species have come. For example, the bonobo, the chimpanzee, gorilla, orangutan, gibbon, we say all are relatives. But you do see human race or human species is separate. Now, a gibbon can mate with another gibbon, but intermixing among these species is not possible because speciation has already occurred. And please remember, there's one more point, that evolution, it does not means progress. Evolution is not progress. Please try to understand this. If anybody says evolution is progress, no, it is not progress. Evolution is always related to environmental condition. Evolution is simply adaptation of an organism for a better life. It's not progress, but there is one progressive factor to it. I can say that if you look at any sort of organism, let's take example of this slide itself, you will see that there is complexity which is increasing. If I go in this particular direction, you will see that the complexity continuously increases, meaning there are complex organ systems now. As I gave you example, we have opposable thumbs. This is an extraordinary feature of humans. Because of this opposable thumb, we are able to perform so many activities. Our brain has billions of neurons and that is continuously increasing. That means our system is getting more and more complex by the day. If you look at different scientific research, different scientific papers, you will understand the number of neurons in human brain, it is continuously increasing. That means we are still getting complex, and that process of evolution, it is still going on. That does not mean progress per se. One needs to understand that. Clear? Right. I hope I have given you good insight into heredity and evolution. Again, from UPSC Civil Services perspective, I think this would be more than enough. We do not need to get into too much of details or too much of terminology or read about fossil fuels, read about different dinosaurs. Those are all the things which are not needed for us. But if there is anything, if there is any data regarding evolution, if there is any information regarding evolution from exam perspective in current affairs, say anything connected to radiocarbon dating or some old age fossil has been found which has helped us in solving the jigsaw puzzle of evolution, please make a note of that. An MCQ can be formed on that. All right. We have already discussed class 6, class 7, class 8, class 9. And there we have understood light is extremely important for us to see things. And where do we get this light from? The ultimate source of this light is our star, that is sun. So we have understood what are luminous objects. Luminous objects are the ones which have their own light, which give out their own energy. Sun is one of the luminous objects. We discussed that moon is not luminous. Moon simply reflects the light from sun. So we discussed about luminous objects, non-luminous objects. We also understood that light again can be described or can be represented as a ray, and we have understood that if any obstruction comes in between, that obstruction, if it is transparent, then the light would pass through it. But if it is opaque, then the light is obstructed by opaque objects. So we have understood about transparent objects, opaque objects, translucent objects in our previous interactions. We have also discussed about the formation of shadows. Whenever there is an opaque object in between the incident light, or when incident light is put on the opaque object, then a shadow is formed. We have discussed all these things. So we will be building our knowledge over this itself. So you have understood light is extremely important. In fact, in our 9th discussion, we understood that reflection of light is extremely important. Why I am able to see so many things. For instance, I am able to see there are some panels there is a camera there is a desktop, all the setup is there. Why am I able to see all these things? This is because of reflection of light itself. Light is being reflected. We discussed that why leaves are green, because the green light out of the white light, that is sunlight, green light is reflected the most. We see the color as green. So we have understood this phenomena as well. So today we'll talk about two important facets connected with light, connected with optics, that is reflection and refraction. Now, first thing, reflection and refraction, why do they occur? Now we have discussed that light can be represented as a ray. And in our previous interactions, we have understood some characteristics of light. The speed of light is 3 into 10 to the power of 8 meter per second. Light has dual nature. We have understood light is a wave. Or light behaves as a wave, and light also behaves as a particle. I simply like this picture a lot because it describes both the things. It spells particle as well as wave together. So light, it behaves both as wave and a particle. Now right now, whenever we talk about this ray diagram, we discuss light as a particle. All right, but in our subsequent discussions, when we talk about some important physics concepts going forward, we'll talk about the characteristics of light as a wave as well. There we'll talk about the concept of interference, concept of diffraction. Light is diffracted, light interferes because it also behaves as a wave. And when two waves meet, when two waves interfere, they can interfere in phase, the amplitude, the amplitude grows or it gets amplified, light can also interfere out of phase, and when it is out of phase, the amplitude reduces. We'll talk about these concepts going forward, right? That's it. That's what is mentioned here. Diffraction, interference, we'll talk about these in higher classes. That means the wave theory of light would be understood in a better way going forward. But right now we do know, or we do have to establish the idea that light is dual in nature, means it behaves as a particle, it behaves as a wave as well, right? So today's discussion is connected to reflection, and when we talk about reflection, we use the ray diagram to explain. When I use a line like this, that means the light is incident. All right, we give a direction to it. So reflection, what is the meaning of reflection? You must have all observed in our day-to-day lives. Take a mirror, you will see your own reflection in the mirror. If there is no mirror also, during the olden times, if you simply look inside a water body, say you're sitting simply at a lake and you look inside a lake, you will see your own reflection in that water. That's the famous story of Narcissus as well, no? That's why the term also has come, narcissistic. Narcissus was a person, Greek person. He looked at his own image in water and he fell in love with himself. That's why the term narcissistic comes, one who loves themselves, right? Narcissistic tendency, these terms are used, right? So let's not get there, let's not get into that discussion. But why I'm trying to explain is, reflection is very common phenomena that we observe in our everyday life. That means whenever light is incident on something, that light is reflected. And please remember, it's not just a plain mirror. This shirt is also reflecting light. My body is also reflecting light. Some light is incident and it is being reflected. The spectacles, this particular pen, everything, it reflects light. All right? Except for perhaps the perfectly black body, which completely absorbs everything. So light is reflected not just from a mirror, from other bodies as well. So how is this light reflected? Does it follow some sort of rules, laws? Reflection follows two important laws. Laws of reflection include, first one, that the incident ray, this is the incident ray. Now, the respective reflected ray is this, the incident ray, the reflected ray, and the normal to the surface from where the reflection is occurring, the normal to the mirror. Now, this is how we describe a mirror in optics. If you just draw hashes or the inclined lines below, that means this surface is not going to reflect, the other surface is going to reflect. That means this incident ray, reflected ray, and the normal to the reflecting surface, they must all lie in a same plane. That means these three are in same plane. They have to be in same plane. Right now, I would say they are in the plane of this particular panel. The second law, it says that for reflection to occur, the angle of incidence is always equal to the angle of incidence is always equal to angle of reflection. And please remember that angle is with respect to the normal to the mirror. All right, to the normal to the mirror. That means, let me just erase everything and let me try to explain it again. See, now let me take the board. Now, if this is the mirror surface, you know that this is the incident ray, this is the reflected ray. And when we draw a normal, let me draw the normal with a different color, let me draw it with blue color. Now, please try to understand, I am not telling that this angle is equal to this angle. No, it's absolutely wrong. Let me just erase this so that you do not get confused. What we are telling is, with respect to the normal, this is the angle of incidence, this would be equal to the angle of reflection. Is it clear? Now, this is the law of reflection. And please remember, for any kind of reflection, this law is followed. For any kind of reflection, this law is followed. Now, you must be having a question in your mind. This we have discussed before also. Sir, what if, say, imagine this is the reflecting surface. What if I incident the light exactly normal to it? Then the reflected ray would be exactly opposite to it. That means the angle between them would be zero. That's the basic idea. All right. Now, when we talk about reflection, I told you reflection can occur from any surface. Reflection can occur from any. So I told you this shirt is reflecting, my body is reflecting. If I use a plain mirror, that would also reflect the light. But reflection from smooth surfaces, it is called as regular reflection. Whereas reflection from irregular surfaces which are not smooth or probably which are not polished also, not smooth, not polished or rough surfaces, there also the reflection takes place. Please remember this. Now this reflection, it is called as diffuse reflection or irregular reflection. It is called as irregular reflection. Now, how can you distinguish between the two? It's plain and simple. See, I take a mirror, I can see my own face. But say I look into the water. I give you an example of a lake. I look into the water, I can see my face clearly. That means it is some sort of a regular reflection because water is very, very calm. Now imagine you drop a small pebble in water and then you see your own face. Do you see your own face? You would not see it. That means the images that are formed by smooth surfaces, they are distinguishable. You can identify it. But the image formed through irregular surface, we cannot identify it. The image is very diffused. But please remember, even if it is a regular reflection or irregular reflection, both the kinds of reflection follows the laws of reflection. A very important point. If I simply create an MCQ asking you regular reflection on a smooth surface, it follows both the laws of reflection. Yes. Irregular reflection from a rough surface, it does not follow the laws of reflection. Absolutely wrong statement. That also follows the laws of reflection. Clear? Right. Let's move on. Now, based on this, based on the concept of reflection, we have developed spherical mirrors. We have spherical mirrors in our day-to-day activities or day-to-day lives. Now, you will see that I gave you example of a plane mirror. I give you example of a plane mirror. I said, now if this is the mirror, this is a plane mirror, right? This is a plane mirror, and I say this is the incident light, this is the reflected light. All right, and this is the normal. I'll draw normal with the black ink. This is the normal. Now, as soon as I turn this, now this is a plane mirror. This is an example of plane mirror. But if the mirror has curvature, that means this is the reflecting surface, or if the mirror has curvature, something like this, that means the opposite. This is the reflecting surface. These are called spherical mirrors. Why? Because these are like section of a sphere. Now, if I complete this, I would get a sphere. That's why they're spherical mirrors. The classic example of a spherical mirror would be your spoon. Have you seen a spoon? Spoon has both the sides, right? Spoon has a concave side and a convex side. So spoon, it behaves as concave mirror as well as convex mirror. And we have day-to-day applications of these mirrors, right? Spherical mirrors means mirrors. Once we complete, it forms a circle. Let me just give you an example of this. See, this is a concave mirror. Spherical mirrors can be of two types: concave mirror, convex mirror. Concave, that means the reflecting surface is this. This is the reflecting surface. Convex mirror, this would be the reflecting surface, the outside surface, the bulge surface. So in a concave mirror, this is the reflecting surface. In a convex mirror, this is the reflecting surface, the one opposite. Please try to understand this. Now, if you're not able to imagine it, let me just give you this example. See, any kind of mirror is like a segment or a section of a sphere. If it is a convex mirror, I can simply complete a sphere or a circle like this. Meaning, for this particular mirror, there would be a center of curvature. So there are certain terms that we need to understand, and I told you the basic kind of mirror is this. You can simply check today itself. Take a spoon. If you see, you will get your own image, and you can observe this also. At one point of time, you will get inverted image, especially on the other side of the spoon. We'll understand why that happens. Okay, so there are certain terminologies that we need to understand here. C, going forward, it represents center of curvature. Means if this is the mirror, if I complete the circle, the center of that circle would be the center of curvature. F is the focal point. Focal point means where the light is focused. It is called as focal point. And the radius from point P, from the edge of the aperture, the center of the circle or center of the sphere, that becomes radius of curvature, and the length is called focal length. From this point, aperture point P, to the focal point, it is called as focal length. Because these are used in calculation, although we do not need it from UPSC perspective, but we'll get some insights or some idea about that going forward. Right? So we have two kinds of mirror: concave mirror and convex mirror. Now, the images formed by these can become basis of our question. Now, if it is a concave mirror, remember concave means I simply draw a spherical structure and I need to identify concave mirror based on the reflecting side. Now, for concave mirror, the reflecting side should be the concave side. That means light would be incident from here and reflected something like this. That's why this, the other side, this section, it is not going to reflect. Now, imagine that I incident a light on concave mirror and I place an object is placed. Where is the image formed? Now, if the position of the object whose image is to be seen, if it is at infinity, then the image that is formed would be at focus. Now, these are some ray diagrams. This is the first ray diagram. If this AB is the object, incident light comes and the reflected image is formed at this focus, and you can see the AB image, its height is, say, if I put it as h, then you can see the entire image would be very, very diminished, very, very small. Similarly, if I change the position of the object beyond the center of curvature, then the image would be formed between F and C. That means between the focus and the center of curvature. Again, it would be exactly diminished, and all these images from point number 1 to 5 would be real and inverted. Meaning if I take the second example, see, now the object is not at infinity. This is the object, AB is the object, this is the center of curvature. Now, the incident light, it is reflected, and then the image is formed somewhere between center of curvature and the focus, and that image is a smaller image. This AB, if it is of height h, this would be less than h and it would be inverted, but it would be a real image. It would be real and inverted. So you will get real and inverted images when you place the object at infinity. At infinity, it is very diminished. If it is beyond C, it is very, very small size, it is diminished. Once you put the object exactly at center of curvature, then the image formed would be exactly same height as that of the object. It would be same height. And if you place the object between C and F, and at F, you will see enlarged images, but all these images would be inverted only. If you look at the ray diagram, you will understand that the images formed would be bigger images. But just focus on the last pointer. If you place somewhere between point P, that is the aperture point P, and the focus point, the image would be formed behind the mirror, and this image would be virtual and erect, and this would be enlarged. Now, by the same concept, if you look at simple plane mirror, you do understand this was the plane mirror. This was the example of plane mirror. The image, I'll just draw it again. If this is a plane mirror, let me draw a straight line so that there is no confusion. This is a straight line, this is a mirror, and incident ray or the object is somewhere here. Now you will see the light is incident, yes, and the image is formed behind. This is always virtual image. You do know virtual image, and this image would be erect. A similar concept again in the spherical mirror also we get similar kind of image when we place the object between P and F. There is no need to focus too much on these ray diagrams, but sometimes probably in state PSC etc. you might get certain questions. That's why I'm covering that also. Okay, now very similar to how concave mirror images are formed. If you look at convex mirror, you will see that the object, if it is placed at infinity, then the image is formed at the focus behind the mirror. It is highly diminished. That means in both cases of convex mirror, if you place between infinity and pole anywhere, you will always get diminished image, and you will always get virtual and erect image. Let me just show you the ray diagram so that you understand. This is the convex side. Whenever light is incident, the light is reflected and the image is always formed behind the lens. Image is formed always behind the lens, and the image would rather be diminished, but it is virtual and erect always. All right. So with respect to convex, you get only these two kind of cases, because you cannot, the center of curvature is on the other side since it is the convex mirror. Clear? Now you must have seen a lot of uses of this convex mirror and concave mirrors in our day-to-day life, right? We have used so many concave mirrors in our day-to-day life. Say concave mirrors are used in our headlights. They're also used in shaving mirrors because I want to see closely. I want to see enlarged image. I want to see a virtual and a real image. I want to see basically this virtual and erect image which is enlarged, right? So I do use them in shaving mirrors. The dentists also use them. Large concave mirrors are also used to concentrate sunlight. Then the dentists also use it to see the teeth. You must have seen a dentist mirror, a small dentist mirror. It's a concave mirror. The dentist puts it in your mouth and sees the reflection of that teeth to check it. Right? Now, apart from that, convex mirrors, they are also used in many day-to-day applications. You must have seen that if you are driving a car, the mirror that you have, it is actually a convex mirror, and that's why there is an instruction written there. Objects in the mirror, they are closer than they appear, right? And you see a little diminished image itself. Why do you use it? To see the traffic behind you, right? So convex mirror, it enables the driver to see what is happening behind you. I might ask you a question. I can simply use a plane mirror. Can I use a plane mirror also there? I can use a plane mirror also. That is not an issue. Right? You must have seen in movies, etc., where a hero, if that rear view mirror is broken, then the hero would use some sort of a mirror to check, the normal kind of mirror that we have. That is also possible, but I cannot cover wide angle. I want to see the traffic behind me from a wider angle. That's why I use a convex mirror there. Clear? Right. This is about the reflection concept. Now, there can be questions which can be formed like this. A simple kind of question. Consider the following: dentistry mirror, rear view mirror, and torchlight. There are three examples that are given here. Which of the above uses concave mirrors? That's the question in front of you. Take a few seconds to attempt this question and let me know how you did. All right. The options are given here. A is 1, 2, 2, 3, 1, 3, 1, 2, 3. It's fairly easy question. Such questions can be created. Right. Let's move on and talk about the spherical mirror formula. This is again from academic perspective. Spherical mirror formula and magnification formula, they are majorly used in numericals calculation part. For any spherical mirror, be it concave or convex mirror, you need two important parameters or variables. First is the distance of object from its pole. Pole is this particular point on the aperture. Pole, it is called object distance, and the distance of image from the pole of the mirror, right? So from here, at what distance is the object, and from here at what distance is the image. Based on these two distances, we can calculate the this is the mirror formula. 1 by f is equal to 1 by u plus 1 by b, and based on this we can also find magnification of that spherical mirror. Magnification formula is height of the image by height of the object, and of course if the height of image is more, then the image is enlarged, image is magnified. The same formula also can be derived in this form of the object distance and the image distance as minus u by v. Again, from academic perspective, this becomes a little important, not for us, I would say from UPSC civil services perspective, but just to have some knowledge, we are discussing this. All right. Magnification, common sense tells height of the image divided by height of the object. Right. Let's move ahead and talk about refraction of light. This is a very important concept, refraction of light. Now, what is refraction? Reflection is the incident ray is reflected. The incident ray is reflected. What is refraction? Some amount of light can pass through a medium, and it can change its direction. So refraction basically is bending of light. I would say bending of light when it passes from one medium to another medium. And why this light bends? Light bends because the speed of light changes. Please remember this point, very important. Refraction is the change of speed and change of direction of the light wave when it is passing from one medium to another medium. Now, in our day-to-day life, we have seen it so many times. For example, you simply take a bucket of water and just put a coin in it. you will see that the coin appears to have been raised, or the coin appears to be displaced. Why? It happens because of refraction. Why is that happening? Because if I say, if I have a bucket like this, right? Now light wave is passing from air and there is water in it. There are two mediums now. It is passing from air into water, and that's why it appears as if the coin is at some other place. Have you seen this? I'm quite sure you must have seen. And why does that happen? Please remember, the speed of light itself changes, or speed of light, it differs in different medium. There is some variation in different mediums. Speed of light changes as well as the direction of light changes. It either bends towards the normal or bends away from the normal. That is the meaning of refraction. Now, refraction also follows two specific laws. As I told you, the first thing is you need a medium. For understanding refraction, you need a medium. Now, this is the interface. This is the interface. Now, imagine on this side there is air, and on this side there is water. As I gave you example of the bucket, that means the light is incident, or light is coming at this interface, air medium, and from air medium now it is moving into the water medium. What will happen is the light will change its direction. The ideal direction for this should be something like this, correct? Because light travels in a straight line. We have known this. We have already built this concept right from before itself, right? So now light, it bends, it moves either this side or it moves towards this side, and this movement apparently it depends on the density, or I would say optical density of the mediums. It depends on the optical density of the mediums. Now, what is this optical density? We'll try to gauge that in some time, but I hope that the idea is clear. The incident ray should have moved in this direction, but it has changed the direction to one or the other side depending on the mediums. That is the meaning of refraction. Now, what would be the normal to these surfaces? The normal to these surfaces would be this particular blue line. Normal means 90 degree at the interface. Now, the refraction, the law of refraction, there are two laws of it. First law, again very similar to how we have in reflection, that the incident ray, the refracted ray, and the normal at the interface, normal at the point of incidence, they all should lie in a same plane. Apart from that, please remember, now the angle of incidence and the angle of refraction are not same. Remember, the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is always constant to mediums. That is the second law. This is called as Snell's law. This is called as Snell's law. Now, here, if this is the if this is the first incident ray, the incident ray is at an angle of θ1. Now, this is the normal, and now from this medium, it should have ideally gone. In a straight line, but has not gone in a straight line. What has happened is light has refracted to this direction. Now, with respect to normal to the direction, this is the angle θ1, that is angle of incidence. This is the angle of refraction θ2. And what Snell's law tells is this sine of θ1 divided by sine of θ2, it is always equal to some constant. It is always constant. All right, those are the laws of refraction. Now, this n is a constant which is called as refractive index. It's very important. Now, you must see this particular glass. Why am I wearing these glasses? You will understand again the idea of refraction. Through the idea of refraction itself, we use these lenses. What is happening with my eyes? What is the problem is that the image that is formed behind, on both the sides, there is a slight astigmatism. The image from one eye and both eye, they have to match, right? But there is slight power. I have about 0.75 negative power, not the exact numbers though. But what am I doing through this? I am passing light from here to this particular medium so that they are incident properly on my eyes, right? Properly on my eye, so that image is formed in a correct way behind, right? Why? Because of refraction. So day to day, whatever spectacles you use, whatever lenses you use, they work on the concept of this refraction only. That's why you must have seen that when you go to an optical place or when you go to an ophthalmologist, what they do is they'll tell you that you have some sort of power in your eye, and they will try to keep a combination of lenses, and then they'll try to gauge what is the exact power to form the correct image. All right, and this lens is made up of particular refractive index. That refractive index for a material would be constant, and refractive index, it is a measure of how much the light slows down or how much the light speeds up when it goes through a particular medium. All right, and refractive index of vacuum is always 1. N of vacuum is always 1, and refractive index for any medium N, it is calculated by speed of light in vacuum divided by the speed of light in that particular medium. That is the basic idea of refractive index. Clear? Right. Now you must be thinking, sir, you gave me one example of lenses, one significance, but refraction is extremely significant in our day-to-day life. There are so many phenomena which depend on refraction itself, which depend on these refractive indices, right? Air has a refractive index a little higher than vacuum, 1.0003. Ice, alcohol, you can see refractive indexes of different materials here, just for your reference. Now, the significance of this is we come to know a quantity called as optical density, meaning how the speed of light would be influenced when the light passes through that particular medium. All right, and that's why if vacuum, its refractive index or its optical density is considered as 1, then any other entity whose value is bigger than that becomes a denser medium. So we try to find out which is a rarer medium, because we need to understand what will happen when light passes from a rarer medium. These are some of the rarer mediums, and these are denser mediums. So what happens when light passes from rarer medium to denser medium, or what happens when light passes from denser medium to rarer medium? We'll try to establish this, and this depends on the concept called as optical density. This is the connotation that we use. Now what happens here? What happens? See, when light passes from a rarer medium, now this is the, say, imagine this is air and imagine this is glass, right? Now glass has a higher refractive index than air, and when the light passes from a rarer medium to denser medium, the light, it tends to bend towards the normal. It tends to bend towards the normal. Please remember, from rarer to denser, the refracted ray, it bends towards the normal. Ideally, it should have gone like this, but it has refracted in this direction towards the normal. That means what is happening? What happens is the speed of light rays, it reduces when it passes from the rarer medium to denser medium, because speed of light should be high. That's why in vacuum it is 3 into 10 to the power of 8 meter per second. In air, a little lower. In other mediums, it would be a little lower than that. That means the speed of light reduces and the refracted ray, it bends towards the normal. Now this is a phenomena that you must have seen in many of the swimming pools. Now when you go near a swimming pool, I feel that the water is quite shallow. The water is it's not very deep. It looks as if it's shallow, but as soon as you enter it, you will feel, oh my god, it's very deep. Why does it happen? It happens because of the concept of refraction itself. And the opposite happens when the light rays passes from denser medium to rarer medium. That means the light rays or the refracted ray, it tends to bend away from the normal. Now if this is incident ray from denser, ideally it should have gone in this direction. This is the normal, and it gets away, it gets away from the normal. That means the speed increases from a denser medium. When it comes to rarer medium, its speed increases a little. Now when I say speed increases, please try to remember, when I say speed increases, speed slightly changes, but its frequency never changes. This is a very, very important point. Now if frequency does not change, that means its wavelength changes for sure, because one of the parameters has to change. So when light travels from a rarer medium to denser medium or denser medium to rarer medium, please remember its speed varies a little, its frequency never changes, its wavelength changes, and of course speed is changing. Is speed and wavelength, they are changing a little bit. Frequency always remains same. It's a very, very important pointer from MCQ perspective. All right. Now, sir, I understood refraction, I understood ideas with respect to refraction, but I want to know in my day-to-day life, how is it really significant? In our day-to-day life, in our day-to-day activities, we see so many concepts of refraction. I give you example of this particular spectacle, or when you simply watch a star in the night, right? Star appears as if it is twinkling. Why does that happen? Is the star twinkling? Star is not twinkling at all, but I feel as if the star is twinkling because the light coming from that particular star, it is refracted multiple times when it enters the atmosphere, and it appears as if it is twinkling. So it's actually not twinkling. The twinkling of stars is because of refraction. You must have seen a mirage. Especially on a hot day. On a hot day, you must have seen that on the road you see that the light appears as if it is bending. You see that as if something is burning, and the light appears very wavy, or the image appears very wavy. Why does that happen? Because of heat. Because of intense heating, what happens is, this is the road surface. Imagine this is the road surface. What is happening is, air which is nearer to this road, it heats up and it starts moving upwards. That means the density of air itself is in layers, and when light passes through this, it continuously refracts, and it looks as if the image is blurry, the image is blurred. You must have seen this in a mirage, or you must have seen the looming of luminous objects. Or see, we have sun. Around sun, it appears as if there is another layer which is not exactly circular. Now, why does that happen? Again, it looks like that because of the idea of refraction. The looming around luminous objects is because of refraction. Some kind of a halo is seen. You must have observed even with your bulbs also. Even if your bulbs are, so this light, I don't see too much of looming right now, but you can observe that looming. A kind of a halo is formed around that luminous object. Apart from that, you must have seen that something in water, it is offset from its original position. I give you example of coin. That is refraction, right? You must have seen so many applications. How do we focus light? How does this work? It is focusing light at one particular place based on the refractive index. So it is working on the concept of refraction. How do I watch through a lens, or how do I watch through a microscope? How do I watch through a telescope? It is a combination of different lenses made up of different refractive indices so that I get a proper image. These are some of the applications. Apart from that, you must have seen that these days we talk about optical fibers. These optical fibers, what do they carry? They carry electromagnetic radiation, they carry light. Can we transfer information also through it? Of course, we can transfer information through that in binary form, and that is what is observed. You must have heard about a term called as total internal reflection. Now, this is actually a misnomer. Total internal reflection is a concept connected to refraction of light rather than reflection of light. All right. Now, let me just explain to you. Now, I told you that when light travels, now see, this is the interface. This is the interface. All right. Now, I told you that if this is the denser medium, say imagine this is a denser medium, and if this is a rarer medium, and I told you if I draw a normal to this, this is a normal to it, and now this is the incident ray. Let me use the blue color for incident ray. Now, this is the incident ray. This is the incident ray, and I told you when this happens, means the refracted ray, it moves away. It moves away from the normal. That means this particular theta1 would be smaller, theta2 would be larger. Now, I play around with these refractive indices to ensure that the angle of refraction, it goes on increasing. Meaning, I incident a light and ensure that the refracted wave moves away from the normal. I repeat the experiment. I increase the angle, I play around with the refractive indices, and at one point of time, I would see that at this interface, the refracted ray at one point of time would move parallel to the interface. Yes, And if I further increase the angle, this is called critical angle. If you further increase the angle, there would be a point where this incident ray would completely be reflected. It appears as if it is reflected, but I am ensuring that it is refracted. That's why it's called total internal reflection, meaning the idea is based on the concept of refraction, where I would be playing around with the refractive indices and I would be playing around with the angle of incidence, with the angle of incidence, the angle of incidence. And based on that, I design a pipeline, or I design a conduit through which is made up of different, say here I am creating a conduit of different refractive indices. You can see here there is refractive index 1 n1 here, refractive index 2 n2 here, refractive index 3 n3 here. So what is happening is I ensure that the light is incident in such a way that it exceeds the critical angle. That means this ray would be completely refracted, and I ensure that wherever it is incident, it can be completely transmitted from one end to another end. That is the idea behind optical fibers. That's why you must have seen optical fibers, they have multiple claddings, multiple coverings, multiple claddings of different refractive indices to ensure that no amount of information is lost. That means whatever I send from this side, it is completely reflected inside based on the concept of refraction, and I can receive the information on the other side. That's the total internal reflection. That's why I told you it's a misnomer. I hope it's clear. I hope I have given you good insights into the concept of total internal reflection. Questions can be formed on this as well. In fact, questions have come like this on the topic of refraction, reflection, and in our subsequent classes we'll talk about some other ideas in optics, where we'll talk about diffraction, interference, dispersion, etc. So we'll understand more and more. Questions like this have come where some phenomena have been given: size of sun at dusk, color of sun at dawn, moon being visible at dawn, twinkle of stars in sky, pole star being visible in the sky. Which of these are optical illusions? Now, one of them we have already deciphered. This twinkling of stars is actually optical illusion, because stars do not twinkle. They appear as if they are twinkling, because the light which is passing through Earth's atmosphere, it appears as if it is refracted multiple times. That's why it appears twinkly, but it is actually not twinkling. So it's an optical illusion. So I can eliminate 4. So based on elimination, I do know that this would not be answer, this would not be answer. Or which of the above are optical illusions? So it should have that, all right? It should have that. So the answer would be either this or this, all right? So if you look at the other stuff, you can get answer from that. See, one of the ideas that pole star being visible in the sky, I know that it is not an optical illusion, because pole star is actually visible in the sky because it is directly above the axis of the Earth. So this is not an optical illusion, I know. So I can eliminate this. I do get the answer very easily, right? So questions like these have come before. So make sure that you are thorough with the ideas. You're thorough with the ideas of reflection, refraction, and its application part. Clear? Right. Let's move ahead. Now, we discussed, with respect to reflection, we discussed spherical mirrors, meaning I am interested in reflecting the light. But when I talk about refraction, I am interested in spherical lens. That means I have to ensure that the light is incident on the lens, and either it is focused at one particular point or it converges from that particular point, so that I get, say, enlarged image, or I can focus and look at minute things from a larger perspective. So I use lenses for those, spherical lenses. What kind of spherical lenses do we find? Majorly 2 kinds. That is the convex lens, not mirrors lens, convex lens and concave lens. Now, convex lens means the lens which is bulging at the middle. There is a bulge at the middle. Concave mirror, they are thinner at the middle and thicker outside. They are thinner. You do not find bulge here. You find thin surface, thin face here. And in general, the convex lenses, they converge. They are called as converging lens. If you look at this ray diagram, you see that the light is incident on the lens and it converges at one particular point on the focus. Whereas a concave lens, it ensures that the incident light is diverged. is diverged. Clear? So convex lens and concave lens. Now lens, they are based on refraction. Again, from here also for your reference, there have been some ray diagrams shown so that where is the image formed with respect to a concave lens. If the object is at infinity, then the position of the image is at focus f1, and if the object is between infinity and optical center O, optical center O is this, optical center O is this, and optical center O is here, because it does not talk about the radius of curvature, it is connected with optical center now. So if you look at the ray diagram, you see that the object is at infinity and the image or the refracted ray is diverged, but its image is received here at f1, and that image would be highly diminished, just point sized. Same with the other idea, where if the object is at a finite distance, you will find that the image is formed somewhere between f1 and the optical center. It is also diminished. So for a concave lens, we receive diminished images, but they are virtual and erect images. Concave lenses. Convex lenses, when you talk about convex lenses, there are different positions, and here you can get different characteristics, or you can get enlarged images, you can get same side images, you can get diminished images, but ultimately you ensure that the whatever is your application, you get on the basis of that, you can get real or inverted image, or you can get virtual, erect and enlarged image based on different configurations, right? These are the ray diagrams for that. You can refer that. Again, from UPSC civil services perspective, there is no need to focus too much on this aspect. Very similar to how we discussed with the spherical mirrors, the spherical lens also have exactly same lens formula, very similar to the mirror formula. The lens formula is same, but please remember, it's not 1 by u plus 1 by v, it is 1 by v minus 1 by u, that is equal to 1 by f. And the magnification formula is exactly same. Magnification means the height of image divided by height of object, and you can again derive it in form of v by u, but it is not minus v by u. Please remember, the magnification formula for a mirror was minus v by u. Here it is plus v by u. Right? All right. These formulae are very useful in numericals, and numericals, we do not find them in UPSC examination. We do not get them in UPSC examination. But just for your reference, so that you have an idea what is the meaning of magnification, I'm telling you this. But more importantly for us is another concept. It is this. We'll talk about this in some time. But before that, the power of lens, the formula of power of lens is 1 by f. The power of lens, it is based on this lens formula. You calculate this f, 1 by f, this gives you power of lens. And when you put these lenses in series, or when you use them in collaboration, you do know that for a optical microscope, or for a telescope, or even for that matter for these lenses, you must have seen the combination of different lenses. That's why I told you, when you go to an optical place or you go to an ophthalmologist, what they do is they put a template spectacle on you. They close one side to check the power for one particular eye, and what they do is they keep one particular lens and they say, is it clear? Then they do a trial and error basis. Sometimes they even put 2 to 3 types of lenses as a combination. Now when they are put into combination, please remember, when we use them in some combination, then the power of lenses, it becomes some of those lenses whatever are placed. So during your eye testing, you must have seen this. I'm quite sure many of you must have felt that the doctor will ask, is it clear? He asks, is this lens clear or the other lens clear? Then he will go for some sort of combination and then ask you, is it much clearer? Whatever suits best for you, you get that as your spectacle. I am quite sure that people who wear spectacles, they understand that. People who wear goggles for style, they will not get this too much, because once you get that eye testing done, I'm quite sure you'll understand this slide in a better way. All right. Right. Now, apart from that, the important idea for us is to understand where spherical lenses are used. You must have seen in our day-to-day life, spherical lenses are used manywhere. Both convex and concave lenses, they are used in spectacles. You must have seen convex, concave lenses in spectacles also. But you must have seen lenses used in microscope, magnifying glass. In our childhood, we used to take this magnifying glass and focus the sunlight. That's the classic idea of a convex lens. You hold that magnifying lens in front of sunlight and you will see that the sunlight is focused at one particular point, and after some time, if you incident that particular light on a paper, that paper burns. Why? Because you're completely focusing all the sunlight at one place. Heating will take place, right? Now, apart from that, you must have seen in telescopes, projectors, camera lenses, many convex lenses are used. Apart from that, concave lenses are used in binoculars. They are used in flashlights. They're used again in telescopes. In telescopes you use different combination of lenses. In eyeglasses you use concave lenses. All right. So lenses have multiple applications. So make sure from next time, whenever you're outside or whenever you are getting some sort of application, check what is it. All right. Say what kind of lens is it? What kind of image is being formed? Say for instance, there is a small assignment for you, right? What kind of lens do we use, say, in a keyhole? Do you have a keyhole at your home? Say if anybody rings your doorbell, what do? You go and peep through the keyhole and check who is it, and you will see that the keyhole is just this, but there are many keyholes in which you can see the complete person outside. So what kind of lens is it? Do let me know in the comment section, because questions like these only come in UPSC based on day-to-day activities, based on common sense. All right. So that's the end of today's chapter. We'll meet again in the next or the subsequent chapter. All right. Thank you very much for watching. Now, even before this, in our standard 8th discussion, standard 9th NCERT, we have understood some concepts about light. I told about the luminous objects, opaque objects, transparent, translucent objects. We also discussed some insights or some idea about how human eye works. All right. So today we'll talk about that and we'll gain more insight into working of eye. Along with it, we'll discuss about a very common feature. Right now, I'm wearing a spectacle. The question is, sir, why are you wearing this? We'll try to understand that as well. First, let's look at the human eye. Now, in our general life, we talk about our mobiles, right? A great mobiles. We say it is 10 megapixel, 20 megapixel, 50 megapixel. It has camera, right? It has multiple cameras. But I would say the best camera is our eye. Human eye is like a camera itself, and it is one of the best cameras in the entire world. All right. Now, you are thinking, sir, how is it possible? How is it possible? Where is the image formed? Where can I see the image? See, if you look at the cross section of eye, light has to pass through your eye and some image has to be formed. Right now, what I can see a chair here. Now, if I have to see a chair, the image of the chair has to be formed somewhere behind the eye, correct? And it is formed on the retina. This retina is like the picture film, right, on which the picture is formed. And I am seeing exactly the same thing. The chair is the picture is seen on retina. How it happens? In our eye, when the light passes, and I told you already, we see things around us mainly because of reflection. The light is reflected from those surfaces and an image is formed, correct? Now, how it works? Eye has different components. The external eye has a cornea. It allows the light to enter. From cornea, there is iris. It controls the movement of the pupil. That means how much light enters in your eye. It is decided by iris. Iris for every individual is quite unique. Then there is pupil, the black part in your eye through which the light passes. And behind these, there is a lens in our eye. This is a crystalline lens. Now, human eye lens, it has a very peculiar characteristic. The focal length of this particular lens can change to a limited extent, and this is achieved by these ciliary muscles. And you do understand that we have a complex connection with the brain, from eye to the brain, because we need to perceive things, and for that I have optic nerve. That means the image recognition happens basically through optic nerve. Now, if you're thinking, sir, I want to understand further what exactly happens. So this is your eye. There is this white part called sclera. Now, this sclera, it helps in providing proper environment for the eye. Sclera also protects the eyeball from any damage or injury. Now, eyeball basically is this part, this rounded part that you have. The outermost part of the eyeball is your cornea. Now, the cornea, as you can see here, this is the outermost layer. This is the cornea, the outer layer. This protects the internal parts. The internal parts are pupil and iris. The human cornea is approximately 2 to 2.5 centimeter in diameter. The cornea, it also helps in refraction of light. This cornea helps in focusing the light onto the retina. Now, the light passes through the cornea. Now, it has to pass through iris and pupil. Now, what is the job of iris and pupil? Both of these, they are responsible for controlling the amount of light that enters your eye. Pupil is this black part, and you do know that we understand the concept of pupil dilation. Pupil dilation means the pupil becomes bigger in size, or pupil contraction, the pupil becomes small in size. Along with this pupil, the iris muscles, they also move. Iris and pupil, they help in controlling the amount of light that passes through the eye. For instance, if there is too much light here, now if there is too much light, what happens is the iris, it consists of iris muscles. Now these iris muscles, they will expand. Now if the iris muscles expand, that means your pupil, that will constrict, that will contract. Less amount of light passes through it because already outside there is too much of light. And reverse happens when it is dark. If it is dark, I need more amount of light to pass through my eye. That means the pupils, they expand. If the pupils are expanding, that means the iris muscles, they are contracting. And these iris muscles, they are peculiar, they are colored. Now iris is the circular colored area. That color is because of your your iris muscles. And every individual has a unique iris print. Iris is like a fingerprint. You must have seen that you have given 10 fingerprints. Along with it, you have also given your iris scan. These iris muscles are unique for every individual, and iris muscles are responsible for the color of your eye as well. Some people have brown eyes, some people have blue eyes, some people have black eyes. It's because of the iris muscles. All right. Now, light has now passed through cornea. Then the proper amount of light has entered into iris and pupil. Now, I have to form the image. For forming the image, the light has to be focused through the lens. Now, this is the lens. This is the lens that we have, a crystalline lens. When the light passes through it, the job of this lens is to ensure that image is properly formed exactly on the retina. Please remember, it should not be formed in front of retina or behind the retina. If this happens, then you have some sort of eye defect. And that is why our eye lens, it has the capacity of changing its thickness. It can become thicker or thinner. As I told you, if you have a camera, you set the camera lens to focus on something. But human eye has already the ability to become thick or thin depending on your focusing. And this is possible because of your ciliary muscles, because this lens, it is connected to ciliary muscles, and these ciliary muscles, they ultimately help in thickening and thinning of the lens. If you have to focus on nearby objects, the lens becomes thicker. If you have to focus on far away distant objects, the lens becomes thinner. And ultimately, remember that the image has to be formed exactly on the retina. If it is being formed anywhere else, ahead or behind, you have some sort of eye defect. All right. Now, I understood, sir. Light has entered. If I have to see there is a chair here. If I have to form an image of the chair, what happens? I have to first allow the light to pass through it. That reflection is passing, and I have to create that picture. Now that picture would be created where? On the retina. I have to analyze the picture as well. And for that analysis, I have optic nerve. This optic nerve, it assesses what kind of an image is that, or what kind of object it is, and it forms the image on my retina. And this retina is like a film. This retina is like a film, and this film has different kinds of cells. These cells are called photoreceptors. These cells are called photoreceptors. They receive signal from the brain. They receive signal from the brain via the optic nerve. Now, this is the optic nerve which is connected, and the image is formed. Let me just clear it up. The image is formed on this retina. On this retina, through the optic nerve, it analyzes the information and gives you that image. Now, retina has two kinds of cells, two kinds of photoreceptors. One are called cones, the other one called rods. Now, to remember these, please note that our retina, it has two cells, cones CO. Remember, if there were no cones in my retina, I would see everything is black and white, because cones are responsible for, first of all, colored vision. Apart from that, cones are responsible for my frontal straight vision, the central vision that I have. Along with cones, we have rods, the rod cells. These rod cells are responsible for the peripheral image that I have. You do know that human eye, it can see straight. It also has some sort of peripheral vision. I can see my own hand, but not focused. I am not focused on it, but I can see there are two objects here. It is because of the rods. The rods are also responsible for the black and white imagery as well. Now, apart from this, you need to remember that there is one particular blind spot in our retina. This blind spot is where the optic nerves connect with the retina. And that's why at this particular spot, there would be no image formed. That's why there is certain point in my retina where I cannot see my image. I cannot see the image because at this point, optic nerve is connected. So at this optic nerve, there are no photoreceptors, and that's why there is no image detection as well. All right. So this is basically the anatomy of our eye, inside the eye. Now let's talk about the eye image formation mechanism and some of the defects connected with our eye. Now, there is one concept connected to our eye which is called as power of accommodation. Power of accommodation. What is the meaning of this? I told you, human eye is the best camera that is available in the world. Why? Because human eye has the ability to focus on whatever thing you want automatically within a certain limit, of course. Within a certain limit, automatically. All right. Now, how? Say for example, let me just pick up my mobile. All right. If I want to read something, I want to read something on my mobile. If I hold my mobile this close, can I read? I cannot read. The same thing, if I hold my mobile far away from here, and can I read? I cannot read even now. That means human eye has a limit. Human eye has a limit of focusing. I can read anything properly. If I hold a paper, if I want to read, if I hold it approximately 20 to 25 centimeters from my eye, I can read it properly. I can focus properly. Now, this range of focusing of the eye, it is called as power of accommodation. And we have a natural power of accommodation because of the ciliary muscles. Human ciliary muscles in the eye, they tend to thicken the lens or thin the lens automatically, allowing us to focus on distant objects as well as far objects. Now, this is called as power of accommodation, the ability of eye to adjust its own focal length because of the ciliary muscles. It is called as power of accommodation. Now, many a times what happens is this power of accommodation, it becomes weaker. Why? Our ciliary muscles might get weak, or there might be some other problem with the eye, and that is when problem occurs to us. As I told you, the image has to be exactly formed. If the light passes through it, the image has to be exactly formed at the retina itself. If the image is formed somewhere inside the eye or outside the eye, then you have eye defect. Now, what are these eye defects? We have eye defect called as myopia. Now, myopia, it is basically known as nearsightedness, meaning if a person has myopia, that means they can see nearby objects very, very clearly, but they cannot see distant objects clearly. Now, this is very common, especially in youngsters these days. We see a lot of people having these spectacles. I also have one, right? I also have one. In fact, when I went to doctor, my eyes were being tested. The doctor told me I have astigmatism. This is another peculiar case. That means I told you image has to be formed exactly on retina. Both the eyes have to form at the same spot. Now, the doctor told me you have astigmatism. Your image, one is proper, one other image from the eye is not being properly created. So what you need is a correction for one eye. So I have problem in one eye, right? I don't remember the exact power, but there is one problem, one eye has problem where the image is not being formed properly. So if you ask me, sir, if you remove your spectacles, can you see? Yes, I can see properly. I can read properly also. But sometimes when I read, I have to focus a lot, which might lead to a little bit of headache sometimes, right? But nonetheless, what is myopia? Now, this myopia, it is a situation where a person can see nearby objects very clearly, but if it is far away, they say, I can see it, but it is very blurry for me. That's when you go for your eye testing. That means the image, it has to be formed properly at the retina. This is the normal image, but what is happening is the image is being formed somewhere else, and for that you need correction. Now, this might happen because of problems with your with your ciliary muscles, problems with the curvature of your eye lens, or it can even happen because of the elongation of eyeball. Now, in such a case, what can you do? You can simply use a concave lens. You can simply use a concave lens. Why? If I use a concave lens, that means what my understanding is, the image is being formed in front of the retina. I want to make sure that it is formed exactly at the retina. That means I have to focus the light, or I have to expand the light and focus on the lens, my natural lens, properly, so that image is formed here. That is myopia. The opposite of myopia is hypermetropia. Hypermetropia is called as farsightedness. Is called as farsightedness. Now, farsightedness means a person can see distant objects clearly, but they cannot see nearby objects very distinctly. Now, this happens predominantly, I would say, at a little older age, somewhere around 40, 45 approximately. These days, any kind of problem is coming at any age. Why? Because of the use of digital devices. But in general, myopia is seen at a younger age, and hypermetropia is seen a little later, somewhere around say at the age of 40. Now, what is happening here? That the image that has to be formed properly here, it is formed beyond the eye. It is being formed outside the retina. Now, in such a scenario, if I have to make a correction, I have to simply use a convex lens. Now, using a convex lens, I ensure that light is properly focused on my natural lens. Using it, image is formed on the retina. Apart from this, many people can have both. Now, this is called as presbyopia. The name itself, presbyopia. Now, presbyopia means the power of accommodation has gone down, meaning a person is facing both the problems. They are facing a problem of viewing the distant objects very clearly, problem there also, and also problem reading things. Nearby objects cannot be seen very properly. This is called as presbyopia. Now, presbyopia is very prominent, especially in old age people. You must have seen old age people that they have problem with both. And how do you get a correction there? Because now the power of accommodation is now problematic. The ciliary muscles, they have become weak. So what happens is they have to put in too much of effort to form an image. Distant image, there is a problem. Nearby image, there is a problem. So what do? You go for a bifocal lens. You must have seen many people wearing these kind of lenses, right? These kind of lenses where there is correction for distance here, and there is correction for nearby vision here. Do you have any elderly people at your home who have dual kind of lenses? Right now, I do not have a dual kind of lens, right? My problem is mainly with the distant vision, is right now with the distant vision. All right, again, distant vision also I can see, but I have to focus, which leads to a little bit of headache. So probably when I enter my old age, there would be another lens at the bottom. For reading, you have to view from that, and for watching something else, you have to read from the upper lens. You must have seen them. Those are called bifocal lens. All right. Now, apart from this, you need to note one more thing, that eye donation can be done. All right. Even if a person dies, for approximately 3 to 4 hours, eye can be removed and eye can be donated to someone else. All right. So, did you know that eyes can live even after our death? And if we can donate our eyes, then someone else can get that vision. Please note that eye donors can belong to any age or any group, any age group, any specs. People who wear spectacles, they can also donate. People who do not wear spectacles, they can also donate. Please remember this particular point. MCQs can be formed on this simple question. People who have eye power, they cannot donate eyes. Nothing like that. People who have cataract, they cannot donate. They can also donate. Right? Anybody can donate. All right. People with some sort of disease like hypertension, asthma patient, etc., they can also donate eyes. The only thing is that whenever there is death, eye has to be removed within 4 to 6 hours. The eye bank team will come. If you contact them, if you decide to donate your eyes, just contact the eye bank team. They will come, they will collect the eye without disfigurement. They can do it properly through a simple procedure at home itself. These days that facility is available at home itself. After death, you simply have to sign a consent form. Please remember, who cannot donate eyes, right? People who are infected or who have died with AIDS, who have died with hepatitis B or C, who have died with rabies, who have died with leukemia, tetanus, cholera, meningitis, encephalitis, they cannot donate eyes because it ultimately spreads to the other person to whom it has been donated. It leads to problems. All right. Right. Now, apart from this, let's talk about some natural colors. Since we have understood about the anatomy of eye, now we'll try to understand about the colors. Now, we have understood the concept of refraction in our previous class. In fact, I began our discussion with this itself, right? The idea, reflection and refraction. I explained to you. Now, when you see refraction through a prism, this is just one surface. Please remember, this refraction is only through one surface. Now, let's talk about refraction through prism. Now, prism has three surfaces. Prism has three surfaces, correct? Now, as the light enters here, it will be refracted. It will be refracted. The correct path of this light would be in this particular direction, but that does not happen. Now, it is refracted. It is refracted in this direction. Now it enters, or it is at the second interface. Now, when you look at the second interface, it will again be refracted in the same direction. Now, through a normal prism, you will see that the light which enters, it exits in a similar kind of direction, just in the opposite. Now, light was incident in this way. Now, if you look at this in the opposite direction, it is refracted. Now, this is what happens in a normal prism. But if we pass sunlight or white light through a glass prism, we will see that a white light of beam, when it is incident on a prism, it will break into its constituent colors. That is what we call as the colors. We can remember them by the acronym VIBGYOR, VIBGYOR, right? White light, the sunlight, it comprises of 7 colors: violet, indigo blue, green, yellow, orange, and red. This is in the order of increasing wavelength. All right, from 400 to approximately 700, 750 nanometers, or 800 nanometers also, because that is the visible range that we have. When we pass white light through a prism, it breaks into its constituent colors. Now, there were some experiments conducted. A prism can break a white light into its constituents, the 7 colors. 7 colors of the rainbow that we call. Now, there were some experiments that can we further break these lights? Can we further break these lights? For instance, if I place another prism here, can I further check the constituents of red light as well? That was not possible, and this experiment was conducted by Isaac Newton. Isaac Newton first thought that if a glass prism is able to give me the spectrum of sunlight, which gives me 7 colors, now can I go further? And through another prism, if I introduce, can I see the constituents of red light? Can I see the constituents of yellow light? Can I see the constituents of other colored light? He tried to run that experiment, and he understood that if white light is passed through a prism, it is refracted, and the constituent light comes out, 7 colors, and those 7 colors, if I put another prism, they will again combine to give you white light ultimately on the screen. So what we realized is white light comprises of only 7 colors, and these 7 colors are the VIBGYOR colors. All right. So white light comprises of these 7 colors, we established. And many a times we see the phenomena of refraction in atmosphere itself. You must have seen a rainbow. Now, what is this rainbow? Rainbow is a very natural process. You must have seen that whenever there is rain, and if there is sunlight also available, you will get a rainbow. Rainbow, it has 7 colors. Again, VIBGYOR colors. Why that happens? Now, that happens because the rain droplets that are in the atmosphere, they act as a prism itself. The sunlight passes through a raindrop, it gets refracted, it gets internally reflected as well, and then the constituents of white light can be seen. And you will see that the rainbow can always be seen in the opposite direction. If sun is towards this side, on the opposite direction, you will see the rainbow. So rainbow formation is because of multiple phenomena. The white light breaking into its constituent lights, it is called as dispersion. The white light, it disperses into its constituent colors. So rainbow is formed because of dispersion of light, It is formed because of internal reflection, and it is also because of refraction in the rain droplets. Now, apart from rainbow, we see many phenomena in atmosphere. Because of refraction, we see so many phenomena. The first phenomena is the twinkling of the stars, the phenomena of apparent shift of objects, especially celestial objects. For instance, if I look at a star, we see that the star is in some apparent position. Now, because of which we see, of course, the light has to pass from the star. It has to travel. It has to travel millions of light years, and then it enters Earth. Now, if I view a star, I will always see its apparent position, and by the time light enters our atmosphere, that light is refracted, and because of which I see twinkling of stars. Twinkling of stars is because of continuous refraction of that light from the star. I'm talking about starlight, not the sunlight. Starlight being refracted continuously in my atmosphere, it leads to twinkling phenomena. Apart from that, I also see, if I'm looking at a particular star, that is probably the apparent location of that star. All right. In fact, we discussed in our previous classes that probably the light that is coming from the star, that might be past, because it takes a lot of time to reach Earth, and by that time the Earth is also revolving around the sun. Earth is rotating on its own axis as well. That's why we saw the light coming from the stars, that might be the light from the past, right? Now, apart from this, we also see some other phenomena like advanced sunrise and advanced or delayed sunset. You see, because of the refraction through atmosphere, we get an early sunrise. The sun is visible almost 2 minutes before the sunrise itself. Before actual sunrise, we can see the sun, and after the sun has set, we can see sunset for another 2 minutes. This is again because of the phenomena of refraction. We see early sunrise and delayed sunset due to the apparent position of sun or apparent location of the sun. Again, refraction through the atmosphere. Apart from this, we also talk about the scattering. Light, when it enters atmosphere, it is scattered. Light interacts with different particles. Now, our atmosphere has different particles. It has dust particle, it has glass, it has not glass, it has gas molecules, etc. So light interacts with these impurities, dust, and light is scattered. Now, this scattering, it ultimately depends on the size of the molecules, size of the particles. If the size of the particles, it matches with the wavelength of the particular light. I told you, white light, when it disperses in 7 colors. 7 colors are different wavelengths, and a particular wavelength can interact with particular molecule, then that light would be more scattered, and that is why we see this phenomena. We see the Tyndall effect. We see that when a light source is passed through complete or a perfect solution, light is not visible, light is not scattered. But if you pass through a colloidal solution or a suspension, you will see the scattering of the light. Why? Because the molecules or the atoms in this colloidal solution suspension, they interact with light and they scatter. And very similar phenomena happens with this also. We see that sky is blue. Why is sky blue? Why is sky blue? Is only blue light entering Earth? No. White light is entering Earth. But Earth's atmosphere has different kind of particles, and these particles, they interact with light in such a way that they scatter blue light the most. So I can only see the blue light, and the other light, it is not being scattered, it reaches me, but scattering at some height, it leads to that blue look. All right. Why? Because the size of blue waves and violet waves especially, they are just the right size to hit and bounce off the molecules of gas and molecules of dust and water molecules in the atmosphere, because of which we see blue sky. Now you must have a question. Sir, you said that sky is blue on Earth. Is sky blue on other planets as well? Not, that depends. That depends on the atmosphere of that particular planet. In fact, NASA's imagery has shown us that sky in Mars is different colored. Sky in Mars is a little different in color. Now, these are some of the pictures of Mars. They have shown that the sunset there is actually of opposite of what you would experience on Earth. All right. During the daytime, the Martian sky, it basically takes reddish or orangish color, but the sunset in the sky, it has a bluish tinge. So what we see on Earth, its reverse can be viewed, or its reverse has been pictured from the Mars. All right. Now, apart from this, there is one more phenomena. Because of light, we do see that sky is blue, but during sunset and during sunrise also, we see the sky becomes a little reddish or orangish. Why? Why does this happen? See, this is because as the sun gets lower in the sky, the light passes through more and more of atmosphere. That means blue light is scattered even more. Of course, blue light is scattered. Blue light is scattered multiple times now. By now, it has scattered multiple times. It allows red and the yellow lights to pass through our eyes straight, and that is why it looks reddish to us. Again, this is I would say an optical illusion itself. Is the sky turning red? Is the sky turning orange? No, it's only because of the interaction of light with the dust, water molecules, different pollution, right? So larger particles of dust, pollution, water vapor, atmosphere, they reflect more and more of red and yellow, because now the blue light has already interacted, it has scattered more, so I cannot see blue. I do see this scattering. The scattering of red and orange is more visible during the daytime or during the morning time, and especially during the evening time. That's why we see sun also appears reddish, the sky also appears reddish or orange. All right, based on this, many times questions have come in form of MCQs. Please note these down. All right, that's the completion of this chapter. We'll continue our discussion in the next. Now, the concept of electricity is relatively new. I can say electricity as an idea, it is of the modern world. It's not of the medieval world. You do know during ancient times, during medieval times, there was no electricity. The concept of electricity has emerged during the modern times, since the time we are able to control, we are able to transmit, generate, control, and transmit electricity. So in this discussion, we'll understand what is electricity, or how do we define electricity. We define it through the concept of electric current. What is the meaning of electric current? What constitutes current? And how that electric current moves from one place to another place. We'll understand all these things, and from the perspective mostly of our day-to-day life itself. All right, let's begin. First things first, what is the meaning of electric current? When I say electricity and electric current are used, I would say, synonymously. Electric current is basically the movement of electric charge through a particular area. So electric current, it is expressed as the amount of charge that is flowing through a particular area in a unit time. Now we defined two terms. One is the term called as electric current, and another connected term, that is electric charge. So this electric charge means basically movement of electrons, and I'm telling you that electric current is the movement of this electric charge through a particular area in unit time. That's how we define electric current, and it is denoted by the term I. You must have seen, if you have any devices at your home, you must have seen there is some sort of rated current on it, and it differs from equipment to equipment. For some equipment, it might require milliamperes of electric current. For some, it might require a little higher current. For instance, this panel is connected to the board. The board is there, and that board itself, it has a connector of 16 amps. That means the connector can handle up to 16 amperes of electric current. All right. So I, basically electric current, it is defined as Q by T. Q means the amount of electric charge moving through one particular time. Now you will have a question. So what is this electric charge? Do I have any defining parameter for electric charge? Yes. Electric charge, it is expressed through a unit called as coulomb. Electric charge is expressed in coulombs. It is measured in coulombs, and its measure is basically the charge that is contained in nearly 6 into 10 to the power of 18 electrons. It makes 1 coulomb. So 1 coulomb, it's equal to 6 into 10 to the power of 18 electrons moving. And when they pass one particular area in a unit time, that makes electric current of 1 ampere. Now, electric current, it is denoted or expressed in the unit called as ampere, and 1 ampere power, that would be equal to 1 coulomb of charge. That means 1 coulomb is equal to the charge that is carried by 6 into 10 to the power of 18 electrons per second, per unit time, per second. That is the meaning of 1 ampere. So 1 ampere is very high current. Okay, it's a very high current. In fact, many of your equipments, they use microampere or milliamperes of current. There are some which are high end equipments or which require more power. They use higher ampere electric current. All right, so that's why you must have seen that there are many equipments which are mentioned or expressed in terms of milliamperes or microampere as well. And when you connect in a circuit, if I want to measure the current, I connect an ammeter to it. Ammeter is denoted by this A. All right, this is a simple current where the power is flowing here. And please remember, when I say electric charge in a conventional way, you need to remember something, that in a conventional way, the movement of electrons happens in one direction, and conventionally we say electric current is moving in the other direction, because conventionally we say current is the movement of positive charges. All right, please remember this particular point, very important from MCQ perspective. So when I connect a circuit, current is moving and it is lighting this particular bulb. If I have to measure it, I connect an ammeter to it. Please remember, ammeter should always be connected in series. It cannot be connected in parallel, because say imagine if I connect an ammeter parallelly to this particular bulb, hypothetically if I connect ammeter here, meaning current would pass through this bulb, current would pass through ammeter through a separate line or a separate segment. All right, right. So what did we understand? We understood the idea of electric current. Electric current means movement of electric charge. Electric charge is measured in coulombs. How much amount of coulomb per unit time is moving, that is defined as current. All right, now this current has to move from one place to another place, correct? Current has to move from one place to another place, from say point A to point B. Now, how does this current move? How does, or why does this current move at all? Now, to understand electric current, let's study it in an analogous way with other currents. Now, you know air currents. Air current means basically wind or movement of air. We also know water currents. That's why there are two diagrams. You must be getting confused that, sir, we are discussing electric current and you have put the diagram which talks about winds. Now, this is the example of winds. These are the winds itself in our atmospheric circulation wind system. These blue ones are the westerlies. Blue ones are the westerlies. You have yellow trade winds in the northern and southern direction. And this is the ocean currents that you have, right? You know, in ocean currents you have many. There is north equatorial current, there is south equatorial current, right? There is Venezuela current, there is Gulf Stream. There are many ocean currents. Now, do you know why air current or current of air moves or water current moves? Now we have understood that from our basic I would say physics 101, whatever we have understood from 6, 7, 8, 9. We know, sir, air moves from a location of high pressure to a location of low pressure, correct? Or wind is nothing but a movement of air from one position to another position, high pressure to low pressure. Now same thing with water also. You do know water, it needs some sort of gradient, isn't it? It needs some sort of gradient. Say it can be gravity. If I simply have a horizontal pipe and I put water into it, it will not move. There has to be some gradient. It may be because of gravity. It may be because of gravity, or it may be because of some other characteristics. For instance, the ocean currents are because of stratification of ocean water. The ocean water is stratified based on temperature, based on density. We do know that warm waters, they are above, and below these warm waters you have dense and cold waters, and that's why you see circulation, mixing. So we understand that for any current, be it water current or air current, there has to be some sort of gradient, isn't it? There has to be some sort of difference, meaning from point A I have to move it to point B. That means there has to be some difference between these 2 points, correct? Now for electric current, I understand two things. first, if I have to move, if I have to transfer current from point A to point B, first thing is they have to be connected. Now they have to be connected. From in the modern times, we have understood they have to be connected through a conductor. They have to be connected through a conductor. I just wrote the spelling of conductor wrong. Okay, it happens sometimes. All right. So I have to connect them through a conductor. What else is needed? There has to be some sort of a difference between these two, very similar to how gradient is needed for water and air. The flow of charges through this conductor, it will occur only when there is potential difference along that conductor. That means there has to be different potential here. And what is that potential? It is called as electric potential. For air, it is from high pressure to low pressure. For water, some gradient. Okay, it may be gravity or any other parameters that we saw. And for electric current, there has to be difference between the potentials at point A and point B. Now comes the question, what is this potential? I want to understand what is this potential. I understood that there has to be a difference. That means electric potential difference has to be there between these 2 points. But first of all, how do I define that electric potential? Now, electric potential is defined as the work done per unit charge to bring a single charge from infinity into a point in the electric field. Meaning, see, how much amount of work is done. Imagine that I have electric field here. I have electric field and the electric field lines are emanating outside. Yes. Now, what is this potential, electric potential? There is one particular charge here. Now, I have to bring this charge into the electric field at one particular point. The amount of work done that is needed to bring this charge into one electric field, it is called as potential. And what is the potential difference? Potential difference means if I have to transfer this particular charge from one point to another point inside the electric field. That's the basic difference. It's a little technical, but if you keep this in mind, that potential, electric potential means it is a work needed to bring unit charge from a point at infinity into the electric field, into one point in the electric field. And the same potential difference or the electrical potential difference that we talk about, it is the difference between or work done to bring a point in that field from point A to point B. And how do we calculate it? Remember, a potential difference between 2 points in an electric field, they depend on work done and the charge, whatever you're moving. Work done. Now, work done means work is measured in joule. You do know unit of work is joule, right? And unit of charge is coulomb. So one voltage, potential or potential difference, they are calculated as work done per charge, meaning joule by coulomb. All right. Now, the question is, what kind of difference is needed? I told you, for movement, I always need, or I always see that the charges will move from high potential towards low potential. From high potential towards low potential. All right. Meaning, if I have to transfer this charge, there is high potential needed here, there is low potential needed here. Then some current, some electric current will move. Some electric current will move. All right. Right. What is the difference or what is the relation between this voltage and current? We'll understand in some time when we talk about the Ohm's law. But right now, what we understood, there is an electric current, which is nothing but movement of charge. That movement of charge, it depends on the potential difference between 2 points. All right. Now, the next idea is, when I connect something in series, I have to measure 2 things. That means through the ammeter, I measure the electric current, and through the voltmeter, I measure the voltage. The voltage, whatever is there. All right. Now, in a circuit, when we draw, there are some connotations which we need to know. Sometimes questions might arise on this. I would say there is very low probability of question coming based on circuits in UPSC Civil Service examination, but in NEET, JEE, you will find these questions a lot, right? An electric cell is denoted like this. You draw a longer vertical line and a shorter vertical line and just connect it. this would become the positive terminal, this would become the negative terminal, and you put it in the combination again. Please remember, you cannot combine. Now I cannot do this, you do understand, because they will neutralize each other. That's why if I have to connect next battery, again it would be positive and negative in this direction. This is in series. So similarly, this is the definition of a plug or a switch. This is a simple wire joint, a T joint. This is wire passing without joining in a circuit. They are not joined. This is electric bulb, or many a times it is also denoted or written as load in many circuits. This is the connotation for a resistor. What is a resistor? We'll talk about it in some time. This is ammeter. A is ammeter, V is voltmeter. These are the connotations that we use in electric circuits. Now, question comes, sir, what is the relationship between electric current and voltage? Because of course, by now I have understood that current will pass, and that current, it depends on voltage, or the difference in voltage, the potential difference that we call. So this relationship was given by Ohm, by the discoverer Ohm. That's why it's called Ohm's law. Now Ohm's law, it basically gives the relationship between your voltage and your current, and it can be best described through this particular diagram. Now you see the potential difference or the voltage, it is trying to push the current. You do understand, because of the potential difference, because of the voltage, the current is trying to move through the conductor, and this current is resisted by this ohm. Ohm is a unit of resistance. So this is Ohm's law, where voltage, current, and the resistance relationship is given. Voltage is directly proportional to the amount of current that passes in a circuit. All right. So remember, voltage is directly proportional to the amount of current, that is the potential difference. It decides how much amount of charge will move in unit time, or per unit time. Voltage is directly proportional to current. If you remove this proportionality signal or proportionality symbol, pardon me, you get the constant called resistance. And if you draw a graph, you will see that the resistance graph would come something like this. Any circuit or any device which follows a relationship between voltage and current in such a way that resistance graph is something like this, these devices are called ohmic devices. These devices are called ohmic devices. That means they follow Ohm's law. All right. Right. So this is Ohm's law. Now, next thing, what is this idea of resistance? Because using this concept of electricity, I have understood that there is some sort of a constant called resistance. Resistance is that constant which establishes relationship between voltage and current. Now, what does this resistance depend upon? Because it's very important for me, because I have understood to move a charge from one point to another point, I do need a conductor which is able to transfer those charges, and resistance is a property connected to that conductor. All right. Now, what does resistance depend upon? Resistance, it basically depends upon the length of the conductor, or length of the material. It depends on the area of the material, and it also depends on a constant which is connected to that material. It is denoted by rho. So resistance is equal to rho length by area. So resistance depends on the length of the material. Please remember, longer the material, greater will be its resistance, because it is directly proportional. The second thing is area. Area, it is inversely proportional. That means larger the area, lesser would be the resistance. It also depends on temperature. Although it is not there in the formula, but the resistivity, it ultimately depends on the temperature. So resistance, it depends on temperature of the material. Higher the temperature, higher the resistance. Very important, remember this. Higher temperature, higher resistance. That's why you talk about superconductivity. Superconductivity means very low resistance. At what temperature do you achieve superconductivity? Very low temperature. That's why you see we talk about quantum computers. Quantum computers, they work on the concept of superconductivity only. That's why the quantum computer itself, it needs very low temperatures for working. All right. That way you can remember. Again, it also depends on the material. Material means this constant which we define it as rho, or resistivity of the material. It also depends on that. Different materials have different resistivity. For instance, from NCERT, if you look at these conductors, they have very low resistivity. If they have low resistivity, low resistance, they allow current to pass very easily. You can say silver, copper. Copper is something that we use for connection, for making wires. Aluminum also. There are many other metals that we can use. You can see the resistivity is very low. It is of the order of 10 to the power of -8. But if you look at insulators, their resistivity is extremely high, of the order of 10 to the power of 10, 10 to the power of 12, 13, 14. That means they do not allow current to pass through them at all. They do not allow charges to pass through them at all. Again, there is no need to mug up these numbers, but I want you to understand that the resistivity of conductors is very low, resistivity of insulators is very high. That means the resistance depends on that resistivity. Clear? Right. So what all we have established? We have established the meaning of electric current. Electric current is the movement of charges. That movement of charges happens because of voltage potential difference. And we have understood the relationship also between them. Now, when we talk about connections, how do we connect any equipment? Say when I say any equipment, that equipment has some resistance, right? So any equipment or any resistor, how do we connect? We can connect them either in series, or we can also connect them in parallel. Whenever we connect multiple equipment or multiple resistors in series, remember the ultimate resistance or the complete resistance, it is nothing but the sum of all the resistances. If resistors are connected in series, the final resistance or total resistance is equal to R1 plus R2 plus R3. But if they are connected in parallel, then their resistances equation, the total resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 by total resistance. Now, why does this happen? Please try to understand that whenever I connect things in series, you will see that they will have same current passing through all the three. They will have same amount of current which is passing through all the three. Correct? But whenever you have something in parallel, you see that the current, it divides. Now, depending on these resistances, I told you more current will flow where? More amount of current will flow where the resistance is least. High amount of or less amount of current will flow where resistance is higher. That's why across these three, the current will be different. But in all these three, current will be same. Current passing would be same. That's why we get these equations. Now, why did I discuss this? Because see, in many of our household equipments, you will see that we seldom connect things in series. Right? It doesn't mean we do not connect in series, but many a times we connect things parallelly to our electric lines. Why does this happen? Because see, you have connected your fridge to a parallel line, you have connected your AC to a parallel line, your lights to a parallel line. Why? Because if same amount of current flows through all the equipment, some equipment work on milliamperes, some equipment microamperes, some work on multiple amperes. So if the rated current goes high, then the equipment will burn off. Clear? That's why we see that series connections are specific. In general, in your house also, you will see more and more of parallel circuits or parallel connection, because we want individual amount of current to reach according to its rating. Clear? Right. Now, apart from this, we also have a concept of electric power. You have a doubt, sir, how do I get my electricity bill? Is it based on the amount of current, or is it based on the voltage that I receive? You do understand voltage that we receive at our house is somewhere around 220 volts, 220 to 30 volt. And I told you it moves from high voltage to low voltage, of course. And that is why, if you understand how does electricity pass, just a little bit of deviation from our discussion, you do understand how electricity comes. Electricity, first of all, is generated. Now, where do you generate it? Electricity is generated at the generating station. It may be a hydroelectric power station, it may be a nuclear power station, it may be a coal-based power station, whatever station it is, electricity is generated. And do you know how, at what voltage electricity is generated? Generally, it is somewhere around 11 kilovolts. Electricity is generated at 11 kilovolts. That's the potential. So from here, it is going to reach to your home. And your home, what at how much voltage does it reach? We have a rated voltage of somewhere around 220 volts, 220 to 230 volts as per requirement. That's a single phase. For a double phase, it would be 440 volts. Especially for industries or for heavy equipment, we use 440 volts because they need more current, right? Now, you need to understand something happens in between. Now, this middle part, it is called as transmission. This is called a transmission. So you need to understand, from generating station to the transmission station, it ultimately reaches. Now, when you talk about transmission, please remember, transmission losses would appear because we understood concept of resistance. Now, because of this resistance, there would be many losses. There would be many power losses. Now, how do you define this power? Now, power is basically voltage into the current. Now, if I use Ohm's law to this, I get power is equal to I square R. Because voltage is something which I would keep it fixed, but I can control the amount of power that is moving through the transmission line, because current, and current ultimately depends on power. What I mean is, voltage, I generate power at say 11 kilovolts. 11 kilovolts is there. Now I have to transmit from one place to another place. I have to reduce the transmission power losses. Now, transmission power losses, they depend on current and resistance. All right, because the voltage at which I'm generating, I have kept it as 11 kilovolts. So what do? I try to ensure that less amount of current passes through it. If less amount of current passes through it, then I ensure that the power losses would be minimum. That's why what these substations do, what the transmission stations do, is when it is generated, they will step up the voltage. They will use step up transformers. And this particular 11 kilovolt, it's stepped up further so that the losses are less. And here, after it reaches the substation where it is being supplied, then it would be stepped down. It would be stepped down transformers. Transformers are one which reduce that voltage. It would be stepped down, and ultimately at your home, 220 kilovolt would be provided. All right. Why? To reduce the power losses, of course. Power depends on I square R. This is called power factor also, I square R. Now, you still have a question. Sir, power, how do I get a bill? Does it depend on voltage or current? No, it depends on how much power you use. And how much power? See, the unit of power would be watt, because it depends on voltage and ampere. So 1 watt is equal to 1 volt ampere. But many a times for our power consumption, what the stations that they do is they use another unit or another factor for power, that is kilowatt hour. Meaning how much electricity or how much electric charge you are using per time. That way power is calculated. For example, 1 kilowatt hour, it leads to 1 unit at your home. You have a meter earlier that used to revolve. Right now they have digital meters. That means once you consume 1 kilowatt hour, your reading would go +1. And in Karnataka right now, 1 unit is costing 7 rupees. So for 1 kilowatt hour usage, you will pay 7 rupees to the JESCOMs or to the whatever distribution companies they are supplying power to you or electricity, right? So 1 kilowatt hour basically means, in simple plain language, you switch on 100 watt bulbs that you have at your home and you run them for 1 hour, 60 minutes. Then you will consume 1 kilowatt hour. That means 1 unit would be passed. So this is your electricity bill or electricity unit that we talk about at our home. All right. But in general, power is equal to V into I. Power is also equal to I square R factor. Power depends on the amount of current that is passed, amount of current, square of the current, and the resistance. You do understand, I cannot change or play around with this. Correct? I cannot play around with resistance because I use only one kind of wire. You have aluminum wires for transmission. I cannot change that material. So what do I play around with? I play around with the amount of current that passes through it. So I reduce the amount of current by stepping up the voltage. So during transmission, the losses are less. But I again step it down so that more and more amount of current, whatever is required, it reaches your home. Okay, right. Now apart from this, the electric current, it also has heating effect. Now this we have discussed before also. You must have observed this as well, right? You must have seen. You have an incandescent bulb at your home or any kind of bulb at your home. Electric current passes through it. It is going to give you light. Now when I switch this on, it is off right now. I switch on the circuit. I switch on the mains circuit. Now this is giving me light. Yes. But along with light, it is also giving me heat. Correct? It also gives me heat. So electric current, when it passes through a conductor, it has heating effect. And how much heat, it depends on the power factor, that is I square R again. Meaning how much heat is to be generated, that depends on the amount of current and the material that I use. Now using this phenomena, we see because of this heating effect of current, we have created so many things, so many articles. Now for example, for my light, a light is there. For my light, I do not want heat to be generated more and more. I want light. I do not want heat. So what do I use? I use very low resistance materials. But imagine I want electric current to give me heat. Why? Maybe I want to create something. So our day-to-day activities, we use fuse. Now I create a fuse through which there is a very small thin wire, and if it gets heated up, it will melt off. It will cut down the circuit itself. There are many appliances like the electric heater where I create some sort of material which has very high resistance, and when I pass electric current through it, it heats up. You must have seen your room heater, you must have seen your electric iron, etc. I use heating effect of current and I use that as an appliance. And this heating effect, again, it depends on what, as I told you, P is equal to V into I, which also makes it I square R. This is called as power factor. Now, the energy supplied to circuit, this amount of power into time, that will give you whatever heat losses are coming. So heat basically is V into I into the amount of time. So heat that is generated from any equipment, it is equal to I square R into the amount of time through which the current is being sent. So if I want heating effect, what do I want? I want more resistance, I want more current, and I want to send it through more time. So what do I get? I get more and more amount of heat. That's why go home and check your appliances today. Check your appliances, your electric heater, your electric room, your electric iron, how much current it takes. It'll take higher amount of current. Higher amount of power is needed. Your electricity bill would also be very high, right? I hope I have given you a good insight into this. Do not go into the numerical part. Again, do not mug up the formulas as well. These formulas are also not needed for us, but we need a general idea about how exactly electric current passes, or what is this concept of electricity. All right. Chapter 13, magnetic effects of electric current. As I told you in our previous discussion, we understood the concept of electricity. Now we understood what is electric current. Electric current is because of some sort of difference. We understood it through the analogy of water current, air current. I told you air moves from one place, air as wind moves from one place to another place because of pressure gradient, because of pressure difference. Water because of some gradient, maybe because of gravity, maybe because of some characteristics of water. Similarly, electric current, when it moves, it needs some sort of difference, potential difference. The electric potential difference is needed. So we understood Ohm's law, we understood what is the meaning of resistance, what is resistivity, what does resistance depend upon. And finally, we also discussed about the heating effects of electric current. Now you must be thinking, sir, in the previous discussion, you spoke about heating effects of electric current. That was very fine. We saw some of the practical applications as well in our day-to-day lives. But why there is a separate chapter that has been dedicated for magnetic effects of electric current? Because this has more and more applications in our day-to-day lives. Right now, I'm quite sure you are watching this video, and is your fan switched on? Yes. Today morning, did you switch on your water pump, the electric motor which helps to put the water basically from your borewell to the overhead tank? Did you switch on that electric pump, that motor? All those ideas, all those concepts, the fan, that, or any other thing, or any other, your mixer grinder, so many appliances that we have, they work on these concepts. So that is what we are going to understand in this chapter. All right. Now, we have gained some knowledge before as well of magnetic field. Now, magnetic field, it was basically discovered by a scientist named Hans Christian Ørsted. He accidentally discovered it. He accidentally discovered that electric current, it leads to some magnetic effects, some influence on the magnetic field. What he saw was a wire in which the electric current was passing. It had an impact on the compass, and compass basically points towards north and south. That is the magnetic field, or the magnetic north and magnetic south of the earth. But as soon as the wire, it had an electric current pass through it, it impacted the compass, and because of that, accidentally he discovered that electric current also has some magnetic effects. And that's why the entire idea of magnetic field or magnetic field strength, it is named after Ørsted. The unit of magnetic field strength, it is named after this particular scientist. Now, in our previous interactions, when we discussed about the chapters from class 6, 7, 8, 9, we have understood some ideas about magnet and magnetism, right? We have discussed what are bar magnets, right? What are magnetic field lines as well. We discussed about lodestones. We discussed about different magnetic materials, right? The paramagnetic materials, the diamagnetic materials, etc. Right? And we saw that for a bar magnet, it will always point towards north and south. We have seen that. And the magnetic field lines, they emerge from the north side or the north pole, and they fall into the south pole. This we have discussed before. All right, means the magnetic field has a particular direction. It has some quantity, it has some magnitude, it also has some direction. Correct? We have discussed this. Meaning, those magnetic lines which are able to reach from north to south, this is done. But the field, it spreads as well. The more the strength of this magnet, the more is the magnetic field around it, and more magnetic field lines around it. And we have also discussed that every magnetic field line, it would always go in only one direction. You know this idea, right? That means it starts from north and it moves towards the south. There would be no magnetic line which would see an opposite end, which would see an opposite side of that. Right? That is established point for us. Now, why am I discussing this? Because this background is needed for us to understand how electric current, it generates magnetic field, or how it impacts, how it has some magnetic effects on other things. Now, let's talk about first thing, how a magnetic field is generated due to a current carrying conductor. Imagine there is a wire, there's a copper wire is a conductor, and it carries electric current through it. Now, what kind of magnetic field it generates? I told you this was accidentally discovered by Ørsted. Now, what kind of magnetic field it generates? Now, if it is a simple wire, then that wire will generate a circular magnetic field like this. You can simply run an experiment as well. If you run an experiment, a copper wire through which electric current is passed, you will see the magnetic material, it would align something like this according to the magnetic field. Right? Now, this magnetic field and its direction can be decided or can be gauged through a rule. It is called as the thumb rule, the right hand thumb rule, basically the right hand thumb rule, meaning in whichever direction the current is flowing, hold your thumb towards that direction and rotate your fist. That would give you the direction of the magnetic field that is generated. If the current is in the upward direction, then the magnetic field would be something like this. And if the current is in the downward direction, then the magnetic field direction would be like this. If the current is in this direction, then the field is in the other direction. It is based on your fist, right? All right. Now you must be confused, sir. Will such question come in UPSC examination? Probably not, but we will go we'll go eventually to the topic which we want to understand, and for that we need to have this knowledge. So right hand thumb rule, it basically gives you the electric field direction for a current carrying conductor. All right. Now imagine I create a loop of this particular wire. Now what would be the magnetic field because of a circular loop? Because of circular loop, simply use the common sense. There was a straight conductor before. What I have done is I have turned this conductor like this. I have created a loop, and if the electric current was passing in this direction, if I have created a loop, you do understand now that the direction of current is also reversed. So what would happen? What would happen if I use the right hand thumb rule? If the current direction is towards, say, north, upwards, then this would be the direction of your magnetic field. But when you come here, the direction of magnetic field is now reversed. So what you will find is you will find loops of magnetic fields along with magnetic field line in directions like this. All right, this is for a current passing through a circular loop. All right. Now what do? I create more and more loops. I create more and more loops. I take a wire, I create more loops like this, and then I pass electric current through it. A conductor which has been wound, many loops have been created, and I pass electric current through it. Now this is called a solenoid. A solenoid. Solenoid is a conductor which has been formed into multiple loop shape, and I have given it, I'm passing electric current through it. Now this solenoid, it technically acts like a magnet itself. How? If I put a metal bar inside like this, let me draw that with a different color. Imagine I use a metal bar. Let me take black color, and I put a metal bar in this. One second. Right. If I take a metal bar and put here, what would happen? That metal bar would be magnetized. Imagine if that is an iron bar, that would be magnetized. This is the concept of developing electromagnetism, meaning I create, if I have a metallic structure, if I have a simple nail, I take a nail on which I wound a copper wire and I pass electric current through it. That nail itself, it is going to become a magnet, and that magnet will have a north pole and south pole. Why? Because a circular looped wire like this, it is going to have an electric field, a magnetic field very similar to a bar magnet, having a north pole and a south pole. Now you're thinking, you're scratching your head, sir, what are you talking about? You're simply telling me some sort of direction, or some rules, right hand thumb rule, left hand thumb rule. What is this? I'll just recap it once again. See, I told you if there is a current carrying wire, it generates a magnetic field, circular magnetic field. Then I simply created a loop out of it. Then I told you if I create multiple loops like this, and if I put a bar in it, then it is going to act as electromagnet itself. All right. So a solenoid will lead to creation of a field which is uniform, and I can also create a strong field if I have more and more windings or more and more coils. Now the question is, sir, why did we discuss so many things? Why did we discuss so many things? Because I want to understand something. I want to understand that when I pass electric current through a conductor, through a wire, it generates some sort of magnetic field. And if I have another magnet which generates its own magnetic field, how would it impact the object that is carrying current? I want to understand that. Now what happens is, if I have a magnet, this is a natural horseshoe magnet with a north pole and a south pole, and over it, what I have done, I have used a conductor, and through this conductor I am passing electric current. Now when I pass electric current, this conductor is going to generate its own magnetic field, correct? Now this bar magnet has its own magnetic field, they will interact, and because of this there is movement in this bar. This is what I want to understand, because it has a lot of practical application. Now, this is going to move, meaning if I move electric current, or if I pass electric current in one direction, this bar is going to move to one side. If I reverse the current, it is going to move to the other side. I can see the same result if I move this horseshoe magnet as well. Means I understand that some sort of force is applied when I use a conductor through which electric current is passed, which is already in another magnetic field. Now, what kind of force and how do I gauge that force? Now, that can be understood by the left hand thumb rule, Fleming's left hand thumb rule. Now, Fleming's left hand thumb rule will tell you that if there is a magnet, if there is already a magnet, this is a north pole, south pole, that means the magnetic field or the magnetic field or lines of force are in this direction, and you are using a conductor. You are using a conductor in which the direction of current is something like this. Then the motion or the force, the motion of the conductor or the force on that conductor would be in the upward direction. Now that is the left hand, Fleming's left hand rule, right? Meaning you use, this is the magnetic field line, this is the current line, this is the magnetic field line, current line, then the motion towards this side. Now, why I am understanding so many things, why I am going through so much of technical stuff? Because I have to bring some day-to-day application of this. Based on these concepts, based on these ideas itself, I have created your electric motor, I have created your electric generator. Believe me, we are going to discuss this electric generator in our next class also, which is a discussion about environment, or I would say topic connected to environment, topic connected to energy. So we have created electric motors, electric generators, loudspeakers, etc. Now there is a small question also here. Now this asks you, if an electron enters a magnetic field at right angles, the direction of force acting on the electron will be. Now if you use your Fleming's left hand rule, let's try to get the answer to this. This is the line of the force, this is the direction of the current, okay, and this would be the motion. Now I already have the magnetic field line, this is the magnetic field line. Now you think, is this the movement of the current? No, this is not the current direction. If the electron is moving in this direction, then the current would be in the opposite direction. So this is the field, this is the current, that means the force is acting inwards. All right, so that's how you get your answer. This is basically into the page, the force is into the page. Now why we are going through this so many technicalities? Because I want to build something like this, say electric motor. Now I want to understand that if I take a magnet and if I place a coil like this and connect it to some sort of an axle, because now I want this axle to rotate. Now what do? I pass electric current. I pass electric current through this circuit. In this direction there is one kind of electric field, and in this direction there is another direction electric field, but this is constant. This electric, I am using the term electric field, pardon me, magnetic field. So this is going to create one magnetic field, this is going to create another magnetic field, these will interact and this will ultimately rotate, and once that rotates, my axle will also rotate. All right, or I can use different kind of split rings and brushes, because of which I can basically translate this into the movement of the axle itself, and that is nothing but your electric motor. I told you, if your fan is on, if your mixer grinder is running, if your pump is running, when I say pump, I am not talking about the pump which is taking water, but the shaft connected to it, it is nothing but your electric motor. And commercial motors, they do not use magnet. Now you think, sir, do all these motors have magnets, natural magnets? No, they create electromagnets, or they use electromagnets only. See, the electromagnet is used in place of permanent magnet, and for this core, this also has to have some sort of winding. So this electric motor, first of all, this will act as electromagnet, it will have winding, this will also have some sort of winding, and once I pass the electric current through this, because of the interaction of magnetic field, this axle continuously rotates, something like this. And if I connect this shaft to the pump, I can use it as a water pump. if I connect this shaft, say, to fan blades, if I connect this to the fan blades, then it will become your fan. If I connect this to your grinder connection, simply the grinder connection, that connection would be with the grinding jar. It will help you grind. So we have so many applications of electric motor everywhere. And it works basically on the principle of magnetic effects of electric current only. Now you must be thinking, sir, what happens if one of this wire breaks, or many a times you must have seen the fan won't work and the electrician would come and he'll tell you, sir, the winding is gone. Yes, the winding is gone because you can see it is insulated. It is insulated. It acts as a coil. That's why I told you. That's why I told you the concept of solenoid was such that you have winding over this. Now this becomes electromagnet. This becomes electromagnet. There is no need to send the current directly into the metal or into the conductor at all. So this basically acts as a coil which magnetizes this, and another coil which magnetizes this, because of which it rotates. Clear? Right. So this is one of the applications. Another application, we use loudspeakers, right? Loudspeaker also has the same concept, and loudspeaker, they literally use the magnet itself. Have you seen it? Have you seen it? If it is a very huge kind of a speaker, they might use electromagnets, but many speakers, they have natural magnet itself. Now we used to do this when we were kids. If some speaker has spoiled, then we used to take out the magnet out of it, because magnet, again, it's fun to play with, right? Have you done that? Because on that magnet you would have some kind of a cone, and you will see, because of the magnet and because of the coil on it, this magnet is going to generate a magnetic field. When I pass electric current through this coil, this is going to generate another magnetic field. Because of this interaction, ultimately the object is moving, and once the object moves, the diaphragm moves, it is going to create sound waves. That's how loudspeaker works. Same way your microphones work. Same way your microphone works. Say, very similar way your earphones also work. A very small such circuit is present there. All right. So I hope things are clear connected to magnetic effects of electric current. One thing that we understood, because of this magnetic effect, I can make an object move. Correct? We have understood this. Now, is the reverse phenomena possible? What we have studied till now is a current carrying conductor. When it is placed in a magnetic field, it can move. I have ensured that either it rotates, especially in electric motor, or I gave you another example of loudspeaker as well. It moves in this direction. Now the question is, there is a reverse possible. Now what is the reverse of this? The reverse of this is, if I have a conductor, which is, say, again, a current carrying conductor, if I am able to move it, can it generate electricity? Can it generate electric current? Is it possible? Meaning, one electromagnet which has some magnetic field, if I move it, can it lead to creation of electric current somewhere else? That is possible. It was discovered by Michael Faraday, and that is what we basically do when we talk about your generators. What is your generator? See, a motion which ultimately produces some sort of electric current or EMF. Meaning, there is a rotating shaft. And this shaft has some coil. Now, although this is a magnet, imagine this is a coil. Basically, electromagnet itself, which has its magnetic field. And when this is rotating, this magnetic field interacts with another coil, its magnetic field, and produces EMF. Is it possible? Of course, yes. That is how we generate our electricity. That is the same concept, in our electric generator itself. The electric generator, we'll talk about it. Now, for the electric generator, now the rules differ. We saw for the electric motor, we saw the left hand Fleming rule, and for generation, we use right hand Fleming's rule. Meaning, there is a magnetic field which is in this particular direction, and the movement of the conductor is in this direction. This is the field, this is the conductor movement. Then the EMF or the electric current is induced in this direction. That would be gauged through the right hand Fleming's rule. And using this right hand Fleming rule, using this concept itself, we create electric generators. Now, what is this generator? Now, this generator, first of all, it will have a magnet. So this has its own magnetic field. Now what I am telling you is, when I rotate this, then the coil that is moving here, it will generate some sort of EMF or electric current, which I can measure using the ammeter. That is what we do in electric generators. Have you seen the movie Swades? Yes. Yes, you've seen the movies Swades. What Shah Rukh Khan does is, he has created a small reservoir in that village. Water is collected in it. He opens the valve. As soon as he opens the valve, then the water hits the turbine. Turbine has turbine blades. Now, that turbine is something which is rotating. Now, that rotating turbine shaft which is there, this is connected to coil 1. This is connected to coil 1. And as soon as it reaches a particular speed, this becomes electromagnet 1. There is another coil. In general, in a generator, what do we have? There is a structure called as stator. This is called as stator. The stator has separate coils on it, and this basically becomes your rotor, because this is rotating. Now this rotor is going to generate current into your stator circuit, and this stator circuit, you would send it to the substation, where you can pass the electricity forward. That's the basic idea of generation, electricity generation, where you use this motion, and that motion can be induced by anything. That motion can be induced by water. It becomes a hydroelectric generator. That motion can be induced by steam. Normally we use steam on the turbine. The turbine rotates, and then that means the rotor is rotating. The rotor coil is active now. The rotor coil will generate the current in the stator coil, that would be used, or that would be transmitted forward. That's the basic idea of electric generators. Please remember this, because we will be talking about this in our subsequent discussion as well. Now, apart from this, one last topic which is there is our domestic electric circuits. Now, in our domestic electric circuits, you must have seen how electricity reaches us. It reaches at particular voltage. At home, we have a 220 volt setup with a potential difference of 220. Then we have a circuitry something like this, where you have a live wire through which the current passes. You have a neutral wire. You also have a fuse, because if the voltage becomes high, then if the voltage is high, then the current would also be extremely high, and when this current passes through it, the fuse will burn off because of the heating effect. There is also an earth wire which is used. The third wire, the earth wire, is used. This is used so that earthing happens, you do not get that electric shock. And generally, I told you, we connect from our main distribution board. We use parallel connection to different equipments. Generally, at our house, we do have, again, whenever we need a more current, say there are many equipments which need 15 ampere current. There are some equipments which need 5 ampere current. There are some which needs less current than this as well. So we create different kinds of parallel circuits so that requisite current can reach there. All right. Generally, the normal bulbs that we have, bulbs, fans, or whatever low load or low wattage equipments that we use, they use 5 ampere current. And what if we have an AC or a cooler, or your pump, your electric motor, which is about 1 HP or say 2 HP, that requires higher wattage. That means that those require about 15 amperes power. So we give separate parallel connections to those. That's the basic domestic circuit that we have. All right. So I hope things are clear for you from the examination perspective. What is the domestic circuit? What are the magnetic effects of electric current? Clear? Right. We use different sources of energy. For all of us, the ultimate source of energy is sun. Now, from sun itself, we use many other sources of energy that we have here. The ultimate source is that here we may use, say, fossil fuels. Somebody may use firewood. These days we have LPG at our home. I use petrol in my vehicle. I use diesel in my car. So I have different kinds of fuels that I use as a source of energy. Now, when we talk about energy, there are some parameters which makes a good source of energy. And how do we assess that? any source of energy, if it releases good amount of heat when it is burnt, it becomes a good source. It should give heat because that is my ultimate requirement. I need heat, say for cooking. I need heat for my IC engine, internal combustion engine, to run. I need heat so that I transform water into steam. I use that steam for generating electricity. So it needs to produce heat. How much smoke does it produce? Now I want it to produce less amount of smoke because I don't want that source of energy to ultimately lead to pollution. Apart from that, how easily is it available? Meaning, if I have a source of energy, say deep inside the oceans, now extracting that itself becomes a huge problem. Will it be financially viable for me? It may not be. So it should be easily available. That is why people during the ancient and medieval times, they use firewood a lot because it was very easily available. Simply dry it and you can use it for your heating requirements. But slowly and steadily, we came into the modern era. We started using coal. We started extracting petroleum. We use natural gas now. Today, in 21st century, we talk about the concept of climate change, global warming, and we want pollution to go down. We want greenhouse gases to go down. For that, we are looking towards more cleaner and greener fuels. That means more cleaner and greener sources of energy. So what would make a good source of energy? If first of all, that source of energy should be sustainable, meaning I can use it for a long time. It must be renewable source of energy. It should be clean source of energy. It should have high calorific value, meaning if I simply burn 1 kg of that fuel, that source of energy, it should give me proper amount of heat, whatever is needed. It should be easily accessible. It should be easily accessible. Extracting that should be quite easy. And it should not cause pollution. This is one of the important parameters. Apart from that, we also talk about ease of transportation, right? It being economical, all these aspects also make a good source of energy. Now, in general, whenever we talk about energy, we divide energy into two broad categories: conventional sources and non-conventional sources. Now, by the term itself, conventional, meaning which we have been using from a very long time. Say, for instance, we have fossil fuels. We use fossil fuels almost from 200, 300 years. From the time we understood or we discovered the utility of coal, we have been using it. Now, before that, firewood is another natural source, again a conventional source I can call, which leads to a lot of pollution, yes. But from modern times, we use fossil fuel based energy sources. Predominantly, I have coal. Later on, I also discovered petroleum. Now, by fractional distillation of petroleum, I created gasoline, that is petrol. I created diesel. I created other fuels, kerosene, etc. Right now, in recent times, we are talking about natural gas. This is also fossil fuel. All right, fossil fuel means a source of energy which takes a very long time to replenish itself. So conventional sources, I can also call them in an analogous way as non-renewable forms of energy, meaning it takes a very long time, it takes centuries together for them to be replenished. On the other hand, we also categorize broadly as non-conventional sources. Now, non-conventional sources are the ones which I would say largely they are renewable. They are more cleaner, they are more greener as well. Examples being solar energy, wind energy, tidal energy, geothermal energy. These days, many people talk about nuclear energy also as non-conventional source, but nuclear energy has its own threats, has its own issues. We can give example of Chernobyl, we can talk about Fukushima, etc., because it may lead to some sort of radiation based threats. All right. So this is how we categorize. Now let's look at how we use these fuels, to produce electricity, because our main discussion is to understand different kinds of power plants. Now today we talk about power plants which are based on fossil fuel, predominantly on coal. We talk about power plants which are based on diesel. We have power plants which are based on water. Those are hydroelectric power plants. These days, we talk about solar power plants. We talk about nuclear power plants. We talk about wind turbines, wind-based power plants. So we'll talk about these one by one. First, we understood the conventional source of energy, predominantly fossil fuel-based, coal, petroleum, natural gas. Now this power plant can be natural gas based also, right? Now, what would be the working of a simple thermal power plant? Here, when I say thermal power plant, I would say this, or I would write it as fossil fuel based power plant, meaning I will be burning fossil fuel. Once I burn fossil fuel, I will be heating one equipment. And what is that? I would be heating water. Now, once I heat water, I would turn this water into steam. And this steam is now focused through a nozzle or propelled onto this turbine. Now, this turbine rotates. I give you an example of Swadeshi. I hope you remember from the last class. I told you, what does Shah Rukh Khan do? Shah Rukh Khan has created a reservoir. He opens the valve, the water moves. Now, instead of water, think a very high speed jet of steam is coming and it is rotating this turbine. And I told you, how does electric generator work? This turbine moves. Once this turbine rotates, this is the rotor. So in this generator, there is a rotor coil. Let me just change the color. There is a rotor coil. Oh, okay. Black color. There is a rotor coil and then there is a stator coil. Now, once the rotor coil rotates, the rotor coil, because of its magnetic effects, it is going to induce current in the stator coil. And that stator coil's current, it can be passed through a transformer, step up transformer, step down transformer, whatever it may be, sent to the transmission line. Generally, when we use transformer here nearby the generating station, those are step up transformers. And I told you why. Because step up transformers, they increase the voltage manifold. When I transport energy or when I transport electricity in high tension lines or high voltage lines, power loss would be reduced. All right? That means high voltage, low current electricity is passed here. Once it reaches my place, my substation, then I use step down transformer. The voltage is reduced, proper current can be supplied to me. Now, this is how the thermal power plants work. Now, this particular fuel, it can be coal, it can be, I would say, diesel, it can be natural gas based power plant. These are fossil fuel based, conventional ones. Now, among this conventional itself, these days we have made improvement in the conventional sources of energy. One of the examples being that we are generating biogas. Now, biogas is generated from what? Biogas is generated from biodegradable waste. Biodegradable waste. For example, biodegradable waste, the waste vegetables, the waste organic material, the waste food articles, right? What happens to it? We use these waste material, we put them in a digester. And there it undergoes anaerobic decomposition, and ultimately this biogas forms, and we use this gas outlet, and you can use this as fuel. Mostly it comes as methane. Basically, methane gas is seen here. So methane can be used here. Now, when I use this methane in a power plant, now imagine I take this, I use this particular gas, I burn this gas, I boil the water, I get steam. Using that steam, I run the turbine, I run the generator again through the transmission line. Now, this becomes a biogas based power plant. All right. So, majority of our power as of now, it comes from the conventional energy sources only. In India, more than 50% of electricity that is generated, it comes from coal based power plants even till today. If you want to get the latest numbers, you can always go to the website of MNRE, Ministry of New and Renewable Energy website. There you will get all the details about the latest renewable projects and what is the energy mix of a country as of today itself. All right. So whenever you have your exam, just before the exam, do visit the website so that you get some accurate numbers which you can mention in your mains answer writing as well. All right. So this is about the conventional sources. We also have non-conventional sources. Now, many experts put hydroelectric power in conventional itself, but I would say again it is largely renewable source of energy. But let's try to understand how it works. Now, this is the classic example which I gave from a movie, from Swadeshi. Now, what Shah Rukh Khan does, he has created a small reservoir. And from this reservoir, the water will enter through a penstock. This is called a penstock. From that, the water will enter. The water at high pressure very similar to how a nozzle effect works. That high speed water, it comes and it runs the turbine. The turbine, it rotates. Now once the turbine rotates, that rotation is used. That rotor acts as a primary coil. The secondary coil is nothing but the stator. Electricity is generated. Again, that electricity is transmitted through the transmission lines. That's the basic idea. Now everywhere you are looking at the same thing. Now you are thinking, sir, why can't I create only hydroelectric power plants everywhere? Is it not possible? Yes, it is possible. But again, for hydroelectric power plant, you need availability of water for 365 days. You do understand how electricity reaches your place, right? If you have a misconception that electricity is stored somewhere and then it comes to you, that is wrong, because it would become physically impossible. Imagine that I have to provide electricity to crores of people. Where will you store it? We do not have that battery technology. So that's why what the generating companies do. Yeah, let me just give you some idea about that. The generating companies, they have the data of the demand. They do know that yearly the demand fluctuates. For instance, during the summer season, the electricity demand goes very high because of the cooling needs. So generating companies, what they do, they have a schedule. They have a schedule of running their generators. Once the electricity is generated continuously, it would be transmitted through the transmission based company, through the transmission lines, and then ultimately these are the discoms at your place, the distribution companies, they supply to your home. It's not like it is stored somewhere in a battery and then it comes to you. No, meaning these generating companies, they have to run at a very tight schedule according to demand, and that demand, they do have an estimation of that. Sometimes when the demand fluctuates, when it is extremely high, you see a lot of load shedding. Now you don't normally see load shedding at your place during the summer season. Why? Non-availability of water wherever it is coming from the hydroelectric power plants. Clear? Right. Let's talk about some other ideas. Solar power plant. Now this is again a non-conventional way of generating electricity. These days solar power plant has gained a lot of traction because the government is running national solar mission, which has very stiff and ambitious targets. Slowly and steadily we are reaching towards it, although the 2022 target of 100 gigawatt has not been achieved. We have fallen short approximately by 20%, 20 to 25% there. Still, it's a good achievement that we are creating, or we are going for more and more solar projects. Now, how does a solar power plant work? Now, solar power plant, we create an array or a grid of solar photovoltaic cells. These are photovoltaic cells. These are photovoltaic cells. Now, once sunlight falls on these photovoltaic cells, they convert this solar energy into electricity, which I can use through this inverter technology, and I can connect it with grid. And this is the biggest problem that we face right now. And for this, Germany is helping India how to connect it with main grid. How to connect that with main grid, because you do know, if I'm using a conventional source of energy, coal based power plant, it will run at optimum load. But what happens with this solar light is, during the daytime it is actively working, and it is producing that electricity. It is producing electricity because of the working of photovoltaic cell, and that I can connect to grid. And in many solar based power plants, you might also find some sort of battery banks, probably to use them when the sunlight is not available, or provide energy when electricity when sunlight is not available. All right, so we have connected many of the solar plants with our main grid right now. All right, so this is the solar power plant. Apart from that, we also have wind based power plants or wind energy. Now wind energy means I use the concept of air moving from one place to another place. Wind. All right, so air moves from a point of high pressure to low pressure. I use that movement to propel this wind turbine, and this wind turbine has huge blades. They are aerodynamically designed such that this wind will make these blades rotate. This fan would be rotating. You must have seen it at many places while traveling, etc., of great heights. These wind turbines are of great height, and you must be feeling, sir, I have seen that these wind turbine, these fans, they rotate at a very slow speed. Then how does it generate electricity? Now please remember, they have different kind of gearing systems, because of which this low speed of these fans is now transformed into high speed rotor. And again, the same concept of generator works, and the generator generates electricity, and that is connected to your electric line through the transformers. Same idea. Apart from this, we are also using some other non-conventional energy sources like geothermal energy. Now, geothermal energy, you do know that if we go deep inside the earth, you will see that the temperature, as we go towards the center of earth, it continuously increases. That means below we have more temperature, higher temperature, and this high temperature, we use that temperature to capture or to get that hot water. Geothermal energy means hot water coming from underneath, coming from beneath. We use it so that we reduce our input cost here, and here we convert that to steam by maybe putting in some other kind of energy, maybe fossil fuel based energy, etc. But right now this is relatively hotter. I would need lesser amount of energy to transform it into steam. Then I use the steam to run the turbine, generate electricity, then use it with the grids. There are many geothermal power plants which are in the testing phase. There is a geothermal power plant in Ladakh. So keep a track of these. Wherever new geothermal plants are coming, keep a track of those things. All right. Now, apart from this, we also use tidal power plant. Now, this is again a renewable source of energy, a non-conventional source of energy. Because of the gravity of earth, and because of gravity of moon, and the gravitational power of sun, we get different kinds of tides. Now, whenever there is a low tide, the water recedes, and whenever there is a high tide, the water level rises. Now, we use this particular concept and create some sort of a barrage. This is the ocean level. This is the barrage level. Whenever there is a low tide, we see that the level of water in this barrage is lower. So we cannot generate electricity at that time. But whenever there is high tide, the water level is this. And at this point, what we do is we open the sluice gate, or we open the barrage. And once this opens, the turbine rotates. The rotor rotates, and this rotor, it is connected above to the generator, which generates the electricity. So these kind of experimental tidal power plants are also quite active, especially along many coastal locations. Keep a track of these as well from your current affairs preparation. All right. So different sources of energy, conventional, non-conventional. We discussed many ideas. The last idea here is the nuclear power plant. Nuclear power plant, instead of using a fossil fuel, nuclear power plant, it uses nuclear fuel. Now, nuclear fuel, as of now, what we use uranium-235. Now, uranium-235 or uranium oxide, it is enriched according to the nuclear power plant level, and it is used as a core. And this uranium is bombarded with high energy neutrons. What will happen? Uranium nucleus will break, and once this nucleus breaks, it gives you huge amount of energy, leading to formation of other fragments, other elements. Along with it, energy is released. Other neutrons are also released, and these neutrons can sustain nuclear fission reaction. Please remember, whatever nuclear power plants we have, they are all fission reactors. Fusion technology is not yet active anywhere in the world. It is only experimental. There are many experiments which are running in China, in UK, even in India. We have Aditya Tokamak in Ahmedabad, in Gujarat. Testing is going on, but nuclear fusion based reactors are not operational anywhere at the commercial level. Please note this. Everywhere in the world, there is only nuclear fission technology. Because of this nuclear fission, we extract heat out of this. Using this heat, we transform water into steam. I use this steam to run the turbine. This turbine rotor, it generates the electricity, and the same can be connected with the grid. That's the basic idea of nuclear power plant. All right. The source here, the only source of heat is changing. If I use coal here, that becomes a coal-based power plant. If I use diesel, it becomes a diesel-based power plant. If I use nuclear energy here to transform water into steam and then to run the turbine, it becomes nuclear power plant. We have many nuclear power plants. More than 20 nuclear power plants are active in India. The latest ones that are active in Kudanakulam in Tamil Nadu. Different nuclear power projects are already active, which are in collaboration with Russia. There are many power plants which are in building stage right now. There are some coming up in Maharashtra. There is one coming in Gujarat. So keep a track of all these from your current affairs as well. And whenever those power plants are active, make a note of that. All right. Right. Let's talk about today's topic, our environment. Now, whenever we talk about environment, in general, we use this term very often, right? I remember very recently, my father was telling, we were discussing about the rain. It was raining incessantly for almost 10-15 days. It has stopped now. See, in the last 2-3 days, the rainfall has receded. But he was telling, this rainfall is nothing. He was telling that the environment has changed a lot. In 1970s, 1980s, it used to rain a lot, more and more. Now, this rainfall is nothing. Right? Why I told this story is because we use this term environment in our day-to-day parlance. What is the meaning of this? Environment from our perspective. What is the meaning? Environment means our surroundings. Our surroundings. Surroundings, what basically comprises of, I would say, mostly non-living things. Right? The rainfall, the soil, the trees, the forest, the mountains, etc. Right? That's why we say environmental science. Environmental science, study of environment, study of Earth's atmosphere, right? Study of Earth's waters, Earth's soil, etc. All right. But when we talk about living things, we take a single fundamental unit called as ecosystem. In ecology, we use the term ecosystem. Ecosystem is the unit where we study how living organisms we interact with our environment, our surroundings. So whenever we talk about environment, environmental studies, one of the first terms that we need to understand is ecosystem. Now, ecosystem is a community of living organisms and how those living organisms, they interact with their environment, with their surroundings. That is the meaning of ecosystem. So when we talk about ecosystem as a whole, it consists of environment plus the living things in it. So it comprises of two things. One is living factors, biotic factors, and the abiotic factors, both, and how they interact with one another. That's the basic idea of ecosystem. When we say ecosystem study or ecological studies, we discuss this itself. All right, I hope it's clear. And when I say environment, ecosystem, many a times these words are used synonymously, right, in our discussion, etc. So I hope the distinction is clear. So an ecosystem basically is the unit under ecology that we study, which consists of biotic things and abiotic things. Now this is a classic kind of ecosystem. You see, there is this mountain or this hill. This is abiotic. It is not living. There is water, again abiotic thing. There is soil, there is abiotic thing. But there are many biotic things or living things. There is greenery, there is grass, there are fishes, there are people, birds, animals, right? These are all living factors. So biotic factors can be producers, and these producers are green. What is the ultimate source of energy on earth? That is sunlight. Using this sunlight, producers, they produce food. This food is consumed by consumers. And ultimately, after death or after life ends, it has to be decomposed as well. So decomposers. Now these three are biotic factors. There are many other abiotic factors. Predominantly, we divide them into three. That is edaphic. Now edaphic factor means anything that is connected to your soil and soil characteristics. Those are called edaphic factors. Apart from that, there are topographic factors and climatic factors. Topographic factors like say this hill, this water. Climatic factor, the long-term weather pattern, that becomes your abiotic factor in ecosystem. Now why we discuss this? Because these biotic and abiotic factor, they continuously interact with one another and they provide us basic services for survival. Now what are those services? We'll talk about that in some time. But when we talk about this interaction between biotic and abiotic, how does it work? It works through the idea of food chain. In an ecosystem, one of the important services of that is nutrient recycling or energy recycling, and that happens through the idea of food chain. Now, if you take any kind of ecosystem, there would be a food chain that you find. Food chain is the smallest unit of energy transfer. Say, for example, in a grassland, what do you see? There is greenery, there is grass. Now, this grass, this is producer level. This is the first trophic level, producer level. Now, these producers, they use sunlight, they use carbon dioxide, they use nutrients from the soil. That is how. See, now the abiotic factors and the biotic factors are interacting. How? The biotic factor plant, it is taking abiotic thing which is light, it is taking abiotic things which does not have any life, it is taking nutrients from the soil, it is using water to produce energy, to capture some heat to produce energy, and that energy or glucose, it is used by these consumers. And these consumers, again, they were divided into primary consumers and secondary consumers, secondary and tertiary. Now, this is greenery, and this deer basically eats grass, and this deer is then eaten by other carnivores. So, food chain is basically a group of organisms that are consumed in a linear order so that the nutrient and the energy is transferred. So, each organism in a food chain is at a particular trophic level, and it is determined of how energy is transferred. Now, you do know that interacting with the abiotic factors, imagine this plant or greenery, it amounts to energy X. Then some amount of energy is transferred from this to this animal, later on from this animal to this organism. All right, that is the tiger. Now, this movement is studied through food chain. Now, when we connect multiple food chains, we get a food web. Now, food web is an interconnection of these food chains, which shows you how the energy is moving, or how producers are producing food, and how that food or how that energy is being moving into your food web. Please remember, food web is the interconnection or representation of different food chains in an ecological community. Food web is also called consumer resource system, and a food web consists of all the food chains that are present in one particular ecosystem. And please remember that one organism can be a part of multiple food chains as well. Please note this. Now, you must be thinking, sir, you have explained environment, okay, you explained ecosystem, all right, and you spoke about food chain and food web, but I want to understand it further. Why we are talking about this? Now, we are talking about this to understand how energy is moving. I told you sun is the ultimate source of energy. That is, sun provides you some abiotic factors. It provides you heat and light. Now, using that heat and light, some energy is produced by producers. That is why producers are at the lowest trophic level. That means they are able to produce their own food by interacting with abiotic factors. Now, from here, slowly and steadily, the energy, it moves upward in this food chain or food web. So, a trophic level is a level that represents an organism or a level or an organism's level in food chain. Now, through this concept of food chain and food web, we create ecological pyramids. This is called as ecological pyramid, which basically shows you how the energy is moving, in what direction the energy is moving. Energy always moves in one direction. Clear? It's unidirection from producers towards the top level. That is defined through trophic level. Now, trophic level can be divided into different levels. First one is producers. At the base, there are producers. Next, there are consumers who consume the producers, and then there are consumers divided into primary, secondary, and tertiary. All right. Now, what is the significance of this? The significance of this trophic level is to understand that always energy from the sun. Now this would be constant because it would be running for billions of years. Till the time sun is there, till the time that star is available there, we will be getting heat and light, and that heat and light is going to be utilized along with whatever other abiotic factors that are available in earth, say soil, water. I'll be using it and I'll be producing some amount of energy. So first, producers, they use these abiotic factors, they use and produce some amount of energy, and this energy, it flows in our food chain and food web. Please remember that through the studies, through the food chain, food web studies, ecological studies, there is a 10% rule, or the Lindemann rule, which states that at every trophic level, there is a transfer of energy which is only 10% of energy which is available in the preceding trophic level. Meaning, if plants produce 100 units of energy, only 10 units of energy is transferred to the first trophic level, and 10% of this goes to next trophic level, and 10% of this goes to the last trophic level. What does this signify? This signifies that energy always moves in one direction. It always moves in upward direction. It does not return back, meaning the energy is never returned back to sun. Clear? Apart from that, maximum loss of energy, it occurs through heat loss in any ecosystem. Now through this we maintain the heat balance or the heat budget of the earth, because you do understand continuously if the sunlight is coming, then you do expect that earth would be more and more heated. But no, because of this food web, food chain, recycling of nutrients, recycling of energy or flow of energy, the energy is lost, maintaining the heat balance. All right. Now apart from this, when we talk about studies of food chain and food webs, we understand one more concept. Many a times when the producers and the consumers, when they interact with non-living things or the abiotic factors, some abiotic factors, they may enter food chain and food web, and slowly and steadily they might accumulate. Now this concept is called as biomagnification. Please remember there are two terms. One is biomagnification, one is bioaccumulation. There can be MCQ regarding the distinction between these. Biomagnification means how concentration of a toxin or a pollutant, it is increasing through trophic level. The increase is over time. Please remember, it does not happen in one day, because chemicals, we can give example of DDT. We can give example of DDT or any other toxins which continuously accumulate over time. Why? Because they are persistent. Once they enter into our body, we are not able to degrade them, we are not able to disintegrate them or excrete, so they slowly and steadily accumulate. And you do understand the energy flows in only one direction. So what happens is, during biomagnification, the toxins or the pollutants, they accumulate at one place, and since they move in one direction, since the energy moves in one direction, you will see the accumulation also moves in that direction. It is called as biomagnification. Slowly and steadily we see, since the energy is flowing in this direction, the toxins or the pollutants, they would be concentrated at different trophic levels at a higher level. So biomagnification means concentration of the toxin slowly and steadily increasing and reaching at the topmost level highest, right? That meaning the toxin slowly and steadily reaches higher towards this different trophics, towards the top. All right. Now there is one more term called as bioaccumulation. Now bioaccumulation is accumulation of that toxin or pollutant in particular organism. I'm not talking about trophic level, I'm talking about organism. So biomagnification, which is also called as bioamplification, it is the accumulation of a toxin or a pollutant at a trophic level. But bioaccumulation means concentration of a toxin or a pollutant in one particular organism. So to explain it simply, biomagnification runs in this direction, bioamplification in a particular organism. Let me just give you through another example. Biomagnification means slowly and steadily. See, this is the primary consumer, secondary consumer, tertiary consumer, higher tertiary consumers. So you will see the accumulation slowly and steadily increasing towards higher trophic levels. But bioaccumulation meaning in a single organism, slowly and steadily the toxin or the pollutant increasing. All right, it is not connected to trophic level. Is it clear? Right. Now, apart from this, when we talk about ecosystem, our ecosystem, it provides us certain services. First of all, because of ecosystem, because of interaction between living and non-living organisms, we get food, right? From forest we get a lot of food. That means they directly provide us a lot of material, like we get food, we get fresh water, we get purification services, we get regulating services, meaning my weather is regulated by ecosystem. The waste material, it has to be degraded, right? You do know about the carrying capacity or the regeneration capacity of the earth. So earth or our surroundings, they have capability of regulating different things, like the air quality can be regulated, the water quality, water treatment, water purification. All these services are provided by ecosystem itself. Cultural services are also provided, meaning we use ecosystems for many purposes. Say for recreational purposes, you go out to a picnic, you have national parks, you have so many other things. It provides you aesthetic value, it provides you religious, spiritual values, right? Apart from that, it also supports human life. It supports plant life, it helps in photosynthesis, it helps in nutrient cycling, it helps in energy cycling. We talk about water cycle, we talk about carbon cycle, oxygen cycle, nitrogen cycle. All these cycles are nothing but recycling of nutrients. Who does it? The ecosystem does it. All right, and that is why we need to maintain our surroundings in a better manner, because if our surroundings are bad, then ultimately we will be having adverse consequences on these services. So we ourselves would be in danger. Say for example, we come up with more number of industries and we do not have means of addressing the industrial effluents, or if we do not treat them and send into environment, then the environment is degraded, and once the environment degraded, I am interacting with it, I am interacting with my surrounding, my quality of life is also degrading. That's the basic idea, that's the ultimate conclusion of this discussion as well. All right, so how do we interact? How do our activities affect our environment? As of now, they are impacting in very adverse way. Now, one of the ideas we'll discuss here, very important from exam perspective, how human activities have impacted the ozone layer. The first thing, what is this ozone layer? Now, ozone layer, it is a part of our environment, it is a part of our surrounding. Higher in the atmosphere, we find a layer of a molecule composed of oxygen itself, O3. Now, O3 is ozone. Please remember, ozone is a gas. Now, ozone gas on Earth, it is a pollutant. Ozone gas on Earth is a pollutant, but ozone gas in our stratosphere, just above our stratosphere, there is a layer of ozone which protects us from harmful solar radiation. It's called ozone layer. The job of ozone layer is to protect us from the harmful, especially ultraviolet radiation which is coming from sun. This ozone layer, it absorbs most of the ultraviolet radiation. It does not allow that to reach the surface, because of which we are safe. Now the question is, because of human activity, we threatened this ozone layer as well. Now what happened? In 1970s, there were some scientists who deciphered that refrigerants that we were using before in 1970s 18, called as chlorofluorocarbons, they were responsible for depletion of ozone. These scientists showed that the chlorine molecule which is reaching to the ozone, it is breaking O3 and it is turning that into oxygen molecule. Slowly and steadily, the concentration of ozone which is present in the ozone layer, it is continuously reducing. The ozone concentration, it is measured in a unit called as Dobson unit, And these scientists proved that because of chlorine, because of bromine, because of halogens that we use halogen based chemicals everywhere. We use carbon tetrachloride in our cleaning industry. We use chlorofluorocarbons in our refrigerants. So because of this, the ozone layer, it became very weak, right? The ozone layer became very weak, and we see big ozone holes. We saw big ozone holes, especially over Arctic and Antarctic. Now there might be a question, sir, why ozone holes found predominantly over these colder areas? Because of other factors which we'll read in our higher classes, mainly because of very cold temperatures and formation of polar stratospheric clouds. Due to formation of polar vortex, these clouds are formed, and these clouds, they become a substrate or become a place for the chlorine to break ozone molecule. And these conditions are ideal over the poles, over the Arctic and Antarctic, because of which we saw ozone hole. And near these higher latitudes, what used to happen, ozone concentration, it became weak. And if the ozone concentration becomes weak, the sunlight enters easily. That means the harmful sunlight, that is ultraviolet radiation, it enters easily. Now the question is, sir, what happens if ozone enters? If ozone enters, then ozone causes more decomposition in oceans. It causes more ocean stratification. It leads to lower productivity of green plants. It leads to skin cancer. It leads to irritation, right? It leads to eye problems in humans. So it leads to changes in the rainfall pattern, how precipitation comes, it changes that. It reduces the snow cover because more amount of heat comes. Because of more amount of heating, snow cover is reduced. So all these things, they had adverse impacts on our environment, eventually impacting us, impacting plants, animals, humans, everybody, impacting the living or the biosphere. So what we did was, we came to know that, all right, because of human activities, because of use of chlorofluorocarbons, we are leading to destruction of ozone layer. So countries came together in 1985, right? If I'm not wrong, 1985, countries came together and signed a Vienna Convention. And they realized that everybody has to reduce the use of chlorofluorocarbons. Finally, 2 years later, Montreal Protocol, where each country came up with a pledge, with some commitments, that we would be reducing our chlorofluorocarbons, and which has shown a lot of improvement. If you look at this, these were some of the targets that were decided, and slowly and steadily they were supposed to be reduced. Chlorofluorocarbons as well, and hydrochlorofluorocarbons as well, CFCs and HCFCs. All right. Now, what happened was, during this Vienna Convention, Montreal Convention, the chlorofluorocarbons and the hydrochlorofluorocarbons, they were eliminated, and they were replaced by another refrigerant which is called as HFC, hydrofluorocarbons, just HFCs. And it was realized that HFCs were leading to global warming. Now this was what I would say, it was quite ironical that through one protocol we eliminated CFCs, and we eliminated HCFCs, right? Let me just correct this, HCFC, and we replaced them with HFCs, hydrofluorocarbons. And later on we realized these hydrofluorocarbons, they do not harm the ozone layer, but they cause global warming. They cause climate change, which is again threatening us. And finally, we came up with Kigali Agreement in recent times. In 2016 itself, we came up with Kigali Agreement, and now we are going to phase down everything. We are going to phase down, see, already we have phased out chlorofluorocarbons, down. Hydrochlorofluorocarbons, this is also down. Now, whatever was replaced, we replaced it with HFC, that is hydrofluorocarbon. And in the Kigali Agreement, by 2047, we are going to phase these down as well, because this is causing us global warming. Then your question, sir, if we are eliminating these, then what are we using? We are using more environmental friendly, more eco-friendly refrigerants, more eco-friendly chemicals. All right. Now, because of this, recent reports have also shown that the ozone layer is slowly and steadily coming back to its original. It might take another 20-30 years. Scientists do say that by 2050 to 2060, ozone layer would be regenerated, or it would be proper what was there before the use of CFCs, the chlorofluorocarbons. All right. Right. One of the issues is ozone layer. Apart from that, the second biggest issue that we face is how do we handle our garbage. Now, this has become a huge problem these days. How we handle our garbage? Do we segregate it? Do we use, or do we decompose the organic waste, or do we segregate our waste into organic and inorganic? Right? If it is inorganic, can we recycle it? All these things have become very important. Solid waste management has become a big challenge for metropolitan cities, big cities, for everybody, in fact at the village level also, everywhere. How do we handle our garbage? It has become a big issue, and that is why they say, especially because of use of plastic. Plastic is something which does not biodegrade. It stays in the environment for years together, and we have seen so many problems. If you talk about plastic dump or plastic mountain is there in an ocean now. Animals, when they eat plastic, it gets stuck in their alimentary canal, which leads to other disorders. Plastic, if you burn, it leads to production of dioxins, which creates a problem of air pollution. So how do you handle it? How do we resolve this issue? That is the biggest challenge in 21st century as of now. That's why they say use the 4R mantra. Refuse plastic, reduce the use of plastic, and recycle plastic more and more. There is one more R of reuse. If you are able to reuse, repair, and reuse it, then it is very good. And there is one more R which has been added in recent times, remind. Meaning, if you are aware of these 4 R's of refuse, reduce, recycle, and reuse, then remind others about this as well. Stop using plastic. That way, we can protect our environment. And if we protect our environment, our surroundings, ultimately, we are protecting ourselves. All right? Right. So, that's the basic theme or basic idea from this particular chapter. All right? Management of resources or sustainable management of resources. Now, in our previous discussions in class 9, class 8, class 7, we have discussed about natural resources. We have discussed about forest, wildlife, air, water, soil, right? Petroleum, coal. We have discussed all these things. And we need to understand that these natural resources, they just do not belong to us alone. That means not just for this generation. That is why we use the term sustainable management of natural resources, meaning living in harmony with the nature, living in harmony with our environment. And this concept is not new. Although I would say the term is relatively new because we have been using it from 1970s, or to be very precise, from the Rio Summit 1992. Sustainability, sustainable development, sustainable use of resources. All right, we are talking about refuse, reuse, reduce, recycle, all these things. But it has been a very old concept. Living with harmony with the nature, or living in harmony with the nature, it is a concept which is available inherently in Indian psyche, inherently in the Indian way of life. In many of the ancient texts, we find the mention of Vasudhaiva Kutumbakam. In fact, this Vasudhaiva Kutumbakam, which means the entire earth is one family, this phrase has been mentioned in the Maha Upanishads, which is a part of Atharva Veda. All right. So we have this idea from before itself, but in the 21st century, it has gained a lot of traction. Now, the question is, sir, you said sustainable management of natural resources. So I have to manage them. I have to manage natural resources. That you're telling it. I'll try to understand what is that management. But what are these natural resources? We find two kinds of natural resources. Exhaustible resources. Exhaustible means which exhaust quickly and which take a very long time for replenishment. Meaning, once I finish it off, for getting them back or to get them back, it takes millions of years together. The example is coal, petroleum, or other mineral-based resources, because it takes time for their formation. For this, I don't need to explain you, right? Why do we have to conserve them, or why do we have to use them judiciously? Because once they are over, then I will not have that. There would be shortage of it. The other kind of natural resource is the inexhaustible natural resource. Inexhaustible means these are renewable, these are replenishable, meaning it does not take very long to replenish. We have so many sources. We have water, we have air, we have sunlight, right? We have so many renewable sources. Now you must be thinking, sir, you told that we need to manage these sustainably, we need to use it judiciously. It makes sense with this, but I don't think it makes sense with this because we have plenty. So use it in a non-judicious way. But we have already understood what is the problem with it. In our previous discussions, we have understood water. Of course, water is available in very large quantities, but how much of that water is potable? How much of that water is usable by humans, by plants, by animals? It's very small amount. A large amount of fresh water is stuck with the glaciers, and we have a very small percentage of Earth's water which is available for our drinking purposes or our purpose, our day-to-day activities. Because if we do not conserve that judiciously, already underground water is going further down because we have overexploited it. We are not conserving water, so the water, the fresh water, is now joining the ocean. So we need to ensure that we need to bring some sort of water harvesting methods. Same concept with air. We have been exploiting the air-based or atmosphere-based resources too much. We have passed so much of carbon dioxide, so much of sulfur dioxide, so much of nitrogen-based oxides into our atmosphere that it is leading to pollution. It is ultimately leading to health problems for humans, for everybody. So you need to understand, yes, I have to use this judiciously. I have to use this also very judiciously. Clear? Right. The next question, sir. Okay, why manage it at all? Especially when it comes to inexhaustible source, or I would discuss for both. All right. That's why we use the term sustainable. I'll also try to explain what is the meaning of sustainable here. Okay. Question is, sir, why do I have to manage them? Why do I have to manage them? I would say it has to be understood from 3 dimensions. Now, we all think that whatever resources we have, we think it is available only for us. That means, see, I am living right now in 2023. But you need to understand that these resources, they do not just belong to 2023. These resources have belonged to our ancestors. They belong to us. They must belong to our future generations as well. Do you understand that right now you, me, everybody is breathing the same air that was probably present billions of years before or millions of years before, whatever term you want to use. And the same air would also be available for the future generation as well. So first thing is we need to maintain that intergenerational parity. That's why we need to use them judiciously. Now it has to be taken from 3 angles. First of all, say even if you are using, you will say that, sir, I am using it. Let me use it. Fine, right? Let me use it. The future generation will take care of themselves. That violates the principle of intergenerational parity, first of all. But apart from that, if you are also using it, ensure that you are using it in an equitable manner. Meaning, the current resources that we use, they are first of all available in a very inequitable manner. Gas resources are very rich, say in Middle East, some other resources somewhere else. So ensure that there is equitable use of these natural resources, meaning people from same generation, at least they should get that equitability, but that does not happen. Meaning, first you need to ensure equitability. Now, the second idea is to ensure that the future generation that also has these provisions. All right, we need to ensure the future generation progeny, they also have these resources. And the third aspect, even if you are using it now, ensure that you use in such a way that the environment is not damaged. Environmental care is very, very important. So these are the 3 angles or the 3 concepts which are connected with sustainability. That's why we say, whenever we talk about the concept of sustainability means we have to use these resources in perpetuity, not just for one generation, but we have to provide it for everybody. So right now, this generation, use it equitably, use it with some sort of common sense so that environmental damage does not occur, and ensure that you leave you leave properly for the future generations as well. That is the meaning of sustainable management of natural resources. Clear? And now I don't think I need to explain you why do we need to manage resources. We need to manage them, be it these exhaustible or inexhaustible, ensure that environment's regeneration capacity is always maintained. Clear? Right. Now, I have already made a case that we have natural resources, we have to use them judiciously. So how are we using them? Right now, we have one natural resource, forest and wildlife. And now you think, sir, forest and wildlife, how do we use them? See, we use them for many services. First of all, direct services. We get food, we get timber, we get other services, we get recreation services. Wildlife, yes, wildlife is very important. We talk about the concept of biodiversity. These forests are hotspot of biodiversity. Everybody uses it. There are different stakeholders, people who are living in the forest, industrialists, they want forests, environmentalists, they want forests, people, they want forests for their recreation. But we are not using them right now in a judicious way. Why? Because there is heavy amount of deforestation as of now. There is a lot of pollution also. We see that forests are being cut for agriculture purpose. Forests are being cut to set up the industries. Forests are being cut for timber. Forest provides us so many services. And all those services would be lost. First of all, forest is a home for people, for tribals. Forest is a home for animals. That habitat would be disrupted. Forest has a large biodiversity, but if I cut it, it's gone. Forest has a lot of natural resources. It has flora and fauna. When I cut it, it's gone. And that's why everybody, if you ask any environmentalist, I would say don't even ask them. It's a concept of common sense. Forests are needed to us. Forests are like the lungs of Mother Earth. And if we do not use them judiciously and in a sustainable way, what will happen? The problems of global warming, the problems of climate change, the problems of natural disasters increasing more and more. So disasters, deforestation, they contribute to the climate change, and the solution to the climate change is also forest only. So use them judiciously, use them in a sustainable manner. Right now, if we see who are the stakeholders involved here, first of all, people who are in the forest, tribals, the government is a stakeholder, the industrialists want it, they want to create or they want to get products from the forest. Wildlife enthusiasts, they want it in a purest form. So everybody is battling, everybody has their own idea, and we need to balance these interests. That's why as a bureaucrat, as a civil services aspirant, you will be entering into administration, and throughout your life you will be facing this constant problem or constant dilemma, I would say, of balancing economic development and environmental protection. So different stakeholders are involved, different stakeholders have to come together to safeguard these forests, to conserve these forests. And if we have to protect them, we need to follow the forest management principles. We need to protect the diversity. We need to ensure that we use it sustainably. We need to ensure that the edaphic factors and the hydro-based factors, they are used sustainably. The forest ecosystem, it ultimately contributes to the ecological cycles. Climate change can be countered by increasing more and more forests. Of course, use the benefits, but use them in a sustainable way. But if we become more greedy, see, the idea of sustainable development was very beautifully explained by Gandhi. He said the world has enough for everybody's needs, but not for greed. And once greed increases, then what happens? Then people will fight for their rights. People will fight for forests. The same thing happened in Uttarakhand. We have seen that the different stakeholders, they try to exploit forest and wildlife, especially industrialists, right? So to fight it or management of forest, people are one of the most important stakeholders. All right. So people, they come together, or they came together in many of the movements. One of the movement was the Chipko movement in 1970s in Raini, in the Garhwal region in Himalayas, where one of the contractors came to cut the forest. So people hugged every individual, they hugged one tree, and the contractor had to go back. So this started, or this, I would say, this lit a fire in India of the environmental movements. After that, we have seen so many movements: Apiku movement, Silent Valley movement, Jangal Bachao Andolan. and some other environmental movements as well. So if such movements are not needed, or I would say if people are not involved, then one of the stakeholders would take benefit of it. For example, the industrialists who exploit the forest the most. All right. So this has to be stopped. That's the basic idea. Now the second natural resource is water. Water is for all. You do know that. But despite that, water has to be used in a very efficient and a judicious manner. Why? We have seen it. Although water is available in plenty in our hydrosphere. Yes, when you say biosphere, hydrosphere is a part of it. But most of the water is in oceans, which is not potable. And whatever freshwater sources we have, be it underground water or the surface water, which is rivers, lakes, ponds, etc., they are getting polluted. One of the classic example is the Ganga water pollution. Now, the Ganga water pollution has been a major problem. Ganga runs its course for about 2,500 kilometers, starting from the Gangotri. It moves through multiple states and ultimately drains into the Bay of Bengal. Now, throughout its course, we have seen that especially in Uttar Pradesh, in Bihar and West Bengal, there have been so many towns, cities, so many industries that have come up who release their runoff, who release their wastewaters in Ganga, which has led to pollution of river Ganga. And when we talk about pollution, we can assess any river's health by the presence of bacteria, that is coliform bacteria, which leads to basically food poisoning in you. The coliform bacteria should be in low amount, or we can also assess the pH of the river. And since 1980s, we have understood that Ganga has become very polluted. Why? If you look at these numbers from 2007 to 2011, the CPCB, Central Pollution Control Board data, it clearly suggests that the bacterial coliform, which is one of the measurement for the pollution level of a river, it has been consistently high. It has been consistently high in many parts, especially in the downstream. If you look at Roorkee, Kanpur, Varanasi, etc., right from Uttarakhand to Uttar Pradesh to Bihar to West Bengal, we have seen the bacterial number, or the bad bacteria in the water is in very high quantity. Now, this is the standard which has been set by CPCB. But ideally, what people tell is the water, or I would say the drinking water, it should have less than 10. It's basically said 10 amounts to one colony of coliform bacteria, and it should not have E. coli basically. So coliform bacteria less than 10 is ideal. But the CPCB set level is a little higher than 1,000. But look at the pollution in different stages or in different stretches of river Ganga. We have started so many programs, right? We have started Namami Gange program, the Namami Gange program, Mission Ganga, Mission Clean Ganga. So many missions have come, but we are still struggling to clean Ganga river. Right? That means water has to be used judiciously. Water resources have to be treated. That means industrial effluents that are now released into Ganga, those have to be stopped. The runoff that goes from even household, that has to be treated, and then eventually can be left out in the river, because you do know that every river or Mother Earth has regeneration capacity. But right now what we are doing is we are exploiting that level itself. We are releasing so much of garbage, so much of waste in a river that it cannot regenerate itself in its normal course. Why? Of course, because of population increasing, because of increasing population, because of demands increasing, because of so many industries that are coming up. So that means water, which is a basic necessity for terrestrial form of life, it is now being polluted, be it underground. Look at the problems with underground. We do not have solid waste management system. The waste, it seeps into underground aquifers. We are consuming that only. The waste from septic plant, it leaks. Waste from the runoff, it leaks. Surface water, forget about this. I don't need to explain about this, because you go to any beach, go to any river, go to any lake, you will find so much of plastic, so much of garbage around there. All right. Now you clearly understand that water, it is, yes, inexhaustible resource, but fresh water, I would say, it is always short, and we have to use it in a judicious way. And to ensure that we have proper drinking water facilities, we have water for our educational, agricultural needs, etc., we have brought so many measures. For instance, we have created big dams, right? We have created big dams. Of course, India gets a lot of water as rainfall, which is pure form, yes. But when do we get that? We get it in, say, 3 months, 4 months. Right now, from, say, June to August, June to September, probably we get intense rainfall. Most of that rain, it it goes underground, and large amount of that rain eventually reaches to the oceans itself. So we need to conserve that. Now, how do you do it? We do it through dams. We have constructed big dams. There is a dam near my place also, which supplies water to the urban areas. But these dams, on one hand, they have a lot of benefits. Yes, water from these dams can be used for irrigation. Water from these dams can be used for water supply to the urban cities, right? To my city, water comes from a dam itself. Water from dams can be used to generate electricity. Yes, it has a lot of benefits. But creating dams everywhere, is it feasible? Because it leads to many problems. First of all, it leads to societal problems. To create a big dam, I would need thousands of acres of land. That means I would need to resettle many people. If it is a forest area, I have to cut that forest. And I understood forest is a very important natural resource, right? So it has societal impacts, it has environmental impacts, it has even economic impacts. The dams itself, they cost huge amount of money. Multiple thousands of crores are needed to construct a dam. People have to be moved, people have to be resettled, forests have to be cut, biodiversity is lost, forest is lost. So there are disadvantages. So a better solution would be to ensure that we have some sort of traditional means of water harvesting or traditional means of conserving water. One of the examples is the kuls in Himachal Pradesh. Kuls in Himachal Pradesh are a local system of canal irrigation which have been used for almost 400 years. Apart from these kuls, we have so many others rainwater harvesting methods. If we harvest rainwater, water harvesting methods, if locally or traditionally they are used, it's much better than constructing a dam itself, isn't it? And in many areas we do use it. For example, they are called by different names in different areas. They're called khadins, tanks, nadis, bandaras in Maharashtra. This is a small map which shows you the nomenclature. Sometimes MCQ can be formed regarding these names. Traditional water harvesting system in Kerala is called Surangam. In Tamil Nadu, Eri, Urani. In Karnataka, there are Keres, right? There is a scheme also running in Karnataka, Keres Sanjeevani, to rejuvenate these local tanks, local ponds. In Maharashtra, it's called FUD Bandara. Bandaras are basically water harvesting systems in your agricultural land, right? At the border of your land. Apart from that, you have Vav and Virdas in Gujarat. You have Kul in Himachal Pradesh. I already told you there is Bauli, Johad. Johad is also seen in Rajasthan predominantly. Kunds in Uttar Pradesh, Kata, Bandha, Dabri in other areas. Even in Northeast, you can find Apatani, Zabo, Ruza. These are some of the methods of traditional water harvesting. So we need to promote them more and more. Why? Because this is one of the ideas of sustainable use of these water resources. All right. Right. Now, apart from this, we also have exhaustible resources. Now, we have discussed about this. Coal and petroleum, how they are formed. I told you, coal is formed after millions of years. Initially, there would be forest or plant-based biomass. Once it goes under, once it is compressed for millions of years, ultimately it leads to formation of coal. Similar thing with petroleum. For petroleum, it is basically marine organisms or marine animals. After millions of years, plant and animal remains that are left underwater, they become, or they turn into fossil fuels, that is petroleum and natural gas. And we do know that they are available in limited number or limited quantity, meaning we need to use them very judiciously, very in a very, or I have to come up with some measures or means to reduce the usage of these fossil fuels, so that I have it available for the next generations, for the future generations as well. Because to form that coal, it will take millions of years. It will take millions of years in future. So what can we do? We can come up with some methods. For instance, See, coal itself, it leads to a lot of air pollution. So what can I do? I can turn coal into some sort of gas form. First of all, burning coal itself can be avoided, and we can convert that into liquid fuel or say gas fuel, right? The coal gas through gasification methods. When we are extracting coal and petroleum, ensure that the wastage is not there. You do know these are highly inflammable. That means it catches fire very quickly. Ensure that wastage through fire, it does not happen. Ensure that transportation of these fuels is done in a very sound manner. Ensure that you use fossil fuels in a very sound manner. So for example, if your vehicle, ensure that your vehicle has proper tire pressure, it is properly serviced, then it will consume less amount of fuel. I am conserving that fuel only. So avoid wastage pollution. Check over consumption of fuel in automobiles. This is one of the ideas. And apart from these fossil fuels, or I would say exhaustible resources, use inexhaustible resources. Try to promote solar energy, try to promote wind energy, try to promote geothermal energy. So that we use less amount of coal, less amount of petroleum, less amount of natural gas, and it is available for the future generations as well. All right, now that is the idea of sustainable management. Remember, although we have discussed only forests, water, and coal and natural gas, but sustainable management of resources is needed everywhere, with respect to soil, with respect to minerals, with respect to rocks, with respect to food that we eat. Forest and water has already been discussed. Everywhere sustainability has to become the concept. It's the buzzword in 21st century, and that's why it's not just the duty of one individual. Of course, we can play whatever role is there, but all the stakeholders have to come. You, me, the state government, the central government, the international players, the international organizations, they have to come together, and they have come together to give us UNDP, United Nations Development Program. UNDP, United Nations Development Program, and the Environment Program. They have basically given us many sustainable development goals. UNDP sustainable development goals like sustainable development goal 3, 6, 7, 9, 12, 13, 15. They all talk about sustainable management of natural resources. All right. Good health and well-being. It is one of the sustainable development targets. By 2030, ensure this is achieved. Clean water and sanitation, another sustainable development goal. We have affordable and clean energy. If we go for renewable energy, then the pressure on coal and petroleum would be lower. All right. We want to build industry and infrastructure in such a way that it is sustainable, meaning I reduce my AC requirement. That means I reduce my electricity requirement. Ultimately, from right now, majority of electricity comes from coal-based power plants only. So if I reduce my electricity consumption, then coal consumption would be reduced, right? Apart from that, responsible consumption and production. Yes. Life, climate action, 13, climate action, SDG 14, life below water, SDG 15, life on land. What are all these? All these are development goals which have been finalized by international organizations and the nations involved here to ensure that Mother Earth would be safe, Mother Earth would be pristine, and we fight global warming and climate change. That's the idea of sustainable management. That's the idea of sustainable development globally. All right. And I hope we achieve it. And I told you, it's not just top down, it has to be bottom up as well. Of course, international organizations are involved, but every person has to do their bit. So ensure that when you're shaving, do not put the tap on continuously. When you're leaving your room, switch off all the appliances, switch off your fan, switch off your light. Try to reduce the use of plastics. Do not use the plastics when you're going out. Carry a jute bag for the equipment, carry the jute bag for your stuff. So these are the things that you can do. Try to reduce your fossil fuel consumption. Ensure that your bike has proper tire pressure, it is serviced, right? Try to use public transport wherever it is available. So all these are some of the means of sustainable management itself. Hope we achieve it. All right. Right. With that note, this is the end of discussion, and this is the end of NCERT Class 10 Science textbook as well. I hope that you have enjoyed this series. Thank you very much for watching this, and if you have liked this, You can always follow me on this particular ID. You can contact me on this ID anytime if you have any queries, not just regarding NCRTs, but regarding exam preparation itself, regarding UPSC Civil Services or your state PSC or any other thing. Just like that, if you want to drop a message, you can drop me a message on IG. I do respond on Saturdays and Sundays. Thank you very much for watching this again. Jai Hind.